Today, you're going to learn exactly what React.js is, and we're going to cover some core concepts of React.js like components, JSX, interactivity, whether you can use React full stack, how React is just a library, the community around React, job outlook, and all of those things regarding React.js. This video is going to be the first video of a full course on React.js. So if you're just getting into React.js, or maybe you went away from React.js and you want to get back into it, this video is going to be good for you. So what is React? Well, React is just a JavaScript library for building user interfaces. And before we go further, this is a web page that I created just to help me present this video. Is not somewhere you can actually go and see, but if you're interested, definitely leave a comment below and I can give you the code to this website if you're interested. But React is a JavaScript library for building user interfaces both on web and mobile. The library is just some pre-written code that provides somewhat of helper functions and other tools to build whatever you're looking to build. So React, it uses JavaScript to help users build user interfaces, which a user interface is what the user actually sees. So what we're seeing here on this page, we're seeing 3 columns of 3 different rows in this grid layout with these cards that flip around and the user can interact with these cards. I'm using React to build this user interface, what the user actually sees and interacts with. React is a JavaScript library, so it uses JavaScript, and you also use JavaScript within React, where you can build what the user sees on a web page or even on mobile using React Native. And you do that through using some of the pre-written code and structures that come from this React.js library. Now, before diving into React, what should you know? Well, React, it fundamentally builds on the web or native. So if you want to build web apps, it's going to be really important for you to understand fundamentals when it comes to HTML, CSS, as well as JavaScript. Now, if you're building natively, so you're building mobile applications, then in those cases, there's a little bit less CSS that you'll need to know, although depending on what mobile route you go, you can use stuff that kind of looks like CSS. But regardless, when using React, understanding HTML, JavaScript, and how to style applications is going to be important. Now, you don't need to necessarily know everything about how HTML works and CSS and JavaScript. I've been working in React for several years and I still don't know everything when it comes to HTML, CSS, and JavaScript, at least not off the top of my head. But you should know the fundamental concepts of how those technologies work. I think you should be able to build at least kind of basic websites using just JavaScript, HTML, CSS. You should understand how the DOM works and how to manipulate the DOM. All that stuff really does come in handy when using React. And sometimes when using React, you run into an issue to where maybe the only way to solve it or the best way to solve it is actually using some sort of DOM techniques or basic fundamental web development techniques. So before learning React, I would at least have a fundamental understanding of JavaScript, HTML, and CSS. Now, heading into some core concepts of React, React uses this concept of components. React lets you build user interfaces out of individual pieces called components. And then you combine these individual pieces into entire screens, pages, and applications. Don't let components scare you because they're really just JavaScript functions that return some sort of your user interface or a piece of your user interface. So in our little web page here that I used React to create, I created a component for a card that you see here that kind of does this flip around animation, and you see it render a title. And then when I hover over it, it renders some content. And you can see that I reuse this card for all of these different titles and content throughout this page. These are all the same card components that I use kind of throughout this web page. So this is a single component that I just reuse everywhere, which is a fundamental of React. You create these single components that you can then reuse throughout your entire application. So if I had other pages in my application or different sections of my application, I might want to use a card component that looks just like this one. Well, in that case, I can create a JavaScript function that just returns some piece of UI. So this card is a piece of UI, and then I can use that within my page, and then you can combine those components into an entire page or an entire application. Now, when I say return some UI, what you are going to return from these JavaScript functions, these components, are actually JSX. So this is another core concept of React. So React uses something called JSX, which it looks a lot like HTML, but it's actually just JavaScript, which it can be a little bit tricky at first, but you might come to really like combining your JavaScript and HTML all in the same file. Let's go look at what my card component actually looks like here. So this is my card function here within React.js that I used to build this website. You can see it has a title and content, and then we'll get to interactivity here in a second. But what it returns is a div, an H3, a p tag, on mouse enter, on mouse leave, and it's just a JavaScript function here. So const card is equal to an anonymous function that returns this, what looks like HTML. But this is actually, this right here is JSX, which I'll of course have their own dedicated videos on. But it looks a lot like HTML, but it's actually just JavaScript that gets converted into HTML, which allows me to use JavaScript within this JSX. And then I export this card component here and use it throughout my application. So you create these functions that return some, what looks like HTML. It ends up being HTML, so you can think of it like that for now. But it returns some JSX that gets turned into HTML. And this is a piece of your UI that you can then reuse throughout your entire application and build pages with several of these different components. And then you can compose these components together. You can pass certain components into other components, nesting components, and we'll get to all that in future videos. So JSX is a HTML-like syntax where it's actually just JavaScript that gets converted into HTML, but you get the benefit of being able to use JavaScript logic right within your HTML, which can come in really handy. Now, as I alluded to, React also has interactivity, so it provides different ways to allow the user to interact with your web page. So like what you can see I'm doing here, I'm hovering over these elements to see the content of them. You could also click a button and immediately see some sort of output on the web page. React allows good ways to manage this interactivity from the user and allow for very responsive app-like web pages and even native apps if you're using React Native. Here you can see I'm using something called useState from the React library, and then I'm just managing whether the card is flipped or it's not flipped. So if they hover on it, on mouse enter, I want to set the card to is flipped is true. But when they leave the card, I want to set is flipped to false. And then we're using this logic here within our styles, within our HTML or our JSX right here. So React gives you ways to handle different interactivity within your web pages. And I'll of course have dedicated videos on how state works and how these functions from React actually work. But it provides nice ways to handle interactivity. Now, React, it helps build user interfaces, but you can also build full stack applications in React. And it doesn't necessarily do this out of the box with just using React.js. Now you could use React as your front end and then use like Django REST framework as your back end. I've created products to where I do just that, but more common ways these days to do that is using a framework, a full stack framework in React that will allow you to do that. So that's going to be something like Next.js or a Remix those are two common full stack frameworks that people use to build full stack applications. So both the UI, which would be front end, and then also like database work and API work, that would be more back end work. And combining the front end and the back end is considered full stack. So you can build full stack applications using React. You might just use something like a Next.js or Remix or even like Django as your backend, because React is really focused on just building what the user sees, the user interface. And kind of on that note, React is just a library. So it lets you create these components for your user interface, but it doesn't prescribe how to do routing, so how to manage different pages in React, going back and forth between pages, really linking between pages. And it also doesn't really prescribe how you should do data fetching. So if you need to get data from a certain API endpoint or your own database or whatever it might be, React doesn't really prescribe the best way to do that. However, like we just discussed, React can still be used for those full stack applications like Next.js and Remix that do provide more prescriptive ways to do data fetching and routing. Like I'm most familiar with Next.js, and I have a lot of videos on this channel about Next.js, but Next.js provides you more prescriptive ways to do routing, like Next.js has built-in routing, which I actually really like. And then it also has ways to do data fetching, and it kind of prescribes different ways to do that. Now, I'm sure Remix has very similar things, but I'm just a little bit less familiar with that full stack framework because there's only so much time in the day. Just keep in mind that React is just more so like a UI library to build user interfaces. It is less concerned about routing between pages, data fetching, doing API stuff, and all that sort of thing. But there are frameworks that build on React to do that stuff. Now, a couple of reasons why I really like React is, for one, it has a great community behind it. So React is very popular. It's used by large tech companies like Facebook, Instagram, Airbnb, Netflix, Reddit, Shopify, and I think Codecademy and several other larger companies. At least through my research, I found that these companies use it, which I know that a lot of large professional companies do use it. So you can definitely build very cool applications using it. Now, the benefit of this community isn't just like bragging rights, but it means that if you get stuck on something in React, there are a ton of resources on how to get unstuck. There's probably a blog post on the exact issue you're running into. There's a ton of different resources on how to do data fetching and routing and all that stuff if you're just using like vanilla React, so to speak. So there are a ton of resources, which, you know, if I was just starting out developing, I'd be like, who really cares? But if you're building a professional application that you're planning to maintain, having resources for that library and having a good community around a library is really important, and React definitely has that. Now, to this day, if I was going to learn a JavaScript library, I would learn React. And some reasons for that is because in the 2024 Stack Overflow survey, it puts React.js as the #1 most used framework for professional developers. And I don't even think it's really close between React. I believe it was like 39 or 46%. And Angular was the next kind of closest JavaScript library at like 19 or 20%. So React, very much so used by professional developers, which means that there's a lot of jobs for React. And in searching LinkedIn in the USA, which is where I'm located, for React.js, you see 39,000 plus open jobs there. Now, of course, not all those are going to be like entry-level jobs, and there's like running jokes that entry-level jobs these days require like 3 years of experience, but that's a whole nother topic. But what I'm saying is that when it comes to JavaScript libraries, I think React is definitely towards the top, if not the best, by a pretty decent margin in terms of job outlook. And if I was looking to get a job as soon as possible, React would be my JavaScript library of choice. So hopefully that gives you a good overview of kind of what React is, a few of the core concepts around components, JSX, and interactivity, whether you can build full stack or not, how React is just kind of a UI library, the community, job outlook, all those things. I hate to admit this because some people really don't like it, but I actually kind of really like JSX. And once you understand it and once you get the hang of using JSX and you keep in mind a few kind of simple notes and rules of JSX, it's really not too tricky to use. And I think you will end up liking it. So we're going to cover all that in today's video. What it is, a few rules to keep in mind, and a couple of notes to keep in mind. And this is just going to be a nice kind of quick guide to using JSX and a few things that have really helped me along the way when using React and JSX for several years now. So first off, JSX, it is a syntax extension for JavaScript that lets you write HTML-like markup inside a JavaScript file. So here, this is just a template Next.js application where they just template out this home page right here. And this is in React because Next.js uses React. So this is just basic React code that you would even see in like a Create React app. This would still work. This right here, it looks a lot like HTML, but we're in a JS file or a JavaScript file. This is technically a JSX file, but this would still work all the same if this was just in a .js file. You can see there's no errors thrown. This is still all valid code here. So if you're new to React, you're like, man, this is weird. You're rendering HTML in a JavaScript file. Well, not really. This looks like HTML, but it's really just syntactical sugar at the end of the day. And what this really is just syntax that eventually just gets turned into JavaScript code. And this JavaScript code will eventually do things like what you've probably done in vanilla JavaScript applications to where you do like dom.create element. I totally forget a lot of those methods at this point, but you're going to be basically creating JavaScript or using JavaScript to create these HTML elements. But here you're just writing the HTML and it's just syntax over the JavaScript that actually is going to create all of these elements. So at the end of the day, this really is JavaScript here, which is why it works in a JS file. And if you look at my running application here on localhost, you can see like this renders, it works. The reason for that is because in this JS file, this really is JavaScript. It's just HTML-like syntax that on the surface looks like HTML, but it gets converted to JavaScript, and then that JavaScript will create all these elements and then kind of inject them into the DOM here, which is what you're seeing on the page. So here you can see like get started by editing app/page.js, get started by editing app page.js, and then you're also going to be able to see like this Vercel logo. So that's what's kind of going on here. Now, there are some rules of JSX that you need to keep in mind. So I'm going to remove pretty much all of this. So I'm going to remove everything but this main tag here. And I'm going to change this back to a JSX file because I get better code completion. But just know that this is the same thing as having a JS file for the most part for our demonstration purposes. So I'm going to just have an H2 here that says my JSX tutorial. Now, this is totally fine, but one of the rules of JSX is that you need to return a single element. So what that means is, and this is a React component, but we need to return a single element from this component. So if I try to do like a p tag down here below and say, this tutorial is so great, you're going to see that JSX expressions must have one parent element, because what I'm trying to do here is I'm trying to render this element directly next to this element. So these elements are on the same level. They are siblings of each other. So there's not one overall parent element that I am returning from this function. So this JSX has two separate elements. Now, the reason you can't do this, and I feel like a lot of videos don't explain this part, but the reason you can't do this is because at the end of the day, this React component here is just a JavaScript function. And this JSX, it gets rendered down into JavaScript objects. And what we're basically trying to do here is return two separate JavaScript objects from a function, which wouldn't make sense. Like if we just had function, sum, function, and this is just a JavaScript function, and I tried to return two separate objects next to each other. So if I tried to return curly braces, and I'll just say sum property is equal to 2, well, that works because I'm returning one object. What if I try to return a second object? Another property is 4. Well, I'm going to get an error here too, because here it's like I expected a comma, not another object. So in JavaScript, and I realize I spelled return wrong, let me return that. But here you're going to see I still get the same thing. I get unreachable code detected, which is an error that actually makes sense more. But I'm trying to return two objects from this JavaScript function, which it just doesn't work. And that's the same thing I'm trying to do here. I'm trying to return this JSX, which gets converted into a JavaScript object. And then I'm trying to return this JSX, which gets returned as a JavaScript object. And that's the same thing as like trying to do this, which doesn't make any sense. It also doesn't work. So the way to fix this would be the same way that we would fix this JavaScript function. Instead of returning two objects, well, we could return like an array that has these objects within the array, and I'll separate these by commas, and now this function will work just fine. It would return an array of two objects. So it's still returning one thing. And very similarly, in our React component, instead of returning two sibling elements here, we could just put one of the sibling elements within the other. So this will now work because the p tag is now a child of the main tag. So this main element here is wrapping around this h2 and this p tag, making this be a valid element. And if I go to our browser, we can see JSX tutorial. This tutorial is so great. And then if I come back, another way to fix this would be say for whatever reason, and this wouldn't make sense semantically. Well, what if I wanted this p tag to be a sibling of this main element? What if I wanted to keep that structure? Well, we can do that. We would just need to add some sort of wrapper element. So you'll often see people throwing around divs a lot in React and then placing those elements within a single wrapper div is what you'll hear it be referred to as. And I'll make sure to indent these to make them a little bit more clear. But now what you're going to see is that we have our main tag as well as our p tag. They both get rendered within this wrapper div. So we're still returning one JavaScript object, but we have these two objects nested within them, which is totally fine as well. Now, if you want to maintain HTML semantics and you don't want to just return a bunch of wrapper divs, you can also use what's called a React fragment. So this would be a React.fragment. It gives you that out of the box, which basically allows you to render a wrapper element, but it's not going to actually render anything to the DOM. So if I save this and I see React is not defined, so let's go ahead and import React from React. But if I look at the DOM here and I inspect this, all I have is a wrapping main tag here. So I have a main tag in my p tag. I don't have anything. I have my body tag here, but I don't have anything wrapping my main and p tag because a React fragment isn't going to render anything to the DOM. And shorthand for a React fragment is just using empty arrow brackets. So you can use empty arrow brackets, and that's the same thing as a React fragment. You're going to see this also renders out. If I rendered out a div here, what you're going to see is that it does add that to the DOM. So if I inspect this again, I have this main tag. You see it now has a wrapping div around the main tag. So it does add that to the DOM. So a nice way to return a single element and abide by that rule of JSX is by making sure that you are using like a React fragment or some sort of wrapper element. Now, another rule of JSX is that you must close all of your tags. So HTML has the idea of self-closing tags. So for example, for W3 schools here, for this image tag, you can see that it has no self-closing slash. So in our app, we can see like this paragraph, it closes it with a p tag right here. This div, it closes it with this div tag, and it has this / to close the element. But in HTML, you don't need to close all of your elements. There's certain elements that are self-closing. So this image tag would be totally fine, and it would work even without a closing slash here. But if I try to use an image tag like this in JSX, what we're going to get is JSX element image has no corresponding closing tag. That's because you need to close all tags in JSX. So if I just put a / here before the closing arrow bracket, we're going to see that this compiles and it works. And if I go to localhost, you see this beautifully styled page with this. I always love these vertical scroll bars. You can see we do have an image down here below. So it does indeed render the image when we add that self-closing tag. And then just for a little bit better styling here, let's move the P and image tag up into this main tag like so. And then I also justify center, and that should, at least allow us to see it. So we see we rendered this image successfully with the closing tag. So make sure to not try to use self-closing tags like we see here with image tags, and there's a few other HTML elements that work like that. Make sure to close them all. Now, in addition to this, you're going to see that in HTML for attributes, they're all going to be like lowercase. And that's somewhat true in JSX. Like this is lowercase, this is lowercase, this is lowercase, these attributes, that's fine to do. But what you're going to see is that for 2-word attributes, they're going to be camel case. So, or at least for the most part. So for this class name, it's going to be camel case. It's going to be class and then uppercase name. So instead of using just like class in HTML, it's actually going to be class name in JSX, because in JavaScript, class is a keyword. Like if you're going to create JavaScript classes, you're going to use a class keyword in front of your JavaScript class. But since JSX gets compiled down into JavaScript, well, we're trying to add like a class for CSS styles. So what we actually want to do is use class name, because we don't want to run into those conflicts of JavaScript keywords. And the same is going to be true for other attributes. So like if I used the attribute like stroke width, it would be lowercase stroke and then width. So it would be like stroke width, like so. Or if we add an on click, so let's do a button down here. And then for this button, if I do on click, and then you see my autocomplete for all these are all going to be camel case. On abort capture, on animation start, on aux click. All of these are going to be this camel case syntax. So if we did something like an on click, you see it's not like HTML where it's just on click. It's going to be camel case. All right. So keep that in mind. Camel case for attributes. And then also when it comes to certain like JavaScript keywords like class, you're going to use class name instead. And that's actually going to be the same for this image tag as well. We would use class name instead of class. So 3 rules to keep in mind But we do have a few more things to note here. So in JSX, when you are passing strings as attributes here, so for this class name property, it's okay to just pass it in quotes here. SRC, we can pass it in quotes. This alt, we can pass it in quotes. But what if we wanted this to like be a JavaScript variable? So let's say, I'm going to say const main tag classes is equal to, and then we'll set it equal to this string. Say I wanted to use this variable as my class name attribute. Well, the way that you can do that is just put it within curly braces. So I'm going to remove these quotes and I'm going to just add curly braces and then add those classes. So if you want to use a JavaScript variable as an attribute, you can put it in curly braces. And you're going to see within localhost here, everything remains the same for our classes. Nothing changed. So this is indeed working. So if you want to use JavaScript variables within attributes, wrap them within curly braces. Now, you can also add some logic here with the curly braces. I'm basically saying in JSX, I want to enter JavaScript land. So anything within curly braces is telling JSX that I want to be able to use JavaScript logic. Now, you can't use all JavaScript logic. You cannot use if statements and for loops and other kind of statements like that. It needs to be some sort of expression. So I could do something like, maybe I'll say something that you might see as like const is small screen to add mobile styles. And I'm going to just say it's false for now. This is where you might look at the window width or something like that to see if it is a small screen, or use other kind of helper functions to do that. But here you could say like, is small screen, question mark, then we will show the main tag classes. Else we will show the mobile classes. And let's create another variable here. I'm going to do option shift down arrow, and I'll call this mobile classes. And we will just remove all of this, I guess. If there's a small screen, and I should reverse this. If there's a small screen, show the mobile classes. But if it's not a small screen, show the main tag classes. So you can add this JavaScript expression here. This expression is totally fine. But if I try to do a statement, and let me actually show you this. So here, we're still showing the same classes because we're saying it's not a small screen. So we're still showing the main tag classes. But if I set this to true, you're going to see it uses our mobile classes, which is just normal display flex. It's not putting them in a column and it's not centering them on the page here. So you can use an expression like this, and you can use this like in anywhere in your application. So I can use it within this p tag here. If I want to enter JavaScript land, I open up curly braces, and then with that, this would now need to be a string within curly braces here if I want to render out text. And then here I can also do, so instead of using this JavaScript ternary operator, I could also use an expression like is small screen. Well, if it is a small screen, let's just do ampersand. This tutorial is so great. If it's a small screen, then it's going to return this tutorial is so great. And this double ampersand is just like a JavaScript things to where if this side of the expression is true, return this. But if this side of the expression is false, return nothing. And then here, if I do option shift down arrow, let's do not is small screen. So if they're not on a small screen, let's return this tutorial is so great and use a little bit longer. And then up top, let's just change this to this tutorial is fine. So something a little bit shorter because it's on small screen. If it's not a small screen, show the longer text. So here you see this tutorial is fine. But if I switch this to be false, you should see not is small screen is going to be true, and it's going to render this tutorial is so great. And we see this tutorial is so great. So you can use these expressions, opening up curly braces within your JSX. Now, like I said earlier, you can't use an if statement. So here you might think that, okay, it makes sense to be like, if is small screen, then I want to return, and you can already see it's throwing errors because expression expected. You can't use an if statement. You also can't use like a for loop because that is going to be a statement. In JavaScript, think about expressions as like little fragments of a sentence, but statements are going to be like a full sentence. You can only use expressions within your JSX code. So within this return statement. But here, like we could say, let text, and we can just initialize that. And then I can say if is small screen. Then I can say text is equal to this tutorial is fine. Else, if it's not a small screen, we can set the text equal to this tutorial is great. And then instead of like doing this logic here, we can open up curly braces because we still want to render this JavaScript variable here. Then we can just paste in text. And then what you're going to see is this tutorial is so great. If I switch this to be true, if is small screen, that is going to be true. So it should be this tutorial is fine, which is what we do see up here. So you can still use like if statements and for loops within the body of your React component. You just can't use those within the JSX itself. It needs to be some sort of expression like a ternary operator, a double ampersand, something like that. But you open up curly braces to use these JavaScript variables. Now, one thing that you will see is that you might see double curly braces from time to time. And these double curly braces is nothing special. So you might see like on this H2 here, you might see like a style tag, and then you might see curly braces to enter JavaScript land. But then to add styles to this, you might see another set of curly braces because for the style tag, you need to pass a JavaScript object. So style is equal to curly brace, and then you could write your styles here. So I could write color is going to be red, and then I could do font size is equal to 32 pixels, and then I could save that. And if we come back, we see JSX tutorials now red, and it's a little bit bigger because we've added this style within our JSX. But to do this, it looks a little weird at first, these double curly braces, but all this is saying is that one set of curly braces is to enter JavaScript land, and the second set of curly braces is to add this JavaScript object that is going to render out these styles. So double curly braces is just meaning within JSX that you are using a JavaScript object, and to use a JavaScript object, it needs to be in JavaScript land, which you enter using curly braces. I know it's a little bit tricky, but there's nothing, if you see it, there's nothing like crazy going on there. You're just using a JavaScript object within JSX. So to use JavaScript within JSX, it needs to have an initial curly brace, and then you're rendering the JavaScript object curly braces within a curly brace. To do a quick recap here on this kind of TLDR of JSX, you must return a single element. If I try to return this main tag as a sibling of this div tag, it's not going to work. You see I get errors here because you need to return a single element. You also need to make sure to close all tags. So you can't just use this self-closing image tag here. You need to make sure you do indeed close it. You also need to camel case most attributes. So like if we added an on-click to this p tag, you're going to see it's camel cased. Same with all these other suggestions are camel cased rather than just HTML like so. And then also some attributes look a little bit different. So instead of like just using a class, it's going to be class name because it runs into the JavaScript keyword class. So there's a conflict there because this does get rendered into JavaScript. And then also, if you're using strings as attributes, just pass those as strings within quotes. That's totally fine to do. But if you want to use a JavaScript variable, within your JSX, put it within curly braces so you can render it like within your tags. Or if I wanted to add a class name here, but I wanted that to be a variable, I can use curly braces and just pass it like so. And then also, if you open up curly braces like we did here, whether that's within an element or as an attribute of an element, we can use JavaScript expressions. So like is small screen and render this text, or we can use the or operator or the double question mark or a ternary operator. This is all fine to do, but we can't use statements like if statements and for loops. And then also from time to time, you might see like double curly braces. And all that means is that the first curly brace is to enter JavaScript land, and the second curly brace is to render a JavaScript object within your JSX. So I know this video was a little long, but I really think that's pretty much everything you need to know about JSX in React. Today, you're going to learn everything you need to know about React components here. And I've created this kind of web page here, and we're both going to use it as like code examples, as well as topics we're going to cover and kind of organize things. So first, we're going to cover what you should know before diving into components. Then we're going to cover what they are. I'm going to show you an example. We're going to discuss why components might be a good idea when developing web pages, how to create components, nesting components, as well as organizing components. So first off, for prerequisites, I think it would definitely be a good idea to understand JavaScript functions, and then also have a rough idea of what JSX is. If you don't know JSX, then I have my previous React video. I think it's like something like the truth about JSX or something like that. That will be a good kind of starting place to understand that. And then also understanding JavaScript functions, because if you understand these, then components are pretty straightforward and fairly easy to understand. So we will mark that as done. But what are components? Well, components are effectively just JavaScript functions that start with a capital letter. So that's an important distinction there. With when creating a component in React, you should make sure that that component starts with a capital letter. This, I'll show you this in our example here in a sec. And then these components, well, they return JSX, and JSX gets converted into HTML and injected into the web page or the DOM. So it ends up being just kind of part of your UI. So when looking at even my web page here, these little like drop-down menus, these are themselves little components of UI. And for every drop-down, I'm just reusing these components. So these components are just JavaScript functions starting with a capital letter that return pieces of UI. So for another example of kind of what this looks like, and that's what we're going to cover now, so I'm going to mark that as done, and we're going to move on to this example. We're going to go to /UI components and look at some examples here. So I have created just several examples of different common components. So here we have a button component to where we could reuse this all across our application. And then when I click on the button component, I get an alert saying button was clicked. And then we could reuse this in several other areas. I could reuse this same button for a submit button down here, or for this modal component here. We could kind of reuse this component or this piece of UI, this JavaScript function that returns UI, all throughout our application. This card right here that has this kind of shaded background, a card title, as well as card content. Well, this is a component that we could use in several places of our application. This is a separate JavaScript function that returns UI. Same thing with this form component. It is its own JavaScript function here that returns a name and an email field, as well as a submit button. Same thing with this modal component. It is a JavaScript function, and I'll show you the code in a sec, that kind of does this logic for opening and closing a modal. And same thing with this nav bar here. So let's go over to VS Code, and you're going to see this is technically a Next.js application, but we're still just writing React here. You don't need to know any Next.js for this. But I have a components folder in which I've just created several different components. So if we look at the button component, what you're going to see is that this is just a JavaScript function here. It starts with a capital letter, and then I'm assigning this const button to an anonymous function. And what it does is it has a little bit of logic here within the body of the function, and then it returns some JSX, which then gets converted to HTML. And then I use some Tailwind CSS to style it. And this is our logic for when they click on the button. This represents a component. We look at the card component, very similar thing. It is a function, so const card is equal to an anonymous function. And then the return for this function just returns some JSX. And like this is where it would come in handy to understand JSX and some of the rules of JSX. But it's just returning this piece of UI. And then we can use this and reuse this in several places. Now, my next video is going to cover props and passing arguments effectively to these components so I can customize this. So I could effectively take a title and content props, and then we could use those props right here for the title and then right here for the content, or we could take these arguments here and use those so we can customize these components, but we'll cover that in the next video. Just know that that's something that you can definitely do in components. They don't need to be these like self-contained, isolated components here. They can definitely be customized more. And then for the form component, you see this time around, it does a little bit more. It uses some state within the form as well as a handle submit function, but the basic principles still apply. It is a JavaScript function here, and eventually it returns some JSX, which then gets converted to HTML, and then it does a little bit of logic here. Same thing with the modal component. It is just a function that returns some JSX, and then same thing with the nav component and so on and so forth. So all of these components are just JavaScript functions that return a piece of your UI. So heading back here, we go back to my home page. I definitely should have saved these in local storage, but we're going to remark these as done. But why components? So I've mentioned a little bit, but it allows you to combine your markup, which is your HTML, your CSS, so your styles, and your JavaScript into custom reusable UI elements for your app, which some people don't really like, kind of combining all of your HTML and CSS and JavaScript. But I think once you get used to the pattern, it really is kind of nice, because when we look at this, everything that we need for this component is right here within this file. We could add some logic here, so some JavaScript here in the body of this function, which say in our modal component, we do that. So we have our JavaScript logic here, and then we return our markup here, which is our JSX. So a button, some divs, an H2, a P tag. So we have our markup, and then we also have our styles. So we have our Tailwind CSS class names, and all this can be found right within this component. And I don't necessarily need to create like a separate HTML page and a separate CSS page and do what you might have to do if you're just using like vanilla JavaScript. Everything I need is right here within this component, and then I can use this component anywhere that I want to within my application. So I can get some really nice reusability of these components. And then, as we'll cover in my next video, you can pass arguments to these components, because at the end of the day, they're just JavaScript functions, so they're capable of accepting arguments just like normal functions, but they can take these arguments and then you can customize these components even further. So they have the benefit of kind of allowing you to combine your markup, your styles, as well as your JavaScript into custom reusable UI elements, and then you can just reuse those elements throughout your application. And it really does help just focusing on one piece of like UI at a time, because, it can be a little daunting. So if we come back to, UI components, if I need to create like a big web page with, a form, different card elements, different, sidebars and, a navigation menu and all this stuff, it can be like, I don't even know where to start. But if you're like, okay, I'm just going to focus on creating one component at a time. I'm going to first just focus on creating the form, and then I'll create that component and render that to the page. And then after that, I'm going to focus on creating a card, and you focus on that, create it exactly like you want to, and then kind of move forward with your web page. And then if I want to, I can reuse those components elsewhere in my application, which we'll kind of get to now. So we'll go back to the home page. I'll remark these as done. So we covered Y components, but now how do you kind of create components? Well, first we need to define the function. So let's go to the button here. So first we define the function. So const button is equal to an anonymous function. Other things that you can do is you can do a function declaration. So you could do function button, and then you could create your component like this and return your JSX. That's totally fine to do as well. Basically, any way you create JavaScript functions, you can do that here. I think it's pretty standard to see components created like this with anonymous arrow functions from JavaScript. But for the sake of readability, I actually kind of like the syntax of just saying function declaration and then the button. I actually quite like that. But you're going to often see kind of I guess this would be considered maybe the modern way of doing it, of just doing a anonymous function and assigning that to a constant like so to create your functions. So first you need some sort of function definition, and ignore this use client. That's a Next.js specific thing that you don't need to worry about. But first you define the function. Then you can add some logic and return your JSX. So here you can see we have a little bit of logic here. So we have a handle click. And if we go to our modal, you can see we have a handle close, and kind of we're handling some React state here. And same thing with a form. We have some logic here, but across all these, you'll see we have our kind of function definition, potentially some logic depending on what you want to do with your component. And then we return some JSX. Same thing with a modal. Function definition, some logic, and then return some JSX. And then finally, you can export and import your components. So we'll cover organizing components here in a second, but what you're going to see is that all these have like an export default modal. And then we export default form. And then we export default section. And then we export default card. So we're exporting all these components because we need to do that to be able to use those components within other like pages. So if we go to our page.jsx, you can see for our UI components page, we are importing our button component, our card, our form. So since we've exported these, we can import these all within separate files, and then we can render those within our separate pages. Now, to render these components, we kind of use the JSX syntax. So to render our card component, we render it like a self-containing HTML element. Now, you don't necessarily need to do this because you can see our section component. We actually render it as a parent to the card component, but we'll cover that in just my next thing. But just to stay on importing and exporting once a little bit more, in order to use these components, our button, our card, our form, our modal, we need to make sure to export to them from this file. It's very common to export default to them. So what that basically means is that here within this, we don't need to say like import modal from this components page. The default export is modal, so we can just say import modal from that components folder. Now, if I don't export modal, so if I comment this out, what we're going to see, and I try to go to our UI components page here, they were unable to resolve something. And basically what's happening is that we're trying to import here in UI components, we're trying to import a modal component from our modal file that isn't there. So if I go back to modal and I comment this back in and we make sure to export it, we can now use that within other files. And the way that you can import it is I don't need to import like with curly braces here if it's an export default. If it was just if I go back to modal, if I just do export modal and I export it like so, then I need to import it with curly braces as well. I need to import modal from components modal. And if you see nothing breaks here, everything still works. But I just import it from the relative path in my project. So components modal. But it's probably more common here to see a default export. So export default modal. And then coming back to my page, I don't need these curly braces anymore. I can just import modal from components modal. And all this will work. All right, so in order to use your components, you need to make sure to import and export them correctly, which is honestly more of a JavaScript thing than a React thing. But coming back here, we've covered prerequisites, what are components, examples, why components, and how to create components. But now let's go to nesting components. So it is perfectly fine to nest components within other components just like HTML. So if we come to this UI components page, you can see that within each section component, so I have my section component here, and we'll cover props in my next video as well as children. You can see that I don't render it like a self-containing element like I do with a button, the card, the form, the modal. To render these components to the page, I render them like an HTML element with opening and closing tags. So you render them just like you render other kind of JSX within your project. Your components are effectively custom elements. So you render them to the page like you render other elements, like an H2 element or a HTML form element or an input element. Your components, they're JavaScript functions that return JSX, and you render them to your web page just like you do other elements in HTML. So the way I render this button component is here in my components page, I do an opening bracket button and then a closing, a self-closing element here. Now, like I said, you don't necessarily need to render them like this. If I wanted to render something as a child of this button element, I could render, a card as a child to my button element. So if you need to render a button as a parent to a card, you can definitely do that like this. Now, I'll cover how exactly to do that in my next video on props, but just know that it's totally fine to nest your components exactly how you nest HTML. It's really not that much different. But just remember that when I want to effectively call my component, because it's a JavaScript function, you render it on your page like this. So once this UI components function here, once this gets rendered to the page, it's going to kind of go down our page here and it's going to see, okay, we have a navbar component. I'm going to call the navbar function and then return this JSX, which gets converted to HTML. And then once it gets to the section component, it's going to call this section component here and then return this JSX. Same thing. Once it gets to this button component, it's going to effectively call our button function and then return this JSX. And when it hits this form element, it's going to call our form component and then return the JSX that's within this form. So it's going to get rendered out here within this section. And we'll do a little recap here towards the end. But it's perfectly fine to nest your components within other components. That's totally valid to do. Now, finally, when it comes to organizing components, multiple components can exist in the same file, but a common practice is one component per file. So as you can see here within my components page, in my button file, I just have one singular button component. But if I wanted to, I could create a function card, and I could create a card component here that just say returns a p tag, and then it has some content. And then I could use that card within my button component somewhere. So I could render like my card component here within my button. And that would be fine to do. The reason I get an error is because in JSX, you need to return just one outer element, but I cover that more in my JSX video. But this is fine to do. So I create this card component right here, and then I render this within this button component, and both of these are in the same file. And if I wanted to, I could export button as well as card from this file. And then I could import those in other files, and that would be fine to do. So you can create components in the same file, but generally I prefer to kind of keep one component per file. Sometimes it's actually really reasonable to create multiple components in the same file, because sometimes you create like one main component in a file, but that main component gets pretty long, and you realize that it would actually make sense to create like an outside component that you just reuse within that singular main component, and you're not really going to be using that outer component anywhere else within your application. In that case, it would probably make sense to just kind of co-locate that or isolate that to that single file and create multiple components in that file. So just know, as a rule of thumb, you're probably going to see like one component per file. But if you have like a longer main component, it's perfectly fine to split that component into multiple components in the same file and just export kind of one main component. Or sometimes it might make sense to export multiple components in the same file. So that's perfectly okay to do. I just think it's probably a little bit more common to see kind of one component per file. So that covers kind of the essentials of what you need to know about components in React. But let's kind of do a little bit of a recap here. So components, well, they are JavaScript functions that start with a capital letter and return JSX, which is going to effectively return a little kind of components of your web page, or little pieces of UI. So as we can see, this button, it is just a JavaScript function that returns some JSX here. I'm going to clean this up a little bit, but just a JavaScript function that returns JSX. And the way that you then call this function is by rendering it on your web page like you would an HTML element. But they can all be like self-closing HTML elements. So like, here's my button, here's my card. They're all like self-closing HTML elements. And this effectively, once my browser starts rendering this component, once it hits button and section and card and form, it's going to call those components, and then it's going to generate the HTML that these components return. And then why are components useful? Well, it allows you to combine your markup, your CSS, as well as your JavaScript, all into custom, reusable UI elements, so you could just reuse those throughout your entire application. And it really can help kind of speeding up development and isolating kind of the logic for certain sections of your app. Now, you create components by defining a JavaScript function, adding some logic and returning JSX, and then exporting and importing that component. So we define our JavaScript function, we have a little bit of logic, we return this JSX, and then we export this component and then import it into other files, and we render that component to the page by using like HTML syntax, like JSX syntax, rendering it like an element as a self-contained element, and that effectively calls that JavaScript function, and it will return whatever that JavaScript function returns. So some JSX. And then it's also perfectly fine to nest your components and have like parent-child relationships, like we see here with this section being a parent of this button element. That is perfectly fine to do. And then when it comes to organizing your components, you can have multiple components in the same file, but you're probably going to see one component per file as maybe a little bit more of the standard. But if you have a longer kind of main component, you might see that component exported as the default export, and then kind of the pieces of that main component split out into other smaller components in that same file. And it's still pretty common to see, and it's totally fine to do. So that, my friends, is components in React. Let me know if you have any questions or if there's anything I missed here, and I'll try to get back to you as soon as I can. I used to overlook this concept in React.js, and to be completely honest, I still overlook it to this day. And I can tell you firsthand, it causes issues, and it can cause just kind of tricky to solve bugs. And it's going to seem obvious in the examples that I show you here in just a little bit of what's going on, but in a large scale production environment, it can be a much more nuanced and kind of very difficult to understand what's going on. And we're going to end with something that I think you really, really need to keep in mind when using React.js that has saved me a ton of headache. So the concept we're going to talk about here today is keeping components pure. And you're going to see this is straight from the React.js docs. Now, I'm not just going to read the docs here. We are going to go over the docs a little bit just to kind of see what the source of truth says, what the React official docs say. But we're also going to look at an example as well. So let's first jump to the section to where they talk about keeping components pure. So what does like a pure function mean overall? Well, it means that a function does not change any objects or variables that existed before it was called. And it also means that given the same inputs, a pure function should always return the same result. So not to get super mathy with you, as you know, I'll be the first one to say my math isn't always mathing, but consider this formula. Y equals 2x. Well, if x equals 2, then y equals 4. Always, no matter what. Like that is a mathematical formula. And if x equals 3, well, then y needs to always equal 6. Always. So this is kind of showing you that this pure function component is kind of based off of mathematical concepts around formulas, to where if x is this and y is this, then the result always needs to be this. And if we turn this into JavaScript code, you could see that if you had a function double and you pass it an argument called number and you return 2 times a number, then if you pass the function 3, it's always going to return 6. If you pass the function 4, it's always going to return 8. And I'm going to stop there with examples so I don't make an embarrassing mathematical error. But React is designed around this concept, and it assumes that every component you write is a pure function. This means that for a React component, given the same inputs, which in React's case, this is going to be called props. Props are basically the arguments you pass to a component. Given the same props, then the resulting JSX or the resulting HTML that is rendered to the page should always be the same. And they show an example of this, but I think it's more illustrative to show you an example of what it looks like when it's wrong. So they show this example here, but I'm going to head to VS Code, and I've created my own example here to where I've basically used their example, but just customized it for stuff that's more related to me, I guess. So I just have this, and this is in Next.js, but it's using React. It's technically in a server component, but that's not going to matter until we get to a later example here. But I have my home component, and then I'm rendering this other component called money I want to spend on my truck, because I go down these rabbit holes of different hobbies, and I basically want to spend all of my money on certain hobbies. So I'm getting into like off-roading and stuff like that lately, which, you know, is what it is. It's way too expensive and I can't afford anything. But this is represents the money I want to spend on upgrading my truck. As you can see, this is the money I want to spend on my truck component. And we have this money variable here, but then we're setting money is equal to money plus 100. every time this component renders. And then we're rendering out an H2 that says, I'd love to spend however much money is represented by this variable. But what you're going to see here is that this is an external variable. We are mutating a variable that lives outside of this component, which means that when we render this money I want to spend component, I render it 3 separate times. Well, we're going to get a different result for each time we render this component, even with the same arguments. So we're not passing any arguments to this component. So based on like the rules of React, we should get to the same result every single time we render this component because it takes no arguments. So we're always passing the same arguments. So with the same inputs, it should render the same output. But if we go to localhost 3000 here, what you're going to see is that component 1 renders, I'd love to spend $200. Component 2 renders, I'd love to spend $300. And component 3 renders, I'd love to spend $400, which all of those are true. I'd actually like to spend a lot more money than that. Given the same inputs to all 3 of these components, they render a different result here each time. And if I refresh this page, you're going to see some more weird stuff. If I refresh this, you see 500, 600, 700. If I refresh again, 800, 900, 1,000. So it's just rewriting this local state and counting up. But if I kill my server here and I run npm run dev, and then I come back to localhost and I refresh now, it resets it back to 200, 300, 400 because I've reset my kind of a local state there. So clearly this is like a confusing behavior to have within your applications. So you definitely don't want to do something like this. And this is kind of the most straightforward example of mutating something external and then seeing a different result and not having things be pure. It gets even more tricky if we're like passing a certain prop here and then we're mutating props within this component and it's changing the result in other components. And it can just get really hairy when you start to make certain mutations like that and you're overriding props, and it's just generally not a good idea. Now, what would be an easy way to solve this? Well, we can just pass a prop here. So we can just say money is equal to 200, and then we will pass another prop below, pass another prop below, and then we'll do 300 and 400. And then we'll just remove this here, and then we will accept money as a prop and just destructure it right there. Get rid of that. And now we should see 200, 300, 400, which we do see. And then say I pass, 400 to this one. Well, it should render out 400, which it does. We see 200, 400, 400. We don't see that behavior of 100, 200, 300. When I refresh this, we see it stays 200, 400, 400. So just passing it as a prop and not making those mutations fixes this particular issue. And it kind of covers this a little bit more here to where it says you can just pass it as a prop instead. And then they show doing that. One thing to keep in mind is that for local mutation, that is actually okay. So in the example I just showed you to where we were editing a external variable money, well, that's not great because we're mutating an external variable. But in the case to where we are changing variables or objects that we've just created while rendering, that is actually completely okay. So if we go back to our example, what do I mean by this? Well, if I create another variable within this component. So say I create a variable called upgrade amount. So I'm going to say let upgrade amount, and then we will just make it an empty variable. And then I'll say let text, and then I will initialize this to I would love to spend no money by default, which in reality is not true. I'd love to spend all the money, but by default, we'll set it to this. But now what I can say is if money, then, and this doesn't make a ton of sense, because we could just use money here. But for the sake of this, I'm just showing you that this would be fine to do, is mutating these variables that we're declaring within this component, within the rendering of this component. I will just set upgrade amount. Let's just, to make it a little bit different than money, which also doesn't make a ton of sense, but I'll say it's 10 plus money. And then if there is money and there's an upgrade amount, I'm going to also reinitialize text. It's equal to, I would love to spend $ curly brace upgrade amount. And then instead of just rendering this out, I'll just render out my text. And I need to make sure to put that in curly braces. So what I'm doing here is, yeah, we are mutating variables here. We're mutating upgrade amount and text, but we're doing that within this component's render cycle. So we are deriving this state based on this prop here. So we're not actually mutating anything external to this component. All of this is local within this component. So this is still maintaining our kind of pure function here. So if I just render these, we should see like 210, 410, and 410. So let me come back, go to localhost. We see 210, 410, and 410. But if I change one to 0, like so, then we should just see the default text because money is 0, a falsy value. So we should see, I would love to spend no money. And I do see for our first one, I would love to spend no money. So this is still a pure function that is totally fine to do. So don't confuse like mutating local variables with mutating external stuff. I know it gets a little bit confusing there, but it only matters that it doesn't mutate variables outside of the function scope, or objects that were created before the call and then say passed as a prop to that component. It's completely fine to change variables and objects that you've just created while rendering. Now you might be thinking to yourself, well, that's cool and all, but at some point, something's probably going to need to change. So we're going to need to cause some side effects. And this is where like that tip that I mentioned earlier is really going to come into play, because React mentions that side effects should usually belong in event handlers. And event handlers are functions that React runs when you perform some action. For example, when you click a button. Even though event handlers are defined inside your component, they don't run during rendering. So event handlers don't need to be pure. It's a very important thing to keep in mind there. So let me go ahead and show you an example of this. I'm going to use some state here, which means I'm going to make this just a client component. This is a Next.js specific thing, not a React specific thing. But for this home component, let's just create maybe we'll do it within this money I want to spend on my truck. So I'm going to say const upgrade amount set upgrade amount is equal to use state, importing that from React, and I'm going to default it to money. So it's going to start with whatever money variable we enter here, but then I'm going to render. Let's go ahead and return a couple of things here. So I'll just do a div for a wrapper component and say money needed for, and then let's pass an upgrade title prop. And then I will render out our upgrade amount and then make sure to include a $ here. So here I will also render upgrade title. And then let's also pass upgrade title here for all these. So I'm going to say suspension. I'm going to copy this, paste it here, tires, paste this here, and then do wheels for this one. We are going to allow the user to increase the money they need for this upgrade. So I'm going to also render a button that is going to say, I need more money. And then when they click on this button, so on click, we're going to pass a function that it's going to set the upgrade amount to the prev amount, but we are going to take the prev amount and add 100 to it. So if they click on I need more money, it's going to set this upgrade amount and then increment this. So clicking on this button is going to affect what they see on the page, which is, technically affecting the outside world or being a side effect. But the important thing to remember here is that when this component renders, we're not automatically running the set upgrade amount, meaning we're not running this effect during the render cycle of this component. We're only running this effect when the user clicks on this button during an event, which in React, what's important is that you don't have effects during the rendering cycle of this component, except for when you absolutely need to use something else, which we'll talk about in a second. So if we look at our localhost here and I click on I need more money, and we see my styling is impeccably beautiful. Everything works as expected here. It does reset when I refresh because we're just using local state here. We're not persisting it to local storage, but it resets it back to its original number like we would expect. It doesn't start doing like weird things and incrementing the count. All these are individually to each other. So everything looks like it's working here correctly. So for the most part, if you need to have side effects like this, it's best to do them during some sort of event handler, because this event handler only creates the side effect when that event occurs, not when this component just gets rendered. That's where a lot of those issues come from. Now, to finish here, React does mention that if you've exhausted all other options and can't find the right event handler for your side effect, you can still attach it to your return JSX with a useEffect call in your component. This tells React to execute it later after rendering when side effects are allowed. However, this approach should be your last resort. When possible, try to express your logic with a rendering alone. You'll be surprised how far this can take you. And this is like the biggest tip here that I kind of alluded to earlier. Really, useEffect, it's confusing. I've been using React for several years, and in my professional job, it's not like I'm using useEffects every single day. So because of the more kind of complexities when it comes to using useEffect, I always forget about those complexities between the time I need to write one. So often it's best to just default to not using them whenever possible and trying to just have your effects be from event handlers. And, I'll be the first to say, if you have a component in your application that is using like 8 or 9 different useEffects, I'm guessing that is a headache component for you because things just get a little bit tricky there. So try to keep those events in event handlers opposed to using useEffect. Now, as one just final thing to finish on, why does React care about this kind of purity when it comes to effects? Well, your components can run in different environments, for example, on the server, as we actually demonstrated with server components here a second ago in Next.js. Since they return the same result for the same inputs, one component can serve many requests. Also, React can improve the performance by skipping rendering components whose inputs have not changed. This is safe because pure functions always return the same results, so they're safe to cache, which is also a very important consideration. And then if some data changes in the middle of a rendering a deep component tree, React can restart rendering without wasting time to finish the outdated render. Purity makes it safe to stop calculating at any time. So if you have a component that's deeply nested in your tree and you have some sort of data change, well, React doesn't really need to worry about finishing that render and then restarting the render cycle of that deeply nested tree. It can just stop and restart because purity makes it safe to just stop the calculation and kind of restart wherever. And every new React feature that they're building takes advantage of purity, which means that they are making assumptions when writing new features that you're kind of following this concept. And if you're not, you can run into weird stuff that will make you think that React is just weird. When in reality, I think a lot of times for me, it was just that I didn't understand React well enough and I wasn't as good with it as I should have been. And that caused me some frustration with using React when really the answers were right in front of me. I just didn't know about it. So hopefully this video helps you out and kind of provide some guidelines when using effects, keeping things pure, And I hope it provides a little bit better kind of understanding for those things. So today you're going to learn everything you need to know about understanding props in React. We're going to cover what props are, how they work, a good way to think about props, destructuring props, default props, forwarding props, nesting props, and whether you should mutate props or not. So a little bit of a deep dive on props in React. And, if you're a beginner, great. This is going to be very good for you. I think it would be a good idea to understand components as well as JSX in React before this video, which I also have videos on, because I'm going to make some assumptions about knowledge there. But if you have a general idea of how kind of components work and how JSX works, this is going to be great for you. And then also, if you're more experienced with React, this is also going to probably be pretty good review for you, as I know that for me personally, I've been using React for several years now, but it was still good to kind of go deep dive and research props in React to kind of create this video. So let's first head over to VS Code, and I'm going to show you what props are just by example here first. So we have this home component, and that's what's rendering here on the screen. And then we also have this info card component. So this component, all it does is it renders out a title as well as some content. So if we go to our home page and I render out this info card component, what you're going to see is that's going to render to this page. I'm going to refresh, and then we see the info card. So that's great and all, but the whole idea of components in React kind of revolves around being able to reuse components. So what if I want to do multiple info cards on this page? Well, I can render out a few of them, and then we come back and we see a few of them, but all three of them are exactly the same, which is probably not what you're actually going to want in an application. You're probably going to want to render some different titles and some different content for these cards. And this isn't specific to info cards. It's for any component you make. You're going to want to be able to kind of customize them and reuse them all around your application if necessary. So how can we customize these components? Well, the way I like to think about components, which I've covered in my components video on React, the way I like to think about them is that they're just JavaScript functions here. So you can see info card is equal to this anonymous function, this JavaScript function, and they're just JavaScript functions that return HTML, or they return some UI. Now, this isn't technically HTML, it's JSX, but at the end of the day, it gets converted into HTML and rendered to the page. So they're just JavaScript functions that return some UI. Now, how do we customize JavaScript functions? Like, how do you tell a function effectively to return something a little bit different? Well, you pass arguments to those functions. And in React, components work a very similar way. We can effectively pass arguments to these components via props. And what props look like are very similar to HTML attributes. So in our JSX here, we're setting these class names on these JSX elements. These class names here would be considered JSX attributes. And you can see when I hover over it, it's going to have the HTML attributes type. And then you could do different things like, if I had an HTML input, it might be type text. So my attribute is type. Well, very similar to adding attributes to components, we can add props. So if I add title is equal to info card title, it looks just like an HTML attribute, but this is considered a React prop. And if we go to our info card, we can accept this via the props object. So right here, passing this attribute is effectively like passing an argument to the info card function. And then within info card, we accept a props object here. So React is automatically going to pass all of the attributes here on a props object. So we're going to be able to access, and I'm going to make this, I'm going to put square brackets around here, and then I'm going to just say return, so we can console.log the props. So if I open my console, you're going to see I render 3 different props objects here, and you can see props is an object. One of them has a title property with info card title. Because I'm rendering 3 different info card components, but I'm giving one of them the title of info card title. So you can see the attributes I add here are passed on a props object in which the name of the attribute corresponds to a property on the props object. So if I add another attribute here, so I'm going to say content is equal to my info card content, and then I save that, you're going to see I render out 3 different props here because I'm rendering out 3 different components. But one of the components, the props object, has 2 properties now, title and content, and they correspond to these attributes I pass here. So these attributes that I pass into this component are passed along on the props object as an argument to the component. So then I can use these within the component. So instead of just rendering this hard-coded title, I can render props.title, and then instead of rendering this content, I can render props.content. And now if we go back to our page, you can see 2 of my cards have nothing here because in 2 of my components, I'm not passing a title and content attribute, which is going to be passed on the props object that I can access with a corresponding name. So props.title, it corresponds to this title attribute. Props.content corresponds to this content attribute. But since I'm not rendering title and content on these 2 info cards, we see just 2 blank cards here. But in our top card, we see info card title and my info card content because that's what I pass as props here. And those effectively get passed as arguments on a props object to this info card component. Now, one thing that you're going to see a lot is destructuring props right here within the parentheses of your component. So the way that this would work is if I'm expecting a title and content prop, instead of just accepting props here, I can use curly braces, and then I can accept title and content. So this is just a JavaScript thing. It is accepting, and I'm going to remove this console log of props, and I'm also going to remove props.title and just use title, and remove props.content and just use content. But this is just a JavaScript thing. I'm accepting a props object, and I'm destructuring the title and content properties from that props object, which allows me to just use them directly within my component. And if we come back, we see we get the same result, but it's just a little bit cleaner here. And you know what you tend to forget if you're a beginner is putting the curly braces around this. So you make sure to use destructuring syntax to destructure title and content from the props object, or whatever attributes you pass, destructure the correct properties with destructuring syntax. Now, what if you want to make sure that you don't render just like empty cards here or empty components, and you want to give your props default values? Well, it's the same thing with JavaScript destructuring. And I'm going to close my console here. What I can do is I can say the default title is just some title. So I'm just using title is equal to this string. And then the content, well, it's just equal to some info card content. So I'm giving these 2 default values just using the same syntax you would with destructuring in JavaScript. So if I come back, you see now my info card, where I actually pass the title and content attributes to, that has the customized title and content. But the other two, since I don't pass the title and content, they just contain the default title and content, some title and some info card content, what you see here. But if I want to customize those, well, I can just add a title here. So title is equal to custom info card title, and then content is equal to custom info card content. And now what we should see is one of our info cards has info card title and my info card content. The second info card has these corresponding title and content here. And then the third one just has the default info card title and content. If we look at that, that's exactly what we see here. So you can use the default values for your props, and those are only going to be the values for this component or for your component if you don't pass the attributes on your component. And these attributes at the end of the day are just going to be passed as arguments to your component on the props object, or they're going to be passed as properties on the props object, which are going to work like just passing arguments to a function. One thing that you really want to make sure not to do, or not to attempt to do, is to mutate your props. Props represent just like a single snapshot in time, and they will be reevaluated when a component re-renders, but you should not mutate them. So if I try to do like title is equal to just a weird case of strings here, you're going to see that now they're like all just changed to this weird case of strings, and like my default values don't work anymore. And then also my actual attributes don't work anymore. So don't change your props. If you find yourself needing to change some like values and have those values be dynamic or conditionally different values, what you're going to want to do in that situation is use some React state. You're not actually going to want to mutate your props. So keep your props read-only, don't mutate your props. And if you need to have dynamic values, that's where you're going to want to use React state. Now, one thing I want to show you that you're probably going to see quite a bit is forwarding props. Let me show you it first, and then I'll provide a caveat. So you might find yourself in some situations where you want to create like a wrapper component that maybe it wraps around this info card and provides some sort of customization to it. So in components here, I'm going to create a new file, and I'm going to create info card wrapper.jsx. And then I'm going to say const info card wrapper is equal to, and it's going to accept props here. I'm not going to destructure it right now. And then we'll do the arrow syntax. And what I'll do here is maybe for my info cards, I want to render like a button to close my info cards, but for some reason, I want that to be a wrapper to where like maybe only if a user is logged in, I want to show them that button. So here I could be like, const is logged in, and then this could be some logic to see if a user is logged in. But for now, I'll just say true, and then we'll return React fragment, and then I will say if they are logged in, so is logged in, then I will render out a button that will say close card. But if they're not logged in, then we won't show the button. Now, this is just for example purposes. The logic here isn't necessarily what you would actually do in an application, but it should get the point across. But now, let's say I want to render out a info card component. So info card, and I'm going to import info card from info card, but I need to render out the props here. So if I'm just going to render out my info card wrapper, I'm probably going to want to send it like a title and content prop. But say I don't want to do like title and content. And if there were several props, I might need to do, a bunch of other things. So like button, text, and say my info card component had a bunch of other props here that I'm typing out. That might get a little bit tedious to do. So instead of doing this, what you can do is just accept props, and then you can spread your props into the info card component. So I can just spread these props like this. Because remember, props is going to be an object, and then I can just use JavaScript to spread that object into this info card component. This is commonly called forwarding props. And if you haven't seen it before, it looks a little bit weird, but at the end of the day, we're just using JavaScript here to take this props object and spread the properties and values into this info card. So if this props object contains a title and a content property, we're going to assign the property title as an attribute to this info card. And the same thing with content. So let me console log these props here, and then let's render within our page.jsx. Let's render an info card wrapper. So I'm going to do info card, and I think we need to export it. So let me make sure to do that. Export default, info card wrapper, and then let's go render it. Info card wrapper. And then now I can pass a title is equal to info card wrapper title. Content is info card wrapper content. And now if we look, we see a close card button, which doesn't make a ton of sense, but that's what we wanted from this wrapper component. But we still see info card wrapper and info card wrapper content. So our props are working correctly. And if I open my console, we see my props in my info card wrapper here that we're console logging have a title and content property. And then we're just spreading those props into the info card, which is going to work because the info card expects us to have a title and content value, and we can just spread those into the info card component. So we're just kind of forwarding these props. Now, the caveat on this is that this isn't always the most readable thing. Like if you're new to React and you haven't seen this, you might be like, what in the heck is going on here? But this is the very same thing is doing something like, instead of spreading them here, I could say title is equal to props.title, and then content is equal to props.content. And that's the very same thing. And if we come back, we see everything works the same. And then we could even do the same destructuring up here for title as well as content. And then we no longer need to access that on the props object. And that's going to work the same way as well. But props is not defined, so I will get rid of that as well. But you see, that still works. And I think that this can be a lot more readable, which is why I tend to still use this approach. But just know that you're going to see that forwarding props of ... props quite a bit. And that's all that's going on there. And it can be really nice to where, like I said, if I had like several other props that I'm destructuring, prevents me from needing to like just continue to add all those attributes manually here, which can get a little bit tedious to do. And sometimes forwarding props makes a lot of sense. You just have to kind of know what's going on there. Now, one final thing to cover here is children. What we're going to do is for this info card wrapper, instead of just rendering an info card here, I'm going to remove that. I'm going to also remove both of these here, and I'm just going to accept props here. But now below my button, I'm just going to render props.children. And I'm going to also console.log props.children. Now, what is children? Well, children is going to be anything that I pass as a child to my info card component. So in page.jsx here, I'm no longer going to be sending these props to the info card wrapper. I want to render the info card as a child to my info card wrapper. So the way I'm going to do this is, instead of just having a self-closing component, I'm going to have an opening element and a closing element here. And then I'm going to render my info card within the opening and closing element. So I'm going to render info card like so. And I'm going to say the title is info card child. And then the content is going to be info card child content. So now I have my info card wrapper, the opening and closing elements, and then I'm just rendering info card as a child to my info card wrapper, or between the opening and closing elements, in a very similar way that like this header here has this h1 as a child to this header component, or this header HTML element. We can use like the same sort of DOM structure logic to render this info card as a child to this info card wrapper. And the way that we're going to access this is going to be on the props.children object. So if I come back to my info card wrapper and I open my console here, you're going to see that my props.children, it's going to be a React element because I'm rendering my info card title. And you can see on my props.children, the type is an info card function. And then it has the props of title and content, of info card child content and info card child. So I access my children on props.children. So if I come back here and I decide to render another card within info card wrapper, or say I want to render an H2, because you can render other React components as children, or you can render JSX element. I can type some stuff out and I can save this. And then now we're going to see my props.children is going to be this React component that we see right here. But we also render this H2 as a child to info card wrapper. So this is also going to be an element of type H2 that has this content, because even in this JSX component, this text that we're rendering within it is going to be the children to this JSX element here. So both of these are going to be on the props.children of our info card wrapper. And if we look at the UI here, we see we render info card child content, and then our H2. And that's being rendered within this info card wrapper. And maybe to make this more clear, I'll make this a div here, and then I will set a style in which the border 1 pixel solid black. I think that might work. And then you can see it kind of has a border here, but maybe I'll make it a little bit bigger. Maybe I'll do 10 pixels and then I'll do solid red. So here you can see my info card wrapper is rendering the button, the info card child, and this H2. And I'm rendering all those by just rendering out my props.children and this button right here. So if I pass more things into this info card wrapper here, I'm going to keep rendering them as children. So this is now going to render this paragraph. And if I look at this, we see it renders this paragraph. So anything that you pass within your component tags here, so within the opening and closing tags, you can access that content or those JSX or other React components. You can access those on the props.children value, because that's automatically going to be passed on the props object, and it's going to be on the .children property. And of course, we can use the same destructuring syntax. I can just destructure children on my props object, and then here we can just render out children. And we see we have the same effect here. Props.children, it can be a little bit tricky, but once you start using it, it can be really nice and it does come in handy. Just remember that anything that you pass as a child or within the opening and closing tags of a React component, you can access those on the children property of the props object that is automatically going to be passed to your component. And that can also help you further customize your React components. To become a professional React developer, I definitely think that you're going to need to understand the concept of conditional rendering. So today's video is going to cover that concept and cover the different ways that you can conditionally render different things within React.js. Now, I have created this just basic web page here that we're going to show conditional rendering with. If I inspect and then I make this a smaller window, you're going to see that it drops down to just a few items once I enter like more of a mobile screen, whereas when I expand, it pops back out to 10 items. And this is using conditional rendering here. If a larger screen, show all the items. If a smaller screen, show fewer items. So we're going to, of course, cover this example, but we're going to cover several other examples of conditional rendering as well. Now, in my running application here in VS Code, if you would like to follow along and see this code, I have this code linked in my description box. You can clone this repo and then run npm run dev, and you should see this project here. Now, it's technically a Next.js project, but we're just focusing on the React aspects. So here, I have a list component, and I effectively generate some new items or a list of items, but then I check the window width of the viewport, and if it is on a mobile screen, then I only take the first 3 items, else I take all 10 items, and then I map over my display items here within my JSX. Now, if you haven't seen my video on JSX, as well as components, those videos would be really great prerequisites to this video here. But assuming that you understand kind of how JSX works as well as how components work, in my JSX here, I'm just mapping over my displayed items, in which I use a ternary operator to conditionally tell React which items that I actually want to show here. So this is one way that you can do this. Now, this can be done also via props. So I could pass in my isMobile variable via props and then use the very same logic here. Of course, you do not need to just have your logic within your component body. You can definitely pass in props and then have different conditionals and different conditional rendering based on props. You can also, we're kind of doing our logic here outside of our component, but you can also do this logic right within this JSX here, because once I open up these curly braces, which you're seeing here in this JSX, I'm telling React that I've entered JavaScript land and I can use expressions in JavaScript. Now, when you're in JSX land here, I'm in my return statement. You can't use statements, so I can't use if is mobile here. That's not going to work. I can't use JavaScript statements here. But I could do that outside of my return statement. In the body of my function, I could say, instead of doing this logic here, I could say something like let displayed items, and I'm going to set it equal to items here to start, but then I can say, let me copy this slice, and then I'm going to get rid of this line. I'll say if is mobile, then I'm going to reset my displayed items is equal to items.slice. And then I map over these displayed items here. So this time around, I can use an if statement, but it's outside of the return statement. It's outside of JSX. It's in the body of my component, but I'm just initializing a variable, setting that to a default value. But if it's mobile, then I want to make my display items a little bit less, just 3 items. So in this instance, our condition is outside of our return statement, but we're still conditionally rendering different items based on this isMobile condition, which this function, every time it renders, and re-renders, it's going to recheck, okay, if is mobile, these are my display items here. Now, what if for this list component, I want to add like a header to this list, but I only want to add it if we are not on mobile. So if we're not on mobile, add a header to my list, but if we are on mobile, don't add the header. Well, above this UL here, I'm going to enter JavaScript land, and here you can actually use a ternary operator right within your JSX. So any expression. So I can say is mobile ? Then return null. So if we're on mobile, don't render anything at all. Else, I'm going to render an H2 saying some title. So here I'm not on mobile. We see the title, but as I shrink it down, you see we only see 3 items and we don't see the title anymore because we're not on mobile. So our display items, our condition here is working correctly, and then we're also doing this correctly. A shorter way to do this rather than using a ternary operator right within our JSX. And to be clear, you could also do something like this. You could say, just like what we did for the displayed items, I could do let title is equal to some title, but I can say if is mobile, then I could just set our title to be equal to an empty string. And then here within this, we could render an H2 and then just render our title within our H2. Now, the problem with this is that we're always going to be rendering this H2 regardless of whether there's a title or not. But this is another way that you can see things done. And you'll see here that it works the same exact way, showing our title when it's not on mobile and not showing it when it is on mobile. Let me get rid of that title variable. But what I showed you before with the ternary operator, there's actually probably a better way that you can do this, in which you could say is mobile ampersand, then render a title. So I'll render some title. And what this is doing is it is the logical and operator here, in which if the left side of the operator evaluates to a truthy value, it's going to return whatever is on the right side of the operator. So if isMobile is truthy, it is going to return some title here. But if isMobile is a falsy value, it is just going to return null, which in React, you return null if you want to render nothing. So if isMobile is true, then render the title. Else, it's not going to render the title. But this is actually the opposite of what we want. We only want to show the title if we're not mobile. So I can say not isMobile, then render the title. So if we see this, I'm going to see if I shrink it down, we don't see the title anymore. Expand, shrink, we see it working as we want. What you're also going to see a decent amount is just returning early with either some other JSX, or you might return early with just returning nothing at all. So before my return statement, you might see an early return like if isMobile, then maybe you just don't want to render the list at all. So I'm going to just return null. So if we're on mobile, don't render the list. And what you're going to see is I'm on mobile, I'm not seeing the list, and now I see it. So what we're doing here is, if we're on mobile, just return nothing. And in React, you return nothing by just returning null. This might not be the best pattern to follow, just because if I'm only looking at my page component here, where I'm rendering my list, if I'm only looking at this page component, I might see this list component here, but it's not clear to me by just looking at this like home page that this list isn't going to render on mobile. I might look at my page component, come look at my page and not see my list, and then be a little bit confused. So it's not always clear. And a better way to sometimes do this is to just conditionally render the component itself. So here I could say not isMobile. So if we're not on mobile, then I want to render the list here. So then it's clear that if we are not on mobile, that's when I render the list. and I kind of leave that logic out of the list, and I could just get rid of that there. So sometimes it's better to just conditionally render the component itself, like how this would work here. Of course, I don't have this isMobile component defined in the scope of this function, but sometimes it's better to just conditionally render the component itself rather than putting that logic within the component, because it can sometimes make the code a little bit more readable. Now, there are times to where it makes sense to put in the component, but sometimes it makes sense to just keep it out of the component logic. So I'm going to go ahead and get rid of that. But you could also return, so in our list component, instead of returning null, you could return some different JSX or a different component altogether. So if isMobile, maybe render like a mobile list component, and that would be perfectly fine to do. So what I'm actually going to do here is, let's take this div and these items, and this use client up at the top is just a Next.js thing. You can just ignore that. But I'm going to create a function called mobile list, and then it's just going to return this, but we're not going to do any mapping here. We're just going to return one list item component. So of course, this is a little contrived. We don't need a key, and we're just going to say that this is a mobile list item. So if we are on mobile, then we're just going to, and of course, make sure to return. We're going to early return our mobile list component that we define here that just returns one list item. Else, we're going to return our entire list. So you can conditionally early return a completely different component, and that's totally fine to do as well. So here you see on mobile, I just return my mobile list item. But if we're not on mobile, I return our full component. Now, one thing to note here is that earlier I showed you these logical operators, and I also showed you the ternary operator to where like not isMobile and show some title, else just return null. And it's common, you're going to see it a lot, but my opinion is more so along the lines of, if possible, use if statements if you can. Because I think that this logic right here, if isMobile, then reset the display items to be something else. I think that logic is much more readable compared to this. I mean, this isn't terrible, but it's like, okay, not isMobile. Okay, so if it's not mobile, then return some title, else just return nothing. Like, that's not bad, but this can get much more complex. Like if I'm returning a big chunk component here, so instead of just a title, maybe I'm returning a whole different section or something like that with more logic, that can get a little bit confusing. So generally speaking, I try to use if statements where possible because I just feel like that is a little bit more readable compared to using the logical and operator or ternary operators. But that is a little bit of a personal preference thing, but it's something to definitely consider in writing a little bit clean code with these conditional rendering patterns here. So those are kind of the main patterns there. We have ternary operators, we have the logical and operators, and we're doing both of these within our JSX here, but of course, we can do that outside of our JSX as well using variables, so display items, and instead of just assigning it to items, we could use our logical operators outside of our JSX, or we could use our ternary operators as well. But like I said, I kind of prefer using an if statement outside of our JSX because if statements won't work in our JSX, only expressions work, but that would be kind of my preferred approach. And then also you can do an early return. You can early return nothing, although sometimes it's better to just do your early return when you're rendering the component itself rather within the component logic. But you can early return a different component, early return nothing, but those are kind of the core ways that you can conditionally render within React.js. So hopefully you learned something from this video and that you take something away from it. But I think if you understand kind of those core ways to conditionally render, and this conceptually makes sense, that you're well on your way to understanding how all this works. So play around with it and let me know if you have any questions in the comments below. How do you render lists in React? Well, in today's video, we're going to cover just that and several different key points that you need to understand when it comes to rendering lists within React. So I have created this web page here. You can find it and you can see kind of the code that we're going to show for examples here at this GitHub repo that I'm going to link in the description below. Just in case you want to follow along or play around with some code, you can clone this and basically see this page. Once you run npm install, then npm run dev. But the first point that I want to touch on here is that when rendering lists in React, it involves using the JavaScript array method. So when you have a list of data that you want to render, you're going to need to map over that data and return list items for that data using the map method. So it is important to understand how the map method works to understand rendering lists in React, as the overall steps for rendering a list in React are going to be, you're going to want to have an array to render the list items. And you might want to filter this array prior to rendering it if needed, which I'll show you how to do in a second. And then also you are going to map over the data, giving each item a unique key prop, which you can see the next few points we're going to cover is regarding that key prop. So we'll cover that in more depth. And then number 3, you're going to render the LIs in the return statement of a component wrapped in an OL or UL. So let's look at an example of this. I have my homepage here, and I have this key points array, and each item in the array is just a string that is going to be an item that I render on my page here. These key points are in an array, and I'm mapping over this array and rendering it to this web page. So here we have this key points array. I'm not doing any filtering on this array, but I'll show you how that would look in a second. We have an array of strings. This could also be an array of objects or different structures. What's most important is that you have an array of some sort. And then once you have this array, you can then call the map method on this array to render items. So here within the return statement of this homepage component, you're going to see that I have a UL, and then within this unordered list element, I open up curly braces because I am entering JavaScript land because I'm using the map method within my JSX here. And if you need a refresher on JSX or components or props, I have 3 videos on all those topics prior to this video. I think all those would be good to understand before diving into mapping over stuff. But I open up curly braces because I want to enter JavaScript land. And then on my key points array, I call the .map method. So this is just a JavaScript thing. I'm using an array and using array.map. And then I am passing in an inline function. I am accepting the point as well as the index that you get on the map method. And then I am implicitly returning. So remember with arrow functions, if it's on the same line here, it's going to be an implicit return. I'm implicit returning this parenthesis that within the parenthesis, it's going to have an LI, a list item, in which it's going to have a class name. It's just going to add some classes for Tailwind CSS. And then it's going to render my point, which is just going to be a string within this array right here. So I have my array, I have an unordered list. You could also have an ordered list, an OL or a UL. And then I open up curly braces to enter JavaScript land. And then I call the map method on the array. And then in that array, I return a list item for each element within my array here. And then I render that content out. I also mentioned that you could definitely filter it. So I could say const filtered array, and then that is equal to keypoints.filter. And then, I don't know, we could say item, we want to return true to filter it into the array. So I'll say item dot maybe includes keys. So only render the points that include keys here. And then instead of rendering our key points, we're going to render our filtered array. So I'm going to do that here. You're going to see I now only have 2 items here within this array. Both of them contain keys because I'm now rendering the filtered array. So that is how I would filter your arrays. I would create a separate array using the filter method, and then I would return that array down here. But this is mostly just JavaScript here, creating a new array that you can then map over within your return statement. but we're going to come back. We're going to get rid of the filtered array and just render our key points array. One thing I touched on earlier is that each item in the list should have a unique key prop. So you can see for this list item that we are returning, it has a key prop right here. Now, it's important that you understand a few different rules to keys. So for one, the reason that they're needed is that keys help React identify which items have changed, are added, or are removed. This allows React to correctly update the DOM. So these keys basically allow React to have some sort of unique identifier to know what item is what. And it allows React to know what the item's position is within an array, which is important because if you remove items from the array, if you add items to the array, if you reorder the array, it's going to allow React to still render things correctly on the page because it knows what position that item was in or should be in. Now, in order to allow React to correctly know the position of the items, it uses this key, and this key, it should be unique and it should not change. And it's best to use a key from your data rather than generating it on the fly. And then I mentioned, for example, with indexes because those reorder. So you shouldn't use an index like I'm doing here. So I'm generating these keys on the fly here. So I'm using the index and I'm using this here. But if I remove elements from my list here, so say I had like a delete button and I could remove this li or the user could, well, that element is now going to have a different index because I just removed the element from the array. So the index is changing, and keys, they should not change. They should be unique. And it's best to get the key from your data. So what I mean by this is it's best to, like within the array itself, maybe you have an ID from your database that you use, or maybe you have some sort of unique identifier within the data itself rather than just trying to create a unique identifier on the fly. That's almost always better to do. So what we're going to do is, instead of just rendering this array of strings, we are going to use this array of objects that I've created right here. I have this key points too. It's a different array, but now you can see it's an array of objects in which each object is going to have an ID, which is going to just be a unique ID from this UUID library. And then it's going to have a text, which is the same as our text in our key points here. So now, instead of rendering key points, let's render key points 2. So I'm going to come back to my return statement, and we're going to render key points 2 for my key. It's going to be my point.id, since it's going to be an array of objects, and this is going to be point.text. Now I'm still using my index here for my style, so I'm going to keep that. But now my point is going to be the ID for my array of objects. And if we look at this, we can see that everything still renders correctly, and this would be the more proper way to do it, because this is going to ensure that the key doesn't change and it is unique. And React mentions that it's best to get these keys from your data, so like the database, or generating them like what we did here with a UUID library. So within the array itself, we give each item of data a unique identifier rather than trying to render it on the fly here. That's going to be a better approach. Now, lastly, you'll see that often lists are kind of abstracted into their separate components. So instead of just kind of generating the list and rendering it here within this JSX itself right here, let's create a different component here. So I'm going to, in the app directory, I'm going to create a new file, and I'm just going to say list.jsx to keep this nice and easy. I'm going to copy this key points 2 array, and let me just copy all this. I'm going to paste it here at the top of this file. I'm going to go back into page.jsx, and then we are going to grab this UL right here, go back into list, and then I'm going to say export default function list, and then it's just going to return that UL that maps over our key points and renders that out. And then we're going to take this list component, go back to our page, and then in place of this UL, we're just going to render our list like so. Now, another common way that you'll see this done is we might have a data prop here to where it has like the key points data, and then our list just renders a list of data. That's also very common, but we're just going to keep it as rendering the list and having the data within the list itself here. So if we come back, we see no real change in our web page because we are doing the same thing here. We just abstracted this rendering logic of the list out into its own separate component, which is very common to see. So in React, to render lists, first you need to have an array of different items. Now you can filter this array if needed and create a new array, but you need an array of some data. And then once you have that array of data, you can use the map method to map over that data and return a list item for each instance of data within your array, or each item within your array. And you can return this list item within an unordered or ordered list, just like you would with regular HTML, and then make sure each list item has a key. And importantly, this key needs to exist on the outermost element of the item that you are returning from your map method. So if I returned like a div wrapping around this list item, then my key would need to go on the outermost element, which would be my div. So I would put my point.id on my div. I would not put it on my list item. So it needs to be on the outermost element, but you need to render a key that is going to be unique as well as unchanging for each item within your list. And this is important because it allows React to identify which items have changed, are added, are removed, and helps React update the DOM accordingly. And then also it's best to have your key unique identifier within the data itself, like what we did here, or it comes straight from your database like that, rather than trying to generate it on the fly using an index or something like that that might be much less stable. And then as we covered finally, it's very common to extract your list into its own separate component and then maybe just pass data to that component and render the list. So hopefully this video helps you out with rendering lists in React. Today, we're going to cover a very important concept to understand about React that is going to allow you to reason about and debug your applications and create better overall React applications. And what I'm discussing here today is thinking about your UI, your user interface. So these card components, and I've created this website is just a demonstration website to show you some examples here, but we have our UI here. So these card components, this button, this form, what the user sees is our user interface, what they see and interact with. But thinking about it as a tree-like structure can make a reasoning about things and your performance. It can help you improve your performance. It can help you debug when things go wrong. So this concept is pretty important, and you'll kind of hear some of the terminology we discussed today throughout your React developer career. So I'm going to first go over several just kind of high points about this tree-like structure, but then we will show you kind of some examples of how these kind of components fit together and where this can be useful. So number one is your UI is a hierarchical tree structure. So React conceptualizes the UI as a tree of components where each component represents a node in this structure. Now, in this UI tree, your components act as nodes with parent and children and sibling nodes. So let's kind of go to an example right now. So here we have our different components. So we have a card component right here. We have a button component here. We have an overall dashboard component we have this form component here with a name and email, and then we reuse this button component within this form. So on its surface, this UI looks pretty straightforward, but there's actually a decent amount going on here to where if we look at the code, one important concept is understanding the root component. So the root component, it sits at the top of your component tree. It is the kind of rootmost or topmost node throughout your tree-like structure. So this root component, it's going to render all of my other components within my application. And this is important to understand because that root component can be a very critical component when it comes to state updates within your application, passing data and props down your tree-like structure and allowing React to kind of efficiently update state. And it really kind of sets the stage for your application. So this root home component, it renders this dashboard component. So this dashboard, it's considered a component or a node in our tree. And since our homepage renders this component within its return statement, this dashboard is considered a child to our homepage. Now, if we go to our dashboard component, so I'm going to command click on dashboard, we can see that dashboard, it renders several other components where our dashboard renders a button, a card, as well as a form component. This dashboard, not only is it a child to our home page here, but it is a parent to this card component, this one here as well, and it's also a parent to this button and form component. Now, these cards, as well as the button and form components, these would be considered sibling nodes within this tree because they are rendered next to each other. In this dashboard component, you can see it has the text, your UI is a tree. Our dashboard is our overall dashboard component right here that renders both of these cards. It renders this button, and then it renders this form component that also renders another button component. So our dashboard is the parent to all the components we see here on this page. Now, when updates happen within our dashboard component, React will efficiently update the UI by traversing the kind of component tree. So starting at our homepage, our root component, and then deciding what components actually updated, and then efficiently updating only those nodes of our tree. Props can be passed down from parent to child components. So here in our example, in our dashboard parent component, we are passing these props to the card component as well as this button component. But it could go further. We could get some data in our home component here. We could pass this data into our dashboard component. And then when that data is available within our dashboard component, we could then further pass that data down into our card components and our button components because those are all children of our root component where we might be getting that data. So in an application like Next.js, it's very common to fetch your data in server components these days and then pass that data down into more sibling components. So we might get that data here in this home component, pass it down into the child, the dashboard, and then dashboard has its own children that we could pass that data to. And then if we go into the form component, you can see that it renders another child button component to where we could pass that data further into. So understanding this tree-like structure, this hierarchy, is going to be helpful when you're passing props or you're understanding how data flows throughout your application, which can be really crucial for the performance of your application as well. And not only can it help you understand how data flows throughout your application with props and state management and all that stuff, and we've covered props, but we'll cover state management in future videos. But like this can also help you understand the kind of more complex pages throughout your application. If I understand kind of this tree-like structure, and this tree-like structure is not unique to just React apps. The HTML DOM uses a tree-like structure. The CSS I believe is what it's called, also uses a tree-like structure. So understanding parent and child relationships and different nodes or root nodes, leaf nodes, sibling nodes, is very important for you to kind of conceptualize and organize your application and also help you kind of create performant applications as well. But here we have our dashboard page, which, it's not crazy complex, but even here, it's kind of helpful to know that, okay, we render our root dashboard page, and then we render two card children elements that are children to our dashboard component. And then we also render a button that is a child to our dashboard component. But then we render a form that renders its own button component within the form. So we kind of have this nice tree-like structure to where if we notice an error comes up in our dashboard component, it's helpful to know this tree-like structure because maybe that error came from a deeply nested child component. Okay, so just to recap here, in your React applications, it's helpful to think about your components and your overall app as this tree-like structure. And the reason this is important to understand is because it will help you conceptualize how data is flowing throughout your application, how state is being managed, and we'll of course cover state in future videos, but how state is being managed, how performant your application is. It will help you kind of piece together more complex UIs and understand how that's all working. It will help you avoid some maybe poor designs when it comes to just making non-performant choices when creating your own tree-like component hierarchy. And it can help you understand how like trees are being traversed and how state's being updated and all that stuff. And just to kind of go over the terminology one last time, you're going to have a root component, which is going to be your very kind of base component that renders all of your other components. So in our case, it is our home component. It renders a child component because it returns this component. This is a child component to our home component, our dashboard. And then our dashboard, it is going to be a parent component to these card components as well as the button and the form. But the card components, as well as the button and forms, these are all going to be siblings to each other because they're all rendered within the dashboard. But then this form component takes it a step further and renders a button component within it. So our button, it is going to be a child to our dashboard, but it's also a child to our form component. So you can nest these components further together and you're going to have these parent-child and sibling relationships that is important to kind of conceptualize and understand. And it can be really helpful once we go further with state management. And you probably already saw some of it with passing props and stuff like that. But I just wanted to make this quick video to kind of go over and reiterate some of these concepts around parent and child relationships, root components, and why it is important to kind of at least have a somewhat understanding of how all these things fit together and some of the terminology with it. So today is going to be a quick video explaining what state is in the context of React.js. And I know that when I was first starting out, this was kind of a tricky concept to kind of fully grasp. Now, the technical definition of what state is state represents data that is changing over time. Now, what does that kind of mean in the context of a web application? Well, if you think about it, your application, and I've just created this kind of demo application. We're going to add some different tasks here in a second to kind of show you some examples. But if you think about your application, really your user interface, which is what React is concerned about, creating your user interface, what the user sees and interacts with. If you think about your application, it really is just an output of whatever data you have flowing throughout your application. So maybe you have a database that returns a list of e-commerce items, and then you display those on the page. Well, your application is just reflective of whatever data is kind of flowing through it. In that example would be those e-commerce items, that data that you return from your database, and then you show those to the page. But in React, if those items are static, then they're not really considered state because that is just data that is not changing over time. Whereas in React, state is going to be data that changes over time, not static data. So in this example here, a user can type into this input and add different tasks. So I'm going to add task 1, and then I'm going to click add. And we've added a task. So my application here, it's showing task 1 here and a remove button, but it didn't show it a second ago. So it now represents this data that the user added to the memory of my application, but it changes over time. Like I can remove this. And now the state of my application, it has no tasks. So that task or our task list here, so I can add task 1 and our application has 1 task. I can add task 2 and now it has 2 tasks. You can see our task list is changing over time. So this is data that in this case, the user is inputting this data, but it's data that is changing over time. So these tasks would be considered state in React. It's data that changes over time. Now, in future videos of this React series, we're of course going to cover how to manage this state and the best ways and best practices to do so. But just remember that in React, your state is data that changes over time, and often it's going to be in response to some certain user events. So here, the user, and even in this input here, this input text is data that changes over time. So you're probably going to create a piece of state data that changes over time for this input. So this input state, there's nothing in it right now, but now the input state would be task 3, but we can change that really easy. And now it's just task th. So this is also data that changes over time, as well as my task list here, because I can add and remove different tasks. So anything in your application where it can change, maybe in response to interactivity from the user. So typing in an input, clicking a button, or several other scenarios to where you can have your application change interactively. That is where you're going to be using state in React. All right. So hopefully that makes it a little bit more clear on what state is, but stay tuned because future videos, we're going to cover the best ways to manage state and maybe some tricky things about state management. And generally, state management can be pretty tricky, especially in a larger application and you have a lot of data flowing through your application. It can be challenging to reason about, but we're going to try to go over the best ways to manage that state within your applications. So state is data that changes over time, often in response to user interaction, and React gives you several ways to add state and manage state. And it's just a concept that is important to understand. So I thought it was worth its own video here. So today you're going to learn everything you need to know regarding handling events in React.js. We're going to discuss what events are, how they work, how to create different handlers for events, the best way to create those handlers. We're going to discuss passing event handlers as props and a bunch more stuff regarding handling events in React. So I've created this website here. This is just for example purposes to show you some examples of handling events here. So you can find the final code linked down below. But to start us off, what even is an event? Well, this isn't really a React thing. It's more so a web dev thing just in general. But an event represents some sort of user action. So what I mean by that is, say a user clicks on this button here, or they type in this input here, or they even hover over this input, or they fill out this form and then they press submit. All of those are considered different events that the user takes. And when writing code, you can respond to those events. So a user clicks on this button. What do you want the next step to be? Or what do you want the resulting action to be? For example, they might click on this button and you might navigate them to a different page. Or they might submit this form and you might want to save their form data in your database. Or you might want to send them a confirmation email. That would be you as a programmer writing code to respond to these different user events. So that's generally what events are, but how do they kind of work in a React context? Well, it's going to be very similar to just a JavaScript context in general. So what I'm going to do is we're going to head over to our code base here in VS Code, And I've created this events page here, and it's exactly what you see on the page. I have a button here that says click me. You see this button here that says click me. I have an input here that says type something. I have an input here that says type something. And then we have our form below our input right here. And then we have our form right here. So this is the code for the page that we're seeing here on localhost 3000 here. So the way that you can handle these events, we're going to focus on the button first, and then I'll show you the input and form, because these are probably the most popular events, although, there's a ton of different web events that you can handle, but it's all going to kind of follow similar concepts. So this should help you out for really handling any events. And I'm going to make sure to just close my application folders here, just so we have a little bit more screen real estate. But in order to handle event, you're likely going to pass some sort of prop to the element that you want to handle the event on. So in the case of this button here, this is the element we want to handle an event on. And the event that we want to handle is an on-click event. Now, here you can see us passing this attribute to this element on-click. In HTML, this is going to look like on-click. You can see in React, it's actually going to be on and then capital C for click. And that's going to be for most of your events. It's going to be on change instead of all lowercase on change. And that is just how React handles attributes compared to HTML, to have some sort of differentiation between those, similar to how it's class name instead of just class. All right, so you're going to pass some sort of event handler attribute to the element that you want to handle that event on. So in the case of a button, we're passing an on-click attribute, and then we're setting that equal to a reference to a function. So we're basically going to pass a function here that is going to tell React, this is what we want to do when the user clicks on this button. So if we look at our handle button click function, you can see it's right here. We define this const handle button click, and it's a function that calls an alert that says button clicked. So when they click on this button, you should see an alert called button clicked. So if I try this and I click on it, you see an alert that says button clicked. So what we're doing here is we're passing an on-click attribute to where when the user has the event of clicking on this button, we're going to pass a reference to a function, and that's going to run the code for that function. So it's going to be alert button clicked. Now you could, of course, change this. This could be a console.log button click. And if we open up our console here, and now I click on the button, you see I get button clicked over here. Just to show you that whatever we put within this handle button click function is the code that's going to run when the user clicks on this button. An important distinction here is that we pass a reference to a function. We don't call a function itself right here. So we're not calling the handle button click function immediately, because that's going to then run this function every time this component renders, rather than only running this function when the user actually clicks on this button, which is what we want. So make sure to pass a reference to a function. Now, you don't need to define the function outside of the attribute itself. We could pass an inline function here, like so, an anonymous inline function that just console.logs, this button was clicked, and we are handling it within an inline function. So this time around, we're still passing a reference to a function here, because we're not just like immediately calling this console.log. We're passing an inline reference to a function that's going to console log this. So if we come back, I'm going to open the console again, and then I click it. We see this button was clicked, and we're handling it within an inline function. So you can either handle your events by passing an inline function right within the attribute itself, or you can define your handler function outside of the attribute itself. Now, my preference is if it's something that's super small like this, I'll just pass it as an inline function. and it'll just be a quick inline function, and I think it's plenty readable and is a fine thing to do. But say you have a lot of code that you write within this handle button click, and it's like some complex logic in here, I wouldn't try to put that all within the return statement and in the attribute as an inline function here. I would definitely pull that out into its own handler function. I think that's a much better idea to do. So if it's just like a simple single line, I would pass it as an anonymous function. But anything much more than that, I would create a whole separate function like we did here, and then pass the reference of that function in to the event handler attribute here. So for this button, that's how you can handle on clicks. Now, a very similar thing we would do for an input. So an input, most of the time you're going to care about the on change event. So when the user starts typing into this input, you're probably going to care about what values are changing in that input as the user is typing. So to handle that, you can use the on change attribute. And like I said before, there are several different on attributes: on change, on click, on hover, on mouse in, on mouse, leave, a ton of different attributes that you can just Google search and find if you need to handle a certain user action. But here we're going to handle the on change, and we do the same thing. We pass a reference to the function, like so, our handle input change, and then we write some code for what we want to do with that kind of event that the user takes, or the action the user takes. So earlier with a button, we didn't really worry about the event object. So in just web development, automatically when you pass these event handlers, you're going to be passed an event object that represents the user event. So in our handle input change, right now it has an alert, but I don't necessarily want to do that right now. Let's just console.log. Input value is changed to this, but let's also console.log the event. And you can see I am passing a object here to the console.log statement. And the reason I like doing this is because, so I'm passing an object where the event property is equal to the event that we're automatically going to be passed from the browser here to our handle input change. So we pass a reference to the function, and then we're automatically from the browser going to get the event from this on change. And it's going to be an object representing whatever user action took place. So it's going to automatically going to be passed here, and then we're just going to console log that. And the reason I like to do it within a object here, like I was saying earlier, is because it gives me a label for the event. So we're going to see in the console an object where the event property is E. So if you're console logging several things, I might do another console log to see like some other value. So some other value, and then I'll set this to that value so you can have like a nice readable console log statement. But let's go ahead and change this input and see what happens. So I'm going to open the console again. And when I start typing into this event, you see that we get a synthetic base event. So this is basically React wrapping the just browser event here to kind of give you some other things. But for our purposes here, just know that the browser is going to automatically pass this event object that is going to have several different properties on it that are going to allow you to better handle that event. So in our case, you can see in our other console log statement, we are saying input value change to event.target.value. That is basically how we can get the value of the input, because the event.target is going to represent the element in which the event occurred on. So in our case, that's going to be this input right here. And the value is going to be the current value of this input. So if we come back, we see input value changed to RGF. So what was it here? But I'm going to say some value here, and you can see input value changed to some value. And on the event that we console log that is passed to us automatically, if we go down to the event.target, and then we look at the value here, you see it's a string that says some value. And you can see there's a whole bunch of other different attributes that you could use that are potentially useful on your event objects that allow you to best handle these user events. In a click event, we didn't use it, but just know that on this handle button click, we could also accept an event here, and then I could console.log, and this time around, I'm going to say button click, and it's going to point to this event. So if we click, I'm going to clear this. Let's click on the button, and you see button click is going to be a synthetic base event that React gives us wrapping around the actual event. But you can see it gives us an event object where the type is click. The target is going to be our button this time because the element that was clicked or the element that we're handling that event on is this button here. So that's going to be our event.target. And then if I open up this target, you can see a whole bunch of different information about the button element itself. And you can see the inner text is click me, just like what it is here. So you're automatically passed an event to the function you reference. So this would be like the same thing is if we passed an inline function, it would accept this button event. And then we could just console.log the button event because we're automatically going to be passed as an argument to the function that we pass as an event handler, an event. So now if I click it again and I scroll down here, we see a button event right here that represents our handle click event. Now let's move to the form element here. So for our form, we see handle form submit. We have a button of type submit, which is going to trigger our on submit of our form. So this is more so HTML stuff rather than React stuff. But on a form, one way to handle the submission of a form is to set a button as type submit, which is going to trigger whatever function you reference in your on submit of your form. So when this button is clicked of type submit right here, when this button is clicked, it's going to trigger this on submit attribute that we pass as a handle form submit function. So if we go to our handle form submit, we see that first we call event.prevent default. This is also more so just a basic web thing, not really React thing, but we want to prevent a default submission of this form making a network request. So we're going to prevent the default behavior of this event. So we're using that event object that I just told you about earlier that is automatically passed to handle form event. We're going to get this event object. We're going to prevent the default. Then we're going to create some new form data based on the event.target. So the event.target in this case is going to be our form element here, because the form element is what we handle this on submit attribute. So the user clicks submit and the target is going to be the form. We're going to create some new form data based on, we get this out of the box for free here in our environment, in our JavaScript environment. So we create a new form here, and then we just alert form submitted with name, which is going to be the form data.get name, and then the email, which is form data.get email. So when we create this new form data based on our event.target or our HTML form, it's going to give us these .get methods to get the name and email from our form, which are going to be accessible or input right here that has these email attributes, and same thing with our input here that has these name attributes. So if we test this out, I'm going to say my name is Ryan, email at email.com, and then I'm going to click submit. And we see we get an alert saying form submitted with name Ryan and email at email.com. So that looks like it's working correctly here. We call our handle form submit. We take the values from our email and name inputs. We alert them right here with our form data.get name and .get email. Now, one other thing I want to cover before we wrap up here is it's very common to pass event handlers as props. So I'm going to create a different component here. And if you see this use client up here, it's just I'm technically in a Next.js environment right now, but use client makes this be just basic React.js. So don't worry about that. That's nothing specific to React, it's more of a Next.js thing, but I'm going to create a new component here that's function button, and it's going to take a handle click prop, and then this button is just going to return the same button that we have right here. But I'm going to copy and paste that within the return statement. But instead of passing an inline function here, we're just going to call the handle click prop for our button component. So we just created this button component, and now we can use it here instead. So I'm going to use our button component, but then I need to pass a handle click to this button, and I'll just pass our handle button click. So this is just to show you that if you have a component that you want to have some sort of event handler, it's very common to define that event handler in a parent component and then pass that down to the child component. That's perfectly okay to do. So if our handle click here, we assign it to our or reference our handle button click function, and then within our button component, it should use our handle click prop and use it right here on our button's on click attribute. So if we test our button again, let me clear the console, we see it's still console logging what we would expect. So it's perfectly fine to pass event handlers from parent to child. I think that covers about everything I wanted to cover here when it comes to events in React. Of course, there's always more that you can know, but I think these are some really good core concepts. And these are also like the main events that you're probably going to handle. Click events for buttons, change events for inputs, and submit events for forms. Those are going to be like the bread and butter of events that you handle. So just to recap here, to handle events in React, you're going to pass some sort of on event handler to an element. So on change, on click, on hover, on submit, something like that. And then to handle that, you're going to pass as almost as like a prop or as the value to the attribute, you're going to pass a reference to a function. And it can be a function that you define externally, like we do here, and then pass it into the attribute, or it can be an inline function like so. Either way, whether it's an inline function or an external function you define, you're automatically going to be passed an event object that is going to better allow you to handle that event. And one major value you're going to use is the event.target, which the target represents the element that that event occurred on. So in our case, it would be this input right here, would be the event.target. And then in the input, you can get the event.target.value to represent the current value that's in the input. And if it was an inline function, you'd accept the event right inline like so, and then use that within the body of the function. If the event has some sort of default behavior, like a form submission, you can call the event.preventDefault to prevent the default behavior. Very common to see that with form submissions. And then it's also perfectly acceptable to create an event in a parent component and then pass that down into a child component, like what we do here with defining this handle button click, passing it into our button component that we created, and then using that within the on click of the button returned from this button component. So when it comes to handling events in React, there's a very common mistake that beginners tend to make. And in this video, we're going to cover this mistake. And if you hang with me, I'm going to give you a more intermediate kind of bonus tip as well here. But this mistake revolves around event handling. And I'm going to show you an example of this in a sec. I just created this very, very basic web page, although I do think it's beautifully styled if you ask me. But what an event is when a user performs some sort of action, and then maybe you do something as a programmer to write some code after they do that action. That didn't make a ton of sense, but let me try to show an example. So like one event would be a user clicks on this button. And then after they click on this button, maybe you want to show, I don't know, some sort of toast message, or maybe you want to hit an API endpoint to get some data or something like that. The user does some action, clicking on a button, and then you as a programmer respond to that user action with something else. Maybe you, like I said, get some data, save some data to your database, something along those lines. It could also be the user starts typing it into an input or they submit a form. That would be a user event. Now I'm going to create a full video on handling events in React, and we're just going to focus on kind of this mistake in this video. Now, if I go to the code for this website, you're going to see I just have this home component, and that's what I render to the page. So avoid this beginner mistake in React. You see that displayed on the page here, and then we render out this test button as well. Now, typically, you handle events with some sort of on attribute. So it could be an on click. In a button's case, this is usually what it is. But if it's an input, it can be on change. If it is a form, it could be like an on submit. And then there's also like on hover and on mouse enter, on mouse leave, and different events like that. But typically you pass an attribute like so to your element. So here, this is my button element within my opening tag here. I of course have this class name as an attribute where I'm adding these styles, but then I also add this on click handler. And then in React, you're going to set this on click is going to be equal to, and you can pass a function to this on click. So what do you want to happen when they click on this button? Now, this could be an inline function to where I just pass a function and then maybe I just call an alert and I say clicked. So I can pass an inline function like so. And then if I click this button, we see an alert that says clicked, which is what we expect. But we can also create a function up top saying handle click. And then I can just do the same alert. This says clicked, but then I can pass handle click to this function here. And if I click this button, you're going to see I get the same result. So you can pass an anonymous function or kind of an external function and pass in the reference to the function, which is the key mistake that beginners tend to make. Instead of just passing the function reference here, they will actually call the function within the onClick itself. So doing something like this, and you can see it automatically alerts it right away and brings me to this page, because what this is basically doing is, and I just remove that because it kept causing that alert, which would take me back to the browser. But basically when I have this right here, every time this component renders, it's going to call this handle click function, and it's going to call this alert function, which is not what we want. We only want to call this when the user clicks on this function. So make sure to only pass a reference to a function. So handle click without the parentheses. You don't want to add the parentheses here. You just want to pass the reference to a function. And that's also why I passed an inline function here that then calls the alert function, because I am just passing a function reference and then it's going to call the alert once this button is clicked. I do not want to just say alert and call that immediately, because that's also going to call that every time this component renders, rather than only when this button is clicked. Now, often I think that when you pass like arguments to a function, this is where people can kind of accidentally do this. So let's say this handle click expects some text here as an argument, and then it calls our alert function with that text. And then we want to use the handle click here. Well, people will be like, okay, I passed the reference here, but I need to pass this argument. So I should just, put the parentheses and then pass this argument. But this is incorrect, because like we just talked about, I am calling this handle click function every time this component renders now, which is of course not what you want. You only want to call this handle click function when they actually click on this button. So to get around this, what you can do is pass an anonymous inline function, and then you call the handle click with clicked. And that's going to work just as you expect. All right. So make sure you pass a reference to a function instead of calling the function itself within the onClick. Now, as the bonus tip here, for testing purposes, I really like to create the handle functions or your event handler functions outside of the component itself whenever possible, because this is going to make it a lot easier from a testing perspective. Because then when I make it outside of this function, I can actually export that function and test it. Because doing something like this is not going to work. You can see I get an error. Modifiers cannot appear here. However, if I pull this handler function outside the body of my home component and I put it right here, you see I don't get any errors, which is going to make this handle click far more testable compared to creating it within the body of my home component here. And I can just write a nice clean unit test for this to where, I call it with certain text, and then I verify that alert has been called with that given text that I called it with. So as a bonus tip, if possible, it's not always possible and doesn't always make the most sense to do it that way. But whenever possible, I try to make my handler functions outside of the component itself, because that's going to make it really easy to export those functions and then test those within unit tests if you're doing a lot of testing within your application. How does state really work in React.js? Well, in today's video, you're going to learn just that. You're going to learn about the use state hook and what state is, and we're going to show some examples along the way. So I'm going to link this kind of starter project in the description below. If you want to follow along, you can just use git clone to clone this repo and then run npm install in your code editor of choice, and you can follow along here. But to start here, state is a component's memory. It represents the current data on a dynamic page. So what does that actually mean? What does that actually look like? Well, we'll of course show what it looks like, but I think it also helps to show what this doesn't look like. So for example, we have this counter button here that shows the current count, and I'm going to open up our console, go to console, I'm going to clear it. And if we go to VS Code here within this project, you're going to see I have this component or this function called React state. I set a global variable, let count is equal to 0. And then this is where I render how does state really work in React. And then our count button with the current count. And that displays our count variable right here. And when we click on this button, we call this handle increment function on this on click, which is this function right here. It should increment the count. So plus equals 1. So increments the count by 1. And then also in the console, it's going to console.log the current count. What you would expect is if we click on this button, it's going to increment the count, and then it's going to show the current count right here on the page. So let's go ahead and see if this works. So I'm going to click on this. You can see it doesn't change what we see on the page, but the values in the console are actually showing the incremented number. So we see all these numbers going up, but it's not showing on the page. So what's going on here? Well, this component, it's not getting its memory updated. It's not being representative of the current value in this dynamic page. By dynamic, I mean that the user can interact with this page and the values of this page can change. So if the data on a page can change and those changes can occur over time, then this is a dynamic page and it's going to need to use some sort of memory for this component. So it remembers what the current data of the page is. Because if it has no way of remembering the current data of this page, it's not going to be able to show the user the correct page that it should see for the current UI. And this memory is state. So the state of our web page right here is a count of 0. But how can we make sure that the state updates and actually shows what our current count should be? Well, a lot of people would say you should just, use a JavaScript variable and update that variable. Well, we can see here that this doesn't work. React doesn't work that way because in React, you need to use something called a hook that allows you to, when you update a variable, it actually re-renders this part of the web page and it shows the updated variable. So the way that we can actually do this in React and we can add state to this component is we need to use the useState hook from React. So to do this, I'm going to get rid of, we'll keep handle increment for now, but in the body of this function, we're going to say const state is equal to useState, and we are going to import that from React. So import useState from React, and we're going to call this function. Now, there's a couple of things that you should know about useState. For one, you can only call a React hook, which is useState, and generally a hook is a function that React is going to give you from its library. It's going to be a function that you get out of the box in React, and you can import that into your components, but it's going to be a function that allows you to hook into React features. And these features of React are going to be things like state and using effects and using references to variables, and we'll cover this stuff as we go. But hooks are just functions that you get from the React library. They're functions that you get out of the box that you can use within your application to allow you to hook into React features. So we're using this useState hook, and it's just a function from React that is going to allow us to use the feature of React called state, which state, it's going to allow us to have components have some sort of data over time or some memory of data. So we can have this changing data over time. And this could be for account, it could be for text inputs, it could be a whole bunch of stuff. And we'll show you a to-do list later on just to show you another example. But we call this useState hook. But what we need to remember is that when we call the useState hook, we're going to call it with an initial default value. So we're going to initialize our count to 0. So we're going to initialize useState with 0. So we're going to call it with that value. And now let's just console.log our state to see what that looks like, to see what useState returns. And if we see state right here, and I open this up, you see it returns an array to where the first value of this array is 0, which is the value that we initialized useState with, or we called useState with. And then the second value is a function. So what useState returns here is an array of 2 values. The first value is going to be your current state, which we initialized it to 0. And then the second value is going to be a function to update your current state. And what you will commonly see this written as is instead of just saying like const state is equal to useState, you will see people automatically destructure the first and second values from useState. So it will actually look more like this. I will destructure using square brackets the current value, which I'm going to call count, and then the second value I'm going to call set count. So useState returns an array of 2 values, the current state and a way to set the state or update the state. And we are automatically destructuring those values using JavaScript destructuring syntax to get to the current count and a way to set the count. And I'm going to remove this counter here. And I'm also going to remove this console.log statement. So now we have our count and set count functions, but instead of just setting our count like this, we now want to use our set count function. So I'm going to say set count. Well, how should I do this here? Should I just say it's count plus 1? Well, a better way to do this is when you are using the state setter function from useState, you can either call that state setter function with just like an absolute value. So I could set the count to 4, or I could set the count to 10. And that's going to update the state to whatever value I pass in here. But sometimes you want to set the state based off the previous state. And anytime you want to do that, it's actually best to pass a function to your state setter function. So here, I'm going to pass an anonymous function, and it's going to give us the previous count as an argument automatically. And then I'm going to set the current count to the previous count plus 1. So what we're doing here is we are passing a function to this setter function return from useState. We're passing a function into it, and React is automatically going to pass our previous count to that function. And then we want to just return our updated state based on our previous state. And in this case, we want our updated state to be our previous state, our previous count, plus 1. And now, if I click this button here, you see we are getting our updated state. And I'm going to clear my console, and then you can see our console now matches what we're seeing here. And the reason this works is because when you use this state setter function, that is automatically going to tell React that it needs to re-render this part of the page because you set a new piece of state, so you need to re-render this component. So anytime you set state in React, it is going to re-render this component, which is going to give the updated value to the page, which is now going to allow this component to show this updated data over time, or to kind of remember the current data of the application or the current state of this page. One thing that's important to understand about state and components in general is that each component is going to have its own independent private state. So the way I'm going to show you this is we're going to create a new file, and it's just going to be called count component.jsx. And technically speaking, we are working within a Next.js application, but to make this just be React, just put use client at the top of the page. It's going to just make this a React component here, but that's a Next.js specific thing. What I'll do is I'm going to say export default function count component. And then what we're going to do is we're going to take this button right here, and we are going to return that in this component. We're going to return this button. And then we're also going to take this logic right here. We're going to copy it, and we are going to paste it here, and make sure that you import state from React, or import useState from React. And then I'm going to remove this console log here because we don't need it anymore. But now we've created our own count component. So within this page, we can remove all this logic here. And instead of hard coding this button, we can just render our count component. And if I didn't mess anything up, we should see that we have the same exact user experience here to where we see this. However, like I was saying earlier, each component has its own independent private state. So if I render another count component here on this page, what you're going to see is now I have one counter that has the count of 9 and another counter with a count of 0. And I can increment these independently of each other. So they have their own private state here, because in React, this component is going to have its own private state, and so is this component. So each component can separately remember their current data or their current values. So just keep in mind that each component is going to have its own private state. Even if you render the same component twice on the page, those components don't really know of each other. And when I update the state in this count component, that is the only thing that's going to re-render on this page, is this component is going to re-render. But then if I update this count component, that component is going to re-render. And they don't really know of each other on this page. Those are the only sections of this page that are now going to be re-rendering. So each component is going to have its own private state, even if you render the same component twice on the page. So now that you kind of know what state is, how the useState hook works, and some other principles of using state in React, a good test for you is if you can now create a to-do list. So basically just a list of text that when you have an input, they can type in the input, they can select add to do, and it is going to add a to do to the page. And for the sake of this, maybe don't worry about deleting to-dos. Maybe I'll do that in my example. I'm not sure yet. It's going to be a surprise, but see if you can build that. But I'm going to move on and build that right now. So if we want to add to-dos on this page, well, what I can do is we can create our own to-do component. So what I'm going to do here is do a new file, and I'm going to say to-do component.jsx. We're going to say it's a use client. Just put that at the top of your files for now, just to make sure everything is just basic React here, client-side React. But I'm going to say export default function to-do component. And what are we going to need here? Well, we're going to need a to-do list that we're going to update. So this page, it's going to have an input to add a to-do and then a to-do list. So we're going to need const to-do list, comma set to-do list is equal to use state, and we're going to initialize it as an array. And that's an important thing as well. You can initialize use state with numbers, strings, arrays, objects, really whatever you want is what you can initialize it with. So we're going to initialize our to-do list as just an empty array. And then we have our set to-do list function. Now, we're also going to want, and let me also import useState from React. What we're also going to want is we're going to want to have an input on this page that the user can type into and add a to-do. So we're going to say const to-do input and set to-do input is equal to use state. And I'm not really going to worry about styling at all right now. We're just going to render an ugly component onto our page. And I think that's going to be just fine. But what should we initialize this as? Well, I think it's going to be best to initialize it as a string. So we're going to initialize our to-do input as a string. And now we need to return. Well, what do we need to return? I'm just going to return a wrapper div, but then in this div, I'm going to render an input that is going to be of type text. And we are going to say that the value is equal to our to-do input. And then for the on change of this input, we're going to pass an inline function in which we're going to set the to-do input. We're going to accept the event here, and we're going to set the to-do input to be the event.target.value. And I think that's all we're going to need for that. But then we're going to have a button here that's going to say add to do. When we do an on click for this button, what we're going to want to do is I'm going to pass an inline function as well. You could, of course, put these in their own functions up top here, and maybe that would actually look better in this case. But what we want to do is we want to set the to-do list with our new to-do. But we want our to-do list to be our previous to-do, so we're passing in a function to our set to-do list. And we want to make sure we return an array where we spread our previous to-dos, but we add our new to-do. Our new to-do is just going to be our value of our to-do input. So we have our input that is going to set our to-do input to be our event.target.value. And then we have our button that is going to set our to-do list when we click the add to-do button. And it's going to set it to be our previous to-dos. And it's going to return an array with our previous to-dos, but then it's going to have our new to-do in here as well. I'm going to open up curly braces, and we're going to take our to-do list. We're going to map over it, accept a to-do, and then we are going to return, I don't know, maybe I'll just return, I should return LIs here, so I guess I'll do that. And we'll render our to-do list within an unordered list here. and I'll move this up. I thought about just doing it with an array of like spans or something, which would also be fine, but probably not the right thing to do. And we'll just render the to-do within an li, and then we'll just set the key. We don't have an ID. We might add one in a second, but we'll just set the key to be a to-do right now. I think this might work. Let's go check. Let's remove one of our count components, and I'm going to now render my to-do list or my to-do component within our home page, which is called React State here. And if we come back, I'm going to close my console. We see our beautifully styled input, and I'm going to type in something to do, but I don't see anything because I think my text is white and my input is white. So let's actually add some styles here. So to do component, input, I'm going to just do style, and I'm going to set color is black, right? Yeah, that'll fix it. Okay. Something to do, and I'm going to click add to do, and hey, we added a to do. Now, one thing that we could do here is after we add a to do, we could also clear our text input. So for add to do here, I'm going to actually create a function called handle add to do. And we are going to take this logic where we're going to set our new to-do list like so. So set to-do list to be previous to-dos, return an array of all of our previous to-dos plus our new to-do. But then we're also going to set our to-do input to just be an empty input. So we're going to clear our input, and then on add to do, we'll just call this function instead. So now if I add another to do, you see it adds the to do here as well, but it clears the input, which is probably what we want here. And you can also see that our count button still works independently of our to-do list because our two components have two separate pieces of state, something to do 3, and all this is working well. Now, what if we wanted to delete a to-do? Well, we could do that fairly easily here. I'll show you this quick. What we can do is when we add a to-do, we probably want our to-dos to have some sort of ID. So we're actually going to make our to-dos an object in which we're going to say our text is equal to our to-do input, but then we're going to set our ID. We're just going to take the easy route and do math.random and make it a little bit hacky right now. You probably wouldn't want to do this in an actual application, but for now it's fine. But each to do now is going to be an object that has a text and ID property. And then we're going to render our to-do.text. But our key is going to be our to-do.id here. We also want to render, so instead of just rendering a list item, we will render our to-do.text. And then we'll also render a button that just has an X. And then our on click is going to be handle delete to do. But we're going to want to pass our to do ID. So I'm going to pass an anonymous function that's going to be handle delete to do. And we're going to pass our to do.id. And I'm going to create a function called handle delete to do. And then it's going to take an ID. And then what we need to do is we need to set our to-do list to be our previous to-do list without the to-do with this ID. So we want to pass a function here. So we get our previous to-dos. And then we want to return our previous to-dos dot filter. I'm going to accept a to-do. And I'm going to say to-do.id is not equal to our passed in ID. So basically return an array because the filter method on an array returns an array. Return an array where we filter in every to-do that is not equal to the ID that we pass for handle delete to do, which should be the to-do with an X right here. So I think this should work here. I don't know what's going on here. We did to-do.text here, which I need to refresh this because when I initially added my to-dos, I didn't add them with an object here. So I'm going to just refresh this page to clear the state, but I'll say add to do 1. So we see it now to do 2, add to do. And if I click the X, it gets rid of the right to do. Let's just add a few more to dos just to make sure I'm correct here. And we should be able to add specific to dos, and we can. And that looks like it's working correctly. So hopefully that example helped. Let's recap what we just went over here today. So state is going to be a component's memory, and it represents the current data of a certain component. And it helps you create dynamic web pages. So the user can click on these values, it can add different things to the page. And then this component right here, it remembers and it updates based on what the kind of user tells it to do, and it shows the current data of the page. Same thing with this count component. And a regular variable isn't going to work. A regular JavaScript variable isn't going to work because you're not telling React to update the page with a current new state or the current new data. So it's best to use the useState function from React, in which this is a hook, which is just a function from React that is going to allow you to hook into React features. In this case, useState is going to allow you to use the state feature of React, in which when you call this function, you call it with the default value that you want your state to be. And this can be a string, a number, an array, an object, a Boolean. And then from there, it's going to return an array of 2 values. The first is going to be your current state, and the second is going to be a way to update your state. And every time you update your state, it is going to re-render that component, so it shows the updated value on the page. So I click my count component, and it's going to re-render this count component with the updated state. And when you call this state setter, you can either call it with just an absolute value like we're doing here, setting the to-do input to be just a string, or you can call it with a function in which React is going to pass as an argument to that function the previous state, and then you can use the previous state to then return the new updated piece of state based on your previous state. And then finally, each component is going to have its own isolated piece of state. So even if you render the same component multiple times on the page, like rendering this count component multiple times on the page, we can use these components independently of each other because each component is going to have its own independent private piece of state. When I first started using React, I really didn't understand this concept very well. And after working in React for a few years, I'm coming to find that this isn't a very well kind of understood concept, although it is pretty straightforward. So I think, it's definitely not like you need to be a certain amount of smart. That sentence makes zero sense. So clearly you don't need to be that smart to understand this. I just think it's something that maybe you kind of forget about as you start working with React day to day, or you don't really understand right when you're getting into React, which is totally understandable as well. So what we're going to cover here today is rendering, what it is, what triggers a render, how does React even render a component, how does it change with re-renders, and then what does it actually mean to commit the render to the DOM. And then we're also going to show an example here. So first off, what is rendering? Well, rendering is basically when React calls your component and decides what to display on the screen. So in React, hopefully you've seen my videos on components, so you understand that a component is just a JavaScript function that's going to return some JSX, which gets turned into your HTML element and is what is displayed on the screen here. So if we go look at my code here, you can see that this page is a JavaScript function that returns this JSX that gets turned into the HTML that the user eventually sees on the screen. So when React renders something, it's going to call this function here, and it is going to decide what it needs to render on the screen. So that is what rendering is in React. Now, what triggers a render? Well, initially, React is going to render the root component of your application, and it's just going to render everything. So one trigger for a render is just the initial rendering of your web page. So the user goes to your webpage.com and your initial web page gets mounted. That is a trigger for a render. And React will call that root component and decide what it needs to render to the page. But another thing that triggers a render is that the component or one of its ancestors' state has been updated with set state. If the component itself is managing some state, and then you call set state within that component, React is going to render that component. However, if a component is a child to a parent component that also calls set state, the child component is going to re-render. So in this example down here of an input, when I start typing into this input, I am calling set state on this input to set a new state of this little component right here. So every time I press a new character here, I'm re-rendering this component with a new piece of state because I'm triggering this re-render with the set state function. So let's look at the code here. So if I come down, you can see I'm rendering this input component, which is managing this input value and set input value. So every time an on change occurs in this input, I call handle input change and I use this state setter from useState. I use this state setter to set a new input value, which is going to trigger a re-render of this input component. Now you're also seeing use client up at the top here. That's just to make this pure React and not Next.js, but I'm technically in a Next.js environment right now, but you can ignore that up there. Let's say that this input component rendered another child. So some child component, and we rendered that out right here. Well, every time an on change occurs here and I set a new input value, React is going to re-render all this code right here, which is going to include this child component. And then we're going to go re-render this child component. And if this child component has children components of its own, React is going to call and re-render those components and decide what UI it needs to render. And if those components have children, React is going to call them. So it's this recursive process where if a component sets its state, that component is going to re-render, and all of its children component are going to re-render, and all the children of those children are going to re-render, and so on and so forth, which I think is an important concept to really understand, especially once an application gets a little more complex and you have this large component tree that you're managing. But I'm going to get rid of this because that's not an actual component. So the initial render of the page triggers a re-render, and then if the component or one of its ancestor state has been updated with set state, that also triggers a re-render. Now, how does React go about rendering a component? Well, as I kind of already mentioned, on the initial render, React calls the rootmost component and renders your entire component tree. So the user goes to yourapp.com and the browser is like, hey, we need to render this page. That is where React is going to go to your root component on that initial render and render out your entire component tree as well as all of the HTML elements for your tree. However, on subsequent renders, React will call the function component whose state triggered the render. Then all of their children and the children of those children components will get called. So what I mean by that is if we come back here and we go to our homepage, on the initial loading of this page, React is going to call this what is going to be our root page right here, our root component, and it's going to render everything. It's also going to come to this input component and it's going to render that input component and then all other components of the tree. However, for subsequent renders, React is only going to look for components that have triggered that render through that state call. So when I update state here in this input component, React is going to be like, hey, this input component is the component that triggered this set state call. So since this input component triggered it, React doesn't need to recall this rendering concepts. It can assume that everything that is above or apparent to this input component can just remain the same, but it will re-render this input component as well as all children and the children of those children of that input component. But what does it mean when we get to committing? Well, that's involved in the re-rendering process. So as I've mentioned earlier, for the initial render, React uses the append child DOM API to put all DOM nodes it has created onto the screen. For re-renders though, React will only make changes to the DOM if there are differences between renders. Fewer commits lead to better performance. So effectively here, on the initial render of your web page, React will render as well as create the DOM nodes and commit all those to your page. But on subsequent re-renders, React will re-render that component, but it will check, okay, are there differences between what this component is now versus previously? If there are no differences, React doesn't commit anything new to the DOM, and it's not going to commit the elements of that component to the DOM if there are no changes before. And not needing to commit this stuff to the DOM is going to lead to less DOM manipulation, which is going to help improve performance. It's one of the benefits of React. So as I was saying earlier, when I only change this input component down here, React doesn't need to re-render everything else on this page. It only needs to re-render what has changed within this input component. And the only thing that has changed here is going to be the value within this input. So like right here, as well as right here. And if this input component had children, well, React would re-render those children. But if those children didn't have any actual changes, React's not going to recommit those children to the DOM. It's just going to leave them the same. And it's only going to commit new stuff to the DOM when there is an actual change, which I think is an important distinction. And I think that when a lot of people think of rendering, they think of like committing stuff to the DOM, when actually it's just React calling your component and deciding what to commit to the DOM. And if nothing needs to be committed, it's not actually going to commit anything to the DOM. All right, so let's recap here. So first off, what is rendering? It's basically when React calls your component and decides what to display on the screen. What triggers a render? Well, the initial render of your page, if you go to yourapp.com, React needs to render your entire component tree for that initial render, and it commits all that to the DOM. However, another trigger for a render is when a component or one of its ancestors, one of its parent components, has updated with set state, the state setter from useState. And you could also update state with a reducer as well. But that will also trigger a re-render of that component itself that set the state, as well as all the children of that component and those children's children. Now, React renders a component where on initial render, like I said, it will render that root component or call that root component and then commit everything from your DOM tree to the actual DOM. But on subsequent renders, React will call the function whose component triggered that state update, and it will also call all the components that are children to the component that triggered that state update, including those children's children, the children of those children, and all the way down recursively. But then for committing changes to the DOM, React will, on that initial render, append everything to the DOM like I just said. But for re-renders, React will call that function and it will see, okay, what do I need to change? What's the difference between this render and previous renders? And if there are no differences, React is not going to try to commit any changes to the DOM and write those changes to the DOM. And by doing that, it leads to better performance because less DOM manipulation is going to improve your performance. But if there are changes, React will then commit those changes to the DOM. It took me a while to understand this concept in React, and I generally think that, well, it's a fairly commonly misunderstood concept. At least it was for me. And this concept is of snapshots. Now, I'm going to do my best to explain this, but it is, at least for me, a little bit tricky. So let me know if you have any questions down below. But before we get to the whole snapshot side of things, let's kind of do a recap of my previous video where I discussed React rendering and what occurs when React re-renders a component. So when you re-render a component in React, the steps that are going to take place are that React is going to call that component again. So if we go look at the code here, we have this JavaScript function here called Snapshots page, and it returns this JSX. So when we re-render a component, React is going to call this snapshots page function, and this is the page that corresponds to what you're seeing here. So it calls that component again. Your component returns a new JSX snapshot, So here in our return statement, it's returning all this JSX, and it's returning a snapshot, which I'll explain here in a sec. And then React updates the screen to match your snapshot that the function returns. Okay, that seems fairly straightforward, but the key here is the whole snapshot concept. So to illustrate this, I'm going to show you kind of a example that demonstrates what I mean by snapshot. So we see that I have that counter on the page, but if we look at it here, all this is a button to where it's going to set state. It's going to set the number to number plus 1. So here at the top, I have number as well as set number, and I initialize it to 0 using useState. And then when I click this button, it sets the number, and you can see this is my +3 button. It corresponds to this right here. When I click this button, it's going to set the number to number plus 1, but it's going to do that 3 times. So what do you think is going to occur here? Well, let's click the button and see. You can see when I'm clicking on this button here, it's only incrementing by 1 every time. Now, what's going on here? Well, the key to understand what's going on here is that what is the value of number when set number is called? So here in the code, I'm going to refresh this page to initialize it to 0. Currently right now, what is the value of number? And you can see number is what I'm displaying on the page right here. So that's just the state value. What is the value of number right now, currently, for this page? Well, it's going to be 0, right? So if we come back and we kind of replace number with 0, this right here is just going to be 0. This is going to be 0. This is going to be 0. And this is going to be 0. So does it make sense now why I click on this button and it just sets it to 1? Because every render in your component is just one snapshot in time. So when this component renders, it's going to basically initialize this set number function to be 0 plus 1, 0 plus 1, 0 plus 1. So yeah, I'm calling set number 3 times, but it's just calling with 0 plus 1 every single time. So that's why it's getting set to 1. This is just going to be, when this component renders, it is just a snapshot in time. It is not going to, like when I click this button, it is not going to set this number 0 plus 1, re-render quick, set this 0 plus 1, re-render quick, 0 plus 1. This number is going to be the same value within a render every time, because it's just going to be a snapshot. Now, what would happen if I do something like, so let me restore everything. So I'm going to just do number plus 1 there. But what would happen if I do something like this and I do set timeout and I alert the value of the number? So I'm going to set the number here, and then I'm going to wait 3 seconds, and then I'm going to display the number. What do you think the value of the number is going to be when I call this alert function? Think it through right now. Think through what I just went over. Every render is a snapshot. What is this number going to be when this component initially renders? So what value do you think it's going to alert here? Well, if I'm explaining these well, you should have a good idea of what this number is going to be. So I'm going to click on it. I'm going to wait 3 seconds. And then you're going to see the number is 0. Does that make sense? Because when this initially renders, number is 0, number is 0, number is 0, number is 0, this alert number is going to be 0. So even though we set the state and we update this to 1 on the page, when this alert is triggered, the number value was 0. On the next render, so if I click OK and I click this button again, well, now it has rendered where number is equal to 1. So when I click this button again, the alert, it should now say 1, and it does. Because during that render, during that snapshot in time, the value of number was 1. So the key takeaway here is that React will not change state within a render itself. It is just a snapshot in time. Event handlers created in the past have the state values from the render in which they are created. So here, for our on-click event handler, we are setting for these state values here, they are all going to be equal to whatever the number value was when this component rendered. So these number state values aren't going to be updated within a render itself, which is actually makes things more clear once you understand this. So you don't need to worry whether the state has changed while the code is running itself. Every render is just a snapshot in time, and those state values are going to remain the same for that render, which is why we get the behavior that we're seeing here. Now, how can you fix this issue? Well, I'm going to cover this more in my next video and explain it fully, but what we can actually do is we can pass a function to the state setter. So instead of just doing number plus 1, if I pass a function, React is going to pass in the previous number, and then we can just return prev number plus 1. And we can do that for all 3 of them. And I'm going to get rid of this set timeout here as well. So now if I click on it and let me refresh here, you see it does increment by 3 every time. So there are ways around this, but I will explain this more in our next video. But the key takeaway here is that when React renders a component, it is rendering a snapshot in time, and it will not change state within a render itself. And for any event handlers that are created in the past, they're going to have the state values from the render from which those event handlers were created. So you don't need to worry about whether the state is changed while the code is running itself. So hopefully that makes sense and makes things a little bit more clear. I know it's kind of a tricky concept, so feel free to let me know if you have any questions below. Understanding state updates in React. In my previous React tutorial, we discussed why, if we look at the code here for this counter, why if I set number as number plus 1 3 times, and you can see that we have this number piece of state here in our snapshots page, it initializes at 0, but when we click this button with plus 3, it sets the number as number plus 1 3 separate times. So why, when I click on this button plus 3, why does it just do plus 1? Why does that occur? Well, we kind of discussed that in React, each render represents a snapshot in time. So when we initially render this page, we initialize number as 0. So when we get to set number on all 3 cases here, number is going to be 0, number is going to be 0, number is going to be 0. And then that ends up with just setting the number to 0 plus 1 3 separate times. So if we refresh this page and reset the state, number is 0 right now. It's going to be 0 plus 1, 0 plus 1, 0 plus 1. So of course, when we click, it's just going to increment by 1. And now that number is 1, it's going to set 1 plus 1 3 times, which is just going to be 2, and so on and so forth. So each render is a snapshot in time. Now, what is going on here though, when I showed you the solution of if we pass a function to set number. So let me pass a function and I'm going to say prev number, and then I'm going to return prev number plus 1. And if I do that for all 3 set states here, like so, and now I reset my state and I click it, we see that everything's working now. So why does that solution work? Well, a couple of things to cover here. So for one, it's important to understand that React is going to wait until all code in event handlers has run before processing your state updates. In other words, this means that the UI won't be updated until after your event handler and any code in it completes. So here, our event handler is this onClick function. React is going to run all the code in this onClick function before it's going to process any state updates, which is also part of the reason why when we just did number plus 1 here, we didn't, re-render the component here after calling set number, rerun it again here after calling set number, and rerun it a 3rd time. We just triggered one re-render here. This is what people refer to when they say that React batches the state updates. It's going to wait until that event handler code completes to then update the state. So it batches that state update. It doesn't trigger a re-render for every single set number call that we have here, which is why we just set it to number plus 1 3 times rather than re-rendering after the first one, re-rendering after the second one, and re-rendering after the third one, and potentially getting the result we want. If it's true that React waits until after all the code in the event handler completes to update state, why does this method work? Why does passing a function to our state setter and using this argument that's passed into this function, why does this work? When you pass a function to a state setter in React, the function is going to calculate the next state based on the previous one in the queue. It is a way to tell React to do something with the state value instead of just replacing it. React will instead push all functions to the queue, and when one function updates the state, then the next function in the queue runs using that updated state, not just replacing the state. So let me kind of elaborate on that a little bit more. In our code here, when we pass a function to this set number state setter returned from useState, and this of course works for any set state call that is in your application. When we call set number here, but we pass a function, we're basically telling React to push this function to a queue. So we're pushing this set number function, or the function that we pass into set number, we're pushing this to the queue. And then when we call set number again with a function, we're pushing this to a queue. And then for the third time, we're pushing this function to the queue as well. So we're pushing these 3 different functions to the queue, and React is going to know when we do this that instead of just doing a state replacement, so if we just do, we set number to 4, that's basically telling React, replace the current state with the value of 4. That's just a straight state replacement. But when we pass a function, it's saying, hey, I want you to take the previous state value and then do something with it. And in this case, React is automatically going to pass the current state to our function that we pass into the state setter. It's going to pass the current state as an argument, and it's going to allow us to do anything with that current state. So this is going to be the first function in the queue, and React's going to pass the current state, and then we just return that current state, which becomes our previous number. It's going to take that previous number plus 1, and then it's going to move on to the second function in the queue. So we updated the state right here with the previous number plus 1, but React is going to know, okay, now the current updated state is whatever we return from the first function in the queue. So it's going to take the return value from this first function in the queue, and it's going to pass it into our second function of the queue. So if we started with 0 here, prev number is going to be 0. 0 plus 1 is going to be 1, and that's the return value of the first function in the queue. For our second function in the queue, prev number is going to be 1, because that was the return value of our first function. Prev number is going to be 1. We're going to return 1 plus 1, which is 2, and that's the return value of our second function in the queue. So then for our third function in the queue, it's going to pass the return value of our previous function in the queue, which was 2. It's going to take 2 as our argument here, and we're going to return 2 plus 1, which is going to give us 3, which is why if I reset the state again here, when I increment this, we get exactly what we expect, because I'm telling React to queue all of these functions here, and then when it goes to update state, it's going to pop these functions off the queue, but it automatically is going to pass our kind of current state in as an argument that we can then use within that state setter. And then for the next function in the queue, it's going to automatically get passed the return value of the previous function that we had in our queue. So the kind of key to this working is that we queue these functions rather than just doing a single state replacement using that snapshot of what our current state was. Now, you might be thinking, so when should you kind of use this passed in function to the state setter? Because honestly, like, you're probably not going to do something like this that often, like in a single event handler, calling the same set state multiple times. Like, that's probably not something you're going to do a ton. Well, you still might use this approach. For one, if you do, there might be some situations to where you do something like this, to where you're going to set the same piece of state multiple times in an event handler. And in that case, you absolutely need to make sure to use this method, or you're probably going to get some weird results. So if you call the same set state in an event handler, use this approach of passing in a function, queuing those functions, and then using the kind of previous state in those functions that React automatically passes in as an argument to those functions. But another time to use it is just whenever you want to use the kind of current state to derive a new state value. So in our functions, we're using the kind of current state to derive a new state value here, prev number plus 1. I still kind of like to use this approach. Now, we wouldn't necessarily need to if we just had one state setter here and we just took number plus 1 and we just do a straight state replacement. We don't really need to use a passed in function, because if I refresh, this is still going to work as just incrementing it by 1. So this is still going to be fine. But there might be times to where you need to do like a more kind of complex calculation based on this number right here. So depending on what this number is, maybe you have an if statement that you want to add or some other logic. Well, in that case, I might do something like, I don't know, function on click handler. It can take like the prev number, and then maybe it will say like, if prev number is less than 3, return prev number plus 5, else return prev number plus 2. So if it's a lower number, take the larger increment, and if it's 3 or greater, just increase it by 2. And then for this set number function right here, we can just pass in this on click handler, and it's automatically going to pass us the previous number, and we can add this kind of logic here. And if I did everything correctly, you can see it increments by 5, but now that it's over 3, it should just increment by 2 here, which you can see it doing. So this logic here, it would kind of be messy if we tried to just do like, write in the code here, like number greater than 3 ? And we have like this kind of not very readable ternary operator. I would probably not take that approach. I would much rather just pass in a function to the state setter and use the previous number in that function, like what we did here. But then again, it also depends on how you have like your on-click handler set up, because we could also very well do, let updated number equal number plus 2. But then you could say like, if your number is less than 3, then you're going to say that your updated number, you're going to add 3 more to it or something like that. And then you just pass in your updated number as your set number right there. That would also be something that you could do and add your logic in your on-click handler. It really just depends on how your team structures stuff like this. But as a quick recap here, just know that React will wait until all code in the event handler is run before processing your state updates, which means that the UI won't be updated until after your event handler and any code in it completes. This is also called batching state updates. But if you want to kind of opt out of that, or you want to call the same set state function within the on-click code, then you're going to want to pass a function to your state setter, which is basically going to add that function to a queue, and then React is automatically going to pass the current state to that function. And you might take this approach, like I said, when you want to have the state set based off of the previous state, or you need to call the same set state function multiple times in an event handler. Those are good times to use this approach. There's a common issue that you can run into with React state updates that can be a little bit tricky if you don't know what's going on here. And this particularly relates to using mutable values in your state updates. So in React, anything can be used as a state value. And what I mean by that is you can have booleans, numbers, strings, objects, arrays. All those JavaScript data types can be state values in React. All that is valid. However, a little extra caution needs to be taken when using mutable values. So a non-mutable value is going to be like a primitive value in JavaScript. So this is going to be something like a boolean, a number, a string. They're things that you can't change without making a new copy of them. Whereas with a mutable value like an object or an array, you can add values to an array without creating a new copy of that array or a new reference of a different array. You can just change the values within the array. And same thing with an object. You can change the values of a certain property on an object without creating an all new object. Mutable values like objects and arrays should still be treated as read-only in React. And React recommends this straight from their docs. You can read here in their updating objects in state page in their react.dev/learn documentation. But they recommend treating these mutable values as read-only values. And they mention that this makes sure that React knows when it actually needs to update the state on your page. Because if you have the same reference to the same object and you're just changing the values within those objects, React might not know that it actually needs to re-render and update your web page because it's still referencing the same object. So a better approach is creating an all-new copy of the object or replacing the object altogether, or the same thing with an array. So we're going to look at two examples of this where we're going to have this form input where you might be using an object as your state. And then we're also just going to use a list of random numbers to demonstrate using arrays as state and the best way to update those. So let's go to the code here, and you can ignore a lot of this. A lot of this is just Tailwind CSS classes, but effectively at the top of this component, we have form data and set form data that we initialize as an object with a name and email, and random numbers and set random numbers that we initialize as an empty array. And then we have a handle input change function to where when a user types in the name input or types in to the email input, we need to make sure that we are updating the form data correctly. And same thing for the add random number. When they click the add random number button, we need to make sure we add another random number to this random numbers array. And here below, you can see this is where our name input is. This is where our email input is. And then we have our random number list and our add a random number button. So we need to handle those and handle these state updates for objects and arrays correctly. So let's first focus on this form data here. When the input changes, how should we update this form data? Well, what we don't want to do is we wouldn't want to just take this form data dot name is equal to the new value, because then we would just be mutating the state value, which is something that we don't want to do. So instead of doing this, what if we did something like if name is equal to email, then we want to set form data, and then we want to pass in the email, and then that's going to be the value. And then else, if that's not true, so we'll say else, then we want to set the form data to be the name now is going to be the value. This might seem like it makes sense. Like, okay, if the input name is of type name, update the name value in our state. And I know it's a little confusing because name and name, but you can see the name of this input is of type name, and the name of this input is of type email. So if it's of type email, update the email value in our set form data. And if it's of type name, update the name value. But do you know what's wrong here? Well, let's go see. Let's go check our UI. I'm to refresh to make sure everything's good. This is going to be my name, which looks good. Name is Ryan. But now let's update my email. So if I do contact@Ryan, and you see when I start typing in my email, my name disappears here. So my state for my name doesn't look like it's working. Now this is still has Ryan in it because it's going to fall back to not being a controlled component anymore. It's just going to have the HTML value being set here, which is totally fine. But you can see my name and my email here look a little bit off. So if we go back to the code and I scroll down, you can see when I'm displaying my form data.name and form data.email here under my inputs, like I am here, my email is correct. My name is not showing Ryan. So let's type back into Ryan here. Let's start typing my last name. And you can see as soon as I start typing, it gets rid of my email. And the reason this is happening is because if we scroll up, when the type is email, we are setting the form data to a new object that only has an email property and it no longer has a name property. So we are effectively getting rid of our name property when we update our set form data with a new object that has that email property only. And same thing when we have our name property, we get rid of the email property. So the way that we can fix this is we could either, like in this instance, this would be fine. I can spread the form data previously that we have in there and then just update the email value. And we can do this below as well. This is one way that we can solve this. And then if I come back and now I type Ryan, which works here, and then let me type my email, and you can see when I type in my email here, Ryan is not removed because we're maintaining that state, because we're making sure to use JavaScript spread and syntax to spread the current form data, all the other values into our new object, and then also update the email property. And we're doing that for both of them. Now, a other completely valid way to do this, and this, I would probably take this approach just because it makes me feel a little bit better, but I would probably pass a function that gives prev form data and then return a new object where we spread the prev form data and then we update the email property to be the value. And what we could actually do here as well is we could get rid of this if-else syntax, and we could just say, instead of just setting it as this property, we can use square brackets, name. So as a property here, we're going to use JavaScript dynamic properties to set the property name to whatever name we get from the event.target, and then our value is going to be our value. And then we're spreading our previous form data into this new object that we're going to return here. And if I think I'm doing everything correctly, let me refresh. We'll do it again. So I'll do Ryan, some email, and you can see everything works as expected. So with objects, make sure to create a new object, but also make sure that you copy all of your previous values over from that object if you want, if that's the behavior you want, so you're not losing all those other values from your property, because that is a common mistake that you can make. Now, how should we handle arrays? Well, it's going to be a very similar thing here. So when we want to add a new number to our array, what we can do is we can, instead of just doing like random numbers dot push and then math dot random, instead of just doing that, pushing a new number to the state variable, we don't want to do that because we don't want to mutate it. We want to avoid mutations in our state updates. The preferred approach here is set random numbers. And then what do we want to make sure we want to do? Well, we wouldn't want to just set the random numbers to a new number, so math.random, because then we're going to lose all of our previous numbers in our array. So what we want to do instead is we're going to do the same thing. We're going to say prev numbers, passing in a function, and I go over this in my last video in case you're not sure how passing a function to set state works. We're going to pass a function that gets the prev numbers. We're going to return an array. We're going to spread the prev numbers into the array. And then we're going to add a new number that's going to be math.random. And then we could also, times it by 100 to make it a little bit bigger numbers as well. So now if I click add random numbers, you see it adds all these numbers to this array, which is what we want, without replacing them and removing all the previous numbers. And we wouldn't necessarily need to pass a function in this case. We could just pass in an array and take the random numbers, spread those into the array, and then do the same thing with math.random times 100. And we could also like floor this so it's not so many decimal points. And then I just refresh to make sure that everything's reset, and you can see it still works as expected. But if we forget to spread those previous numbers in, then what you're going to see is it is just going to do a replace job here to where it just generates one new number every time because we're not remembering to spread those other numbers in there. So when using mutable values and React state, make sure to treat those as read only so React knows when it needs to re-render your page and keeps everything consistent. And when you're treating them as read only, you're probably going to need to create new copies of those arrays or objects or mutable values. Or you could also, instead of creating a copy, just pass in a array directly to set state like we did here. But when either creating a copy or doing a replacement like we're doing here, make sure that you're still keeping in the previous properties of the object, if it's an object like we did here, or the previous values of an array like we did here as well. We won't get into arrays are actually objects in JavaScript because that's a whole nother thing. But just make sure for those immutable values that you're doing both and not losing that previous data in those mutable objects. So in my previous video in this React series, we discussed the idea of it overall being kind of a bad idea to try to mutate mutable state values. So if you have an object or array, it's generally a bad idea to just perform a mutation on those pieces of state rather than creating a copy or an entirely new piece of state. So today I'm going to discuss some more bad ideas when it comes to manipulating arrays. And, if you're kind of starting out with React, or even you just want a refresher on some things that just don't work, then this video is going to be for you. So let's look at a few different things that you might want to do with arrays here. So we have this page that I created. So here you can see the page, and we have 3 different buttons: and add random number, remove last number, and sort numbers. 3 different buttons to do that. And when we click add random number, it calls this add random number function. When we click remove last number, it calls the remove last number function. And same thing with sort numbers and this sort number function. And if we go look at these functions, what you're going to see is that for add random number, let's focus on this one right now. What we want to do is just add a random number to this piece of state, this array, this random numbers array. And you might initially think that the way to do this is to call random numbers.push, and then you add a random number to this array, and then you set the state with your random number pushed into it. So we push in a new number to the random number state, and then we set it here. But if I come here, and I promise you I'm running my application right now, you can see these kind of pulsating in the background. So this application is running. When I go to click on add random number, I'm clicking as loud as I can, but my mic probably isn't picking it up. I promise you that I'm clicking on this, and it's not adding any numbers here. So what's going on here, as you can probably guess, is we are just mutating this random number state instead of creating a whole new different array. So using your state and then trying to push a new number into it and then setting that state with your new numbers is not going to work. So this method right here is overall a bad idea. And one way to solve this, and there are several ways that you could solve this, is this time around, we're going to set our random numbers, but here we're going to create an entirely new array with our square bracket right here and our square bracket right here. We're creating an entirely new instance of an array. We're spreading all of our previous numbers in our array into this new array, and then we're calling this math.random to effectively push a new number into this array. So if I come back, I'm going to refresh this page just to clear out any of my previous state, although we didn't see any of the state updates because we're mutating, but just to clear everything. Now, if I click add random number, you see it does indeed add these numbers. So here we are creating a copy instead of just pushing a new number to the state. Now we have our remove last number function. And you might think that it's a good idea to, okay, we'll just use the array.pop method. So on random numbers, we call array.pop or random numbers.pop on the array. And then we set our random numbers with this random numbers array with the kind of popped value out of there. So, the pop method removes the final value of an array. You would think that this would remove the last number of the array. But if I click on remove last number, you can see we don't see any state updates. That's because we're doing the same thing here. The push and pop methods are going to mutate an array. They're not going to create a separate copy. So one way that you can solve this, and I'll show you a different way here in a sec, but one way you can solve this is using the slice method, because slice is going to return a shallow copy of an array. So here we set the random numbers to be the previous numbers, but then we call the slice method to remove the final number. But this slice method, it returns, like I said, a shallow copy. So we're returning a new copy of the array. We are not just mutating the numbers array. So if we come back and I just refresh the page here, and then we add some more numbers, and then we remove the last number, you can see it works as expected because we're creating a copy instead of doing a mutation. And to continue this theme here, I have this replace numbers function. So here it replaces a number at an index. And this could be something very common that you might want to do. You take your state array, you grab a value at an index, or you have some index, and then you replace that with a new number or a new value. And on its surface, this looks like fine logic to replace a value in an array. But if we click on this replace button, you see nothing really occurs here. So I'm going to refresh here, but the way that we're going to fix this is we're going to, of course, create a copy instead. And this time around, we are going to use the map method to do so. So here, we set the random numbers, we take the previous numbers, and then we call prevnumbers.map, and then we are going to check, okay, does the index match the passed in index? So the map method takes the value and the index, or is going to give you the value in the index for every item in your array. Does the index of the value that you're iterating over match the passed in index? If so, replace that with a random number, else just keep it as the original number. And now if I add some numbers, I'll remove the last number, I'll replace this number here, and you can see it actually replaces the number here because the map method is going to create a new copy of the array. It is not going to mutate the piece of state. What matters here is the principle of not mutating arrays and making sure that you're familiar with the JavaScript method enough to know whether it mutates or whether it creates a copy. Because as you can see in these examples, this can create issues if you're not paying attention to things. But now let's move on to sorting numbers here. So if I click sort numbers, again, you see nothing occurs. Let me refresh. Let's go fix it. And then here in our sort numbers function, we originally just called the sort method on the numbers array and then set random numbers with this newly sorted array. But unfortunately in JavaScript, the sort method, it mutates. It doesn't create a copy. So a better strategy for this is to still use a sort method, but create a copy of the array first. So here we pass in a function, we get the previous numbers. And if you're not sure how passing a function into state setters works, check out some of my previous videos on this. But we create a new array with the spread operator first. So this is a completely new array, and then we sort that new array. But since we create a new copy of this array first right here, that allows us to sort it and it will update the state. because it is a new array. So if we add some numbers, let's add a bunch. You can see they're not sorted, but if I click this, you can see a few of those numbers hopped around, so they are sorted. But let's replace some of these numbers here. And maybe I could make it more obvious. And now let's click sort again. You can see it resorts it again. Let's remove numbers. And now we have this completely unnecessary component working as we want it to, because we're making sure not to mutate our arrays. But let me refresh this. I will still use some of these common methods like push and pop, but I'll just create a copy first. So what I'll do here is move this, and then instead of just mutating this random numbers array, what I'll do is say const random numbers copy is equal to, and then you can just use the spread operator with random numbers to create a copy of that array. And now I can do random numbers.copy.push and push a new value in there. And then we can set random numbers copy to be our updated state. So I can still use this push method if I wanted to. Looking at this right now, this looks about the same here, but sometimes writing the logic out like this, it can be helpful. In this instance, I would actually probably just keep this right here. But sometimes this can be a way to do it that works pretty well. And you can see it doesn't cause any issues there. If we come back, we could do the very same thing for the pop method. So right here, we can create a copy, but instead of doing push, we can do pop, and then we can set the random numbers copy here, and I'll comment this out. And then if we remove last number, we see it works. Just for good measure, I will refresh, add some of these, remove them. You see everything still works here. So you can, if you want to still use some of those more kind of common methods, you can totally do so. Sometimes I'll go that route depending on how my logic is set up. Sometimes that makes sense to do, but often I might just use spread operator and add the value in right there or something along those lines. But here, I kind of prefer this logic of popping over doing this right here. And you could also, another very reasonable way to do this would be I could pass in a function here as well. And then instead of just returning the prev numbers.slice, you could basically put this logic in here, but then instead of setting the random numbers, we'll just return the random numbers copy. And we got this, and then I'll do this. And this is another reasonable way to do it. So, you're still passing in a function, making sure you're using the most updated kind of previous numbers, but then you're still creating a copy of it here. You're making sure to pop the final number, and then you're returning your new numbers copy. And I believe if I refresh, we go through, I remove, everything still works as expected. So there's a ton of ways to do this. Sometimes I like using the spread operator and doing that sort of thing. Sometimes I like using some of the other methods, but TLDR, don't mutate your arrays. Know what your JavaScript methods do, whether they mutate or create copies, and make sure that you're not doing any mutations. When I first started using React, I would always hear that React is declarative. And I didn't really understand what this meant. I didn't really understand why it was important. I was kind of like, oh, okay, it's declarative instead of imperative. That's nice, I guess. But I didn't really understand what that meant and the importance of it. And I do think that in hindsight, it is helpful to understand this, and it is kind of good to understand the mental model for working with React. So today we're going to cover those two differences in case you're in a similar position or need a little bit of a refresher on this. So effectively here, we have two different forms, and we can get the same result with both imperative and declarative code. So on the left here, this is a form made in a declarative way, kind of the React way. And then on the right, this is a form made in more of an imperative way, or the kind of vanilla JavaScript way would be a more imperative way. So if we go look at the code for this, you see the homepage here in which we render the declarative form component and the imperative form component. And if we go look at these components, this is our declarative form here. And then we have our imperative form here. And on the surface, these components, they both function. So I can add a name and an email for both of them, and they're going to work here. And I'm just simulating the submit button there with a set timeout. But we can do the same thing for each, and then we can, of course, edit, delete, clear the list, and kind of all the normal stuff. Styles are a little bit off here, but for the sake of this, I don't think it's a big deal. So looking at the code, let's go look at the handle submit button. So when I submit a new name and email for the form, what does it look like in a declarative versus imperative way? Well, in an imperative way, so here's the handle submit function. What we're going to have to do is effectively tell React every single step that we're going to need to take to manipulate the DOM. So we are going to imperatively say, okay, we're going to do this to the DOM, then we're going to do this, then we're going to do this. And the DOM is just effectively the web page. It's the document object model. It is a tree-like structure that represents all the elements in our web page. So we're going to have to be like, okay, add this text to the DOM, create this element, remove this element, validate this text. We're going to have to do that all just kind of step by step in an imperative way. So here we can see when a submit occurs, we first get the name and email elements from those I just created refs here in React. And then we check them. If they're not there, we use an alert. But if they are there, we'll set loading to true. And this is actually doing something more declarative here. I didn't really worry about it for loading state, more so just for adding items, but this would be a little bit more declarative. But here's where we get into the kind of meat of the more imperative code. So if there is an edit index, so if they're editing this input rather than submitting it, so they just clicked the edit button here, then what we're going to do is we need to find the list item with the current index. So we have to check the listref.current.children and find the correct index. And then we need to check the list item.firstchild.text content. We need to imperatively set the text content for the correct list item. And then we need to manually set the edit index back to null. And then here we need to kind of clear out the name and email manually. And then we set loading to false, which honestly, in that case, that's not terrible. But if it's not an edit function and they are adding a new element, then what we need to do is call the document.create element. We need to create an li element, and then we create a text node by document.create text node with the name and email here. And then we need to append those manually to our list. And then we need to also add the edit and delete buttons for that list item within our list, because we need to manually add these edit and delete buttons here. So that function is also part of our handle submit. So here's our edit button where we create the button, we create the text content, we create the classes, we create the on click. We do the same thing for the delete button here. We also need to create a button container, so these elements actually have OK styles. And then we need to append those to our list. So we need to manually create our edit and delete buttons. And then we come back up here and we add those to our list. So we append those to our list manually. And then we also manually kind of zero out our email and our name. But in a declarative way, for our handle submit, we do the same thing right here. So we check if the name and email is there, and then we say an alert to please fill out the fields. But if not, well, if it's an edit here, if it's an edit operation, then we just need to create a new array of our previous items, because in React, when you're setting a new array, you should create a completely new array. When doing so, you shouldn't just mutate the current array, but we create a new array for the updated items. At the edit index, we add the new name and email from state, because this time around we're using React state to manage this. So we're setting the edit index name and email to the new name and email here. And then we're going to set our items to the updated items. And then we're resetting our edit index to null. And then we basically zero things out here. So pretty straightforward, not terribly different from this edit operation here. But what happens when we need to go add a new item? Well, in React, we just declaratively say, okay, let's set the items to be the previous items plus our new name and email. So we are just very much so declaratively, just with a single line of code, setting our items to be all the previous items plus our new item in our list. And then in our code down here, we just take our items, map over them, and render out this kind of same list item component for all these different items. So we just kind of declaratively say, okay, map over these items and render something that looks like this for all the items. So really, with just a single line of code, we add items to our list, and we just declaratively say these should be our new items, rather than needing to imperatively, okay, this is going to create our new list item. This is going to create the text for our list item. We need to append that to our list item right here. Then we need to add the edit and delete buttons. So we imperatively do all of that work here. And then we append that to our list and then zero things out. Like, that is going to be so much more complex and more difficult to manage, rather than just declaratively saying, okay, set the items to this, and then just kind of let React figure out how to now take that state and manipulate the DOM to add all these items. Because at the end of the day, like, React is going to have to do the same thing. Like, we're still using JavaScript, we're still using the web browser, we still need to add all these elements to the page. So React is going to turn this into more imperative code, but one of the benefits of React is that we can just kind of declaratively say, hey, this is what we want the page to look like. You can do all the figuring out of all of like this stuff right here. Yeah, we'll let you handle that. I know that you enjoy doing that, so you can handle that. And we're just going to say, hey, set the items to be this new list. And this is kind of the crux of declarative versus imperative. You get into cases to where, especially in more complex applications and a little bit more complex logic, like I tried to make this a little bit more complex here to where we're adding edit and delete buttons and stuff to make it clear, like, hey, this is a lot less fun to add an item to where we have all this kind of manual code written out, compared to just like this single line of code of, hey, set the items to this, to where we just declare this is what we want our page to look like, because these are the items we want to show on our page. So really, that's the difference between imperative and declarative in React. Imperative programming, you have to really kind of go through every single step of what you want to do. And in the context of web development, kind of every single step of manipulating the DOM, of creating different nodes, of appending children, of adding class names and text content, all this stuff. Really, in React, you do not want to be doing this. There might be some cases to where like you have to do some manual DOM manipulation, but really you should try to, as much as possible, to never have to do stuff like this, and try to always do things the declarative way in React, to where you just declare, this is what I want my state to look like. And then React will figure out how to manipulate the DOM to make the DOM match what you want the state to look like. So in React, you should just be declaring what you want your UI to look like. But in other forms of web development, you might have to do things much more imperatively, to where you kind of step by step manipulate the DOM on your own. And as you can see, that could become potentially pretty complex in larger, complex applications and become really difficult to reason about and to actually maintain and extend over the long run. Today, I'm going to show you a 5-step process on how to use state in React. And this is not just me making this up. This comes basically from the React docs as well on how they recommend you using state. So number one, you're going to want to identify your component's different visual states. So for example, when a user views a form component, what different versions of the form component will the user see while interacting with it? So if I scroll down, we see this form component. What are the different versions of this component that the user will actually see while they interact with this component? So for example, as I type into this input, the user is going to see the text show up. And as I type into it, the user is going to see this green outline around my name input. That's a certain state. I type into this email, and then I see the email show up in my input. Same thing for my password as well. And then when I click sign up, I'm going to click on it. I'm going to see a different state of my password, submitting, and it's all disabled. And then after I submit, I see forms submitted successfully. So there's a few different states here. If I refresh, you're going to see we have a clear form. We have a state where the user has filled out the name, they've filled out the email, they're filling out the password. Those are all like technically kind of different pieces of state or different versions that the user can interact with for this form. And then when we click sign up, we see kind of a little loading indicator here and the form is disabled. That's another state. And then also when it's fully submitted and it's successful, we see a nice little message up at the top. And you might have other states for this form as well. If the name is invalid, you might see validation that says, hey, this name is invalid. If I just do email.com and I try to move forward with this, you're going to see that it doesn't show up green because it says, please include an @ in the email address. So if I do email@email.com, it automatically validates this. So validation is another state. So there's a bunch of different versions of this form that the user interacts with. So step number one of using state is understanding what versions of this component is the user going to interact with if it's a dynamic component and if the user is going to be interacting it. What are the different kind of states or versions that this component will inevitably be in as a user interacts with it? That is step number one, determining a component's different visual states. Number two, determine what triggers those state changes. So here, consider what user actions or events will change these states. And then user versus computer. So what I mean by that is a user going to initiate these state changes, or is like a network request or an error or something that the computer is kind of generating? So if we submitted this form and we're waiting for that form submission and it submits successfully, it's more so computer generated rather than the user actually like typing into this email. Typing is user generated. Clicking is user generated. Hovering is user generated. Waiting for a network request, more so computer generated. So it's important to consider, okay, for the different visual states that this component is going to have, how are we going to trigger those different states? Is the user going to be typing? Are they going to be waiting for a request to complete? Are they going to be clicking? Consider what events and actions are going to take place to trigger those state changes. And then number three, now that you know the different visual states and you know what triggers the state changes, represent state in memory with the useState hook from React. So in React, you'll use the useState hook to represent these different states in memory. One thing to note is that state adds complexity. Less state is more simple and probably desirable. So a good rule of thumb is if you can kind of get away with using less state, it's probably a good thing. As anytime you add state to a component, it's going to add different moving parts, and this is going to make that component more complex. And trust me, the more simple that you can make things in your app, the more maintainable and scalable that app is going to be. So by default, if you can get away with using less state, use less state. And I'll cover this here in some examples here, but let's actually now look, what does it look like to represent state in memory with useState? And I've covered in previous videos how this useState hook works, but just to kind of give you a quick recap here. So useState is a hook from React that allows you to hook into the React feature of using state. You're going to use this React feature when you have a component that is going to be dynamic, and there's going to be different versions of that component depending on user interactions or certain events, and kind of just what we talked about, like different versions of a component dynamically as a user interacts with it. That's where you're going to use state. So you can represent those different states of that component, hence use state. So when using state, you're going to call this function. It's a hook, it's a function, and it's the same thing. A hook is just a JavaScript function at the end of the day. But we're going to call this function. We can call it with some initial data here. So I call it with an object that has name, email, and password properties. And I initialize those to just empty strings. The useState hook is going to return an array of 2 values. The first is going to be your current state. So what is the current state of the form? Well, when this component renders, the current state is going to be name is going to be empty, email is going to be an empty string, password is going to be an empty string. If I console logged form data on a initial mount, we would see name, email, password object that has all empty string values. But then it gives us a state setter as the second item in the array, or the 1th index, first index. I don't know why I said 1th there, but at the first index of this array, it's going to give you a set form data function, which allows you to basically set some new state based on user interaction. Now, I've covered this in previous videos, so that's about as far as I'm going to go there. But if you want to see exactly how useState works, feel free to check out some of my other videos. But when using the state, we basically think, okay, for our form component that we have down here, what are the different states that we want to see, and how do we want to represent that in memory? Well, we're of course going to want to see different states for our name input. As the user types in, they see different names in the input. Same thing for our email input. Same thing for our password. So we need to find a way to represent those different states in memory. And the way I've done this here is we just have a form data value that has an object with name, email, and password. So we can represent name, email, and password states in memory. Now, what we're also going to have is, for our form, it's going to have a state to where we are submitting the form. So is submitted. We're using an object to represent different states of our form. So is submitted. Are we loading the form? Is there an error message? Is there a success message? So different states of our form: is submitting, is loading, error, success. So if we come back and we look, if I type in a password and I submit, it's in a submitting state, and now it's in a success state. And there's no error, so there's no error messages. We know it's not in an error state. So we're using this form state right here to represent these different versions of the state of our overall form, kind of outside of our name, email, and password. So we've chosen that. But then what we also want to do, if we come back and we scroll up, we represented our state in memory with useState. We identified the different component visual states. But now to kind of show you, what were the triggers for these state changes? Well, it's going to be the user typing in their name, their email, their password. It's going to be user typing. So for these inputs, we're going to use the onChange event handler to trigger these state changes. And then for the sign up, it's going to be user clicking the sign up. But then for form submitted successfully, it's going to wait for a network request to occur. And then a computer generates that. So after that network request, that is our action. We're going to trigger a state change. So for the code here, if we scroll down and we look at our inputs, we see onChange as a handle change function. So anytime this input changes, we call this handle change function that is going to set form data to be the previous form data, but it's going to update the input that we are typing in. So we take the event.target.name and set the new value. So if they're typing in name, set the new value. They're typing in email, this is going to be email. We're going to set the new value, but we make sure to spread in all of our old data. And the reason we do this real quick is because if we just updated the name here, we would just set the state to be an object with a name property, but we want to make sure that we maintain name, email, and password. So we need to spread the previous form data effectively into this set form data setter. So we call this handle change function when a user types on this input, as well as this input. And then when a user clicks on this button, like right here, we have a type submit for the button, which means that if we look at the form, we're going to trigger this handle submit on the form. So our button is type submit. They click that. That's going to submit our form, which is going to trigger this handle submit function, which is basically going to validate the form and make sure the form's valid. But then it's going to set the form state to is loading is true. And it's going to make sure the success is null right now. But then here we simulate a network request. But when that network request finishes, or after this timeout in this case, we're going to set is loading to false, is submitted to true because they submitted their form, error message is null, and then we are setting this to have a success message. So this is kind of another trigger for our state, waiting for that set timeout to complete. In a real application, this would be a network request. So we're representing our state in memory. We have our different triggers, the user typing, the user clicking, and waiting for that network request. And we identified the different visual states we want. So really, that gets you a really long ways. But it's just a couple more tips here. So for one, make sure to remove non-essential state variables. So kind of going back to what I mentioned above. When possible, if you can use less state, it's going to make your application a lot less complex, which is going to increase the maintainability and scalability and the reasonability, the ways that you can just kind of look at the code and make sense of it, of your application. So, for example, for removing non-essential state, instead of having is loading, is error, is submitting, collapse it into a status state and avoid redundant state like is typing and is empty. So for is typing, well, if they are typing into an input, then you know that it's not empty. So we don't really need to use is empty. If they are is typing, we know that it is not is empty. So this would be an example of a removing non-essential state. Same thing for the status. Like instead of having 3 separate slices of state, you could just have a status that is equal to a string that is either the form is either an is loading, is error, is submitting, and is loading in some cases might be like the same thing. So that might be a redundant state that you could remove. Also, can you derive state? So you don't need is error as well as error message. If an error message exists, well, there is an error. So similar to like is typing and is empty, we know that if error message exists, is error has to be true. So we don't need both pieces of that state. And this is like a super easy mistake that you can make, and just cleaning some of this up can make things much more simple. And in my example here, I could probably simplify this even further. And instead of having error message and success message, I could just have like status message. And it could just be like it's either an error or a success. Maybe my component doesn't need to know if it's an error or success. And I could get away with that. And if we scroll up here, like to me, just having 2 slices of state here to represent this entire form is a lot more easy to reason about, rather than like having a name piece of state, an email piece of state, a password piece of state, an is submitted piece of state, and is loading piece of state, a error message, a success message. And then, you know, if you were accidentally having some redundant state, you might have like an is valid piece of state, but you don't need that because you already have an error message state. So you know if there's an error message, it's not is valid. And same thing with if you had a is success piece of state, well, you don't need that because if success message isn't a null, you know that it was successful. So just kind of keep that in mind. Remove non-essential state values. And then finally, connect event handlers to set state. We covered this kind of in step 2, where I said determine what triggers state changes. I already showed you the connection there to where we know that like user typing in an input is going to trigger the state change. So here we just need to connect that state change to an event or connect that event to that piece of state. So here our onChange automatically connects that input to our set form data piece of state. And then our handle submit, the action is the user clicks on that button. So we need to connect that action to setting some state. So here we set the form data in 2 cases, after the timeout as well as prior to it here. So the final step is just connecting your what is going to trigger the state changes to the state that it's going to be changing. So as a quick recap here, number 1, to use state in React, identify your component's different visual states, submitting, loading, errors, typing into an input, all that stuff. What are the different visual states of your component? Number 2, what's going to trigger those state changes? Is the user going to be typing, hovering, clicking? Are you going to wait on a network request? What are triggering those state changes? Number 3, now that you know the different pieces of state, figure out how to represent those pieces of state in memory using the useState hook from React. Number 4, remove any non-essential or redundant state variables. The less state, the more simple, the more better. And if you can avoid some of the kind of common mistakes of using redundant state in your application or not deriving state when you could have, then that can cause more complexity that's needed in your applications. And then number 5, just make sure to then connect your kind of actions, what's triggering those state changes, to the set state calls itself. For example, on click, set the submitting state. When using React, there is a handful of principles that you should keep in mind when choosing your state structure for your different state in React. And today we're going to go over 5 different principles for choosing the structure of your state in React. Now, if you want to learn more about this and see more examples, you can come right here in the docs, and React kind of goes over these principles as well. And I'm, of course, using the docs as kind of my source of truth to share this with you guys. So coming back here, number 1 is going to be grouping related state. So what I mean by that is that if you always kind of update 2 state variables at the same time, it might be a good idea to merge those into a single state variable. And the reason for this, or one of the reasons for this, is because it helps prevent your state kind of getting out of sync. So for example, in your application here, let's say that you have a user profile or maybe a patient profile or something like that, and a user can come into your application and they can change this profile. So they can change their first name, their last name, their email, but they're always going to be doing these changes at one time. You're always going to be making changes to kind of the entire profile, or you're not going to be making changes at all. Well, since this state is kind of representing just a user profile, rather than just like individual pieces of state, it's probably a good idea to, instead of having separate state variables like first name, last name, and email, merging that into just one state variable called profile, and having first name, last name, email properties of that profile object. And then the way that you would update that can be seen right here, to where basically we use the name and value of the event target, assuming these would be inputs. And then we would make sure to spread the previous profile into the new profile. So making sure that we don't lose any state variables here or any properties of this initial object. So making sure to do that merge, and then using JavaScript dynamic properties to set the new value of whatever name is being changed here. So merging a related state into one, especially if you always change those state variables at the same time, this can be a really helpful strategy. So grouping related state. Number 2 is going to be avoiding contradictions in state. So you basically want to avoid having state that can disagree with each other, as this can just kind of lead to bugs and errors. So for example, below you could get into a state where isLoading is true and isLoading is also true, which kind of contradicts each other, because if it's loaded, then it can't really still be loading. So here we see that if we set up these pieces of state here, which is very common to see, I've probably made this mistake, and I know I've seen it before of other developers making this mistake. And I use the term mistake loosely, like this can work, it can be a non-issue, but you can get into, like I said, a contradictory state here, to where we could have a case to where isLoading is still true and isLoaded is true, because maybe you just forget to set isLoading back to false. And that can lead to just kind of weird issues in your state. But if instead of doing something like this, if you decide to just use a single state status, that kind of removes this potential mistake altogether, to where you could have a status of isLoading or a status of isLoaded. And that kind of prevents the possibility of having these contradictory states. And I realize that I just have a single quoted here, but it of course was meant to be just an empty string here as the kind of default status. But this is just one example of how you can avoid contradictory states or potential states that can disagree with each other and cause issues in your application down the road. So when possible, try to avoid these contradictory or states that could disagree with each other. Number 3, and I talked about this a little bit in my previous video, but try to avoid redundant state. So if you can calculate or derive some information based on your existing state or even the component's props, then you don't really need any extra state for that information. So for example, you might see in certain applications something like this, to where you might have a list of items, but you might also have a separate piece of state for the number of items in that list, which again, this can work, but it's not really needed. Like if you can avoid redundant state and just kind of get away with using less state in React, it's probably going to make things a little bit more straightforward in your application, because anytime you're using state, you're using some more dynamic data, which can be a little bit tricky to manage over time if you have a ton of different slices of state. Ask me how I know. So in this case, we don't really need this item count piece of state, because it's really just the items.length. So instead of having this entire piece of state, we could just have a JavaScript variable const item count is equal to the items.length. So we would get rid of this piece of state right here, because it's kind of redundant. We can derive the item count just based on this piece of state right here. So if you can calculate some information based on existing state, or if a component has props passed in, no need to make extra state for it. When you can, don't create extra state if it's not needed. Number 4, avoid duplication in state. So this might sound similar to number 3, but is just slightly different here. So when the same data is duplicated between multiple state variables or within nested objects, it's difficult to kind of keep them in sync once again. So reduce duplication when you can. Say we have an items array again, and then we also want to know like what's the current item, or maybe a better name for this would have been like what's the selected item if a user is viewing just a single item. Well, one way to do this would be we have our items array to where, say we have an item name as well as a ID for this item. And this should actually probably be title property is apple and then title property is banana. But I think you kind of get what I mean. So it has the name of the item as well as an ID for each item here. And then originally we have the current item. Well, that's just set to an object that has the name of the item here, as well as the ID of the item. But you can see we're duplicating state here. Our items list has this item, and our current item is just like a duplication of an item within our items list. So a potentially better way to do this is, instead of making the current item be the entire item object itself, just set the current item to be the ID of an item in the list. And this prevents you from duplicating the item itself, and you're just using the item ID to represent the current item. So this prevents any issues of things kind of falling out of sync, and it reduces duplication in your app, which can be helpful especially in more kind of complex applications. And then number 5 here, and this one I feel like is more of an obvious one. It's more so just like a general good practice when you're coding overall, to not try to work with deeply nested data. But in React, try to avoid deeply nested state when you can, and prefer structure that has your state in more of a flat data structure. So before is going to be, maybe you have some task data to where you have a task property and a meta property with a details property, and then properties within those. And like this state is just going to be tricky to manage because it's going to be dynamic and changing over time, and really trying to like update this state. Well, you have to make sure that you are creating copies of all this nested data, and it can be really, really hard. So a better approach here would be to just flatten this data out. Instead of having this deeply nested title and description and due date and status, just create an object that has a flat structure of data here. So this object just has a title, description, due date, and status property, all on the same level, compared to having this deeply nested structure, which makes it much easier to update here, to where we just spread the previous tasks in and then update the new task, rather than needing to create copies of all of our deeply nested objects and making this much more difficult to work with. So in React, 5 principles of kind of choosing your state structure is trying to group related state. So if you always update 2 or more variables at the same time, consider grouping those into the same state to variable. Avoid state that can potentially disagree with each other or contradicts each other, like an is loading and an is loading piece of state. Maybe just use a status state instead. Avoid redundant state. So if you can calculate or derive information based on a component's existing state or props, then no need to create extra state for that. And then avoid duplication in state. So instead of having 2 state slices that contain kind of the same values within them, maybe just use an ID for one to represent a selected item, and then generally try to avoid deeply nested state and flatten that state out to make things a little bit more maintainable and easier to work with. So hopefully this video kind of helps you out when deciding on the structure of your state. I know this would have definitely helped me out when I was kind of first starting out and maybe newer to React, and honestly, this was a good refresher to kind of go over for me as well. So this is a core principle of React that I think is, pretty fundamental to understand. It also might be a pretty common interview question to be asked about this, especially in more kind of entry-level React positions. So what I'm referring to is lifting state in React. And today I'm going to show you an example of this and kind of how it's done and what does it mean to lift state in React and why is it kind of important. So in this example, we have this drop-down list, and you can see here that currently you can open all these drop-downs individually from each other. So we can open drop-down 1, and that has no impact on whether drop-down 2 is open or closed. Same thing with all the other drop-downs. We can have all these open, we can have all these closed. It really doesn't matter. But what if we wanted the behavior of these dropdowns to be that if dropdown 2 is open, but I open dropdown 1, I want to close dropdown 2? How could we make that work here within React? Well, what we're going to need to do is lift state in order to allow each individual dropdown to know whether their sibling dropdowns are open or closed. So let's go ahead and look at the code for this. So I'm just rendering a page here within my technically Next.js application, but we're using React here. So everything I'm going to show you is applicable to just using vanilla React, but we just render our dropdown list within a page. If I go to my dropdown list, you see it just renders a list of dropdowns here. And if I go to my dropdown component, in my dropdowns themselves, this is where I manage the isOpen state and toggling the dropdown. So each individual dropdown has its own instance of this state, which is why we see this behavior of we can open and close each dropdown individually. And this might be what you want in your actual application. And this is fine to do. But if we want to make sure that like when I open dropdown 2 here, it would close dropdown 1, well, I would need to make sure that all of these individual dropdowns that I render in my dropdown list, each individual dropdown here knows the state of all the other dropdowns. So if I open 1, it effectively closes any other dropdown that might be open. And the way that we're going to have to do this here is we are going to effectively need to lift this state into its parent component and then pass that down into each individual dropdown. So rather than having this open state within the dropdowns themselves, we need to place this state in our dropdown list and then pass that into our dropdowns. So what we're going to do here is within the dropdown list, we're going to create some state, or I'm going to say const open index comma set open index is equal to use state, importing that from React. And then we're going to initialize this to null. And then we're going to create a function called const handle toggle is equal to a function in which we are going to set the open index to the open index is equal to the index question mark, then just pass in null, else it's going to be the index that we are going to pass in to this. So if a user clicks on a dropdown, we're going to call this handle toggle function. And if the index that we pass in is equal to the open index, the index that's already open, then we need to close that dropdown. So we're going to pass in null if this is true. Else, just pass in the index that should be open. And then for each component here, and we could of course render the title and content in a array and then map over this. This would probably be a potentially better way to do this. But for the sake of example, we're just going to make sure you can see everything out on the page here. But I'm going to say is open is equal to open index equal 0. So this is going to be our first index. So if this open index that we set is equal to 0, then this dropdown is going to be open. And then here, we're going to do the same thing, but set it to 1, same thing, set it to 2, and then I'm going to do the other ones as well. Set this one to 3, and then set this one to 4. So all those have their index, and now we just need to make sure that we call the handle toggle function when these dropdowns are clicked. So I'm going to say on toggle is equal to, and I'm going to pass a function in which I'm going to call handle toggle, and then I'm going to pass in a 0. Same thing for this one, but pass in a 1. Same thing for this one, but pass in a 2. Same thing for this one, pass in a 3. And same thing for this one, but pass in a 4. So now we're managing this open state in this dropdown list component. So we can remove this state from our individual dropdown component, and we can instead just destructure is open and on toggle, I believe is what I called it. Let me check. Is open and on toggle. And then we still use our is open state here, but then we just need to pass on toggle to this on click right here. So now that really should be all we need to do. If I come back and I try to open more than one at a time, you see it automatically closes the other one. So we're getting the effect that we want here, because what we did is we moved this state, we lifted it into its parent component. So it's no longer in this dropdown, an individual dropdown. We lifted this state into the dropdown list component, and now we passed the state down into each individual dropdown. So since this state is being owned by this parent dropdown list, it allows this dropdown list to now control which dropdown is open. And that's important for our example, because if dropdown at the 0th index is open, we want to make sure all other dropdowns are closed. And we're just doing this by this open index piece of state. So in React, lifting state is the idea of we had this individual state in a certain component, but we needed to have that state be shared across other components. And in order to do that, we needed to lift that state into the next closest parent that we could, to then pass that state down into those components that needed to kind of share that state. Now, there's other ways to share state across your different components. You could use context in React. You could use something like Redux or Recoil or some other global state manager within your application. But conceptually here, what it means to lift state is basically taking state from a component that tends to be further down towards your kind of leaves on a React tree, moving that state up into a parent component, so then you can pass that state down your component tree to all the components that need it. So here we take our state from our dropdown. We needed all of our dropdowns right here to have that kind of open state or to know about that open state. So we moved it into this dropdown list component. Now, we didn't need to move it all the way up our component tree into our home component. We don't need to pass it into our dropdown list. We can make our dropdown list be the owner of that state, because our home component doesn't need to know about that state whatsoever. So we just lift it to the next closest parent that can then pass that state down into these components. But effectively, we're just moving the state up our component tree, so then we can pass it back down into all the components that need it. Now, if you end up needing to pass it down several layers through your component tree, that's where using something like context or a more global state manager makes sense to me anyways. But if you just have to pass it down a layer or two, like right now, we just need to pass it down one layer here. We manage it in the dropdown list parent component, and we just pass it down one layer. I think that's perfectly okay to do. And even if we manage the state in this home component and we passed it down into dropdown list and then passed it again into dropdown, I think that's also okay. But if you start going through several layers of prop drilling is what it's called, then at that point, it becomes a little hard to manage. A common misconception in React is that state lives within a component. But I think it's a little bit better to think about it as state is assigned to a component at a certain position, and React will preserve a component state so long as it's being rendered in its same position in the UI. So we're going to just go through some examples of this, as I think just hearing that, it might not click. And just so you know, a lot of this information comes from this page in the React docs. I will link this in the description so you can read through this as well. But what I mean by this is, let's go look at the code for this grudge list component. The TLDR here is that you can add new grudges, but you of course can't remove them because they are indeed grudges. So if we look at this component here, what you're going to see is that if it has this isFancy prop, it basically adjusts the styles of this component and updates the styles whether it is fancy styles or not. And then in our page, we basically have some state that says is fancy, set is fancy. We can check an input, and then that's going to render this grudge list, whether it is fancy or not is fancy. So the kind of key thing that we're talking about here is when does React decide to preserve state? So when we check whether it is fancy or not fancy, and we change the value of this prop, do you think it's going to change the state of this component regarding like the grudges that we render out in this list? Do you think it's going to clear this list of grudges if we just change the value of this prop? Well, if we come look, you can see changing the value of this prop, it's not changing the state of our grudges. Now, what if we do something like this? What if we open up curly braces to enter JavaScript land and we do a ternary operator? So if we check is fancy, question mark, then we're going to render a grudge list in which is fancy is just going to be a Boolean of true. Else, we will render a grudge list to where is fancy is going to be false. So do you think in this case, does changing whether is fancy being true or false, does that change the state of the grudge list here? Like if we render this grudge list, is it going to have the same state as rendering this grudge list? Or if we toggle is fancy, is it going to wipe out the grudges of this grudge list if we then render this grudge list? Let's take a look. So as you can see, I'm going to just refresh right now and clear the state for good measure. So let's clear the state. Let's add a grudge 1, and then we'll add number 2, and that should be enough for now. So if I click use fancy styling here, is it going to wipe out the state of the grudges? Because here, if you think about state living within a component, you might think, okay, well, for our, right now it's in is fancy is false, because this is definitely not very fancily styled. It's also definitely not a word. Actually, I don't know if that's a word or not. But for this grudge list, if we toggle it to true and we render this grudge list, is it going to render a new list of grudges, or is it going to reset the state here within our grudge list? Well, if we think about state living within a component, you might think that's true because it kind of looks like we're rendering two separate components here, but let's kind of see what happens. We have our two grudges. I toggle it on and off, and we don't see a change in state. And this kind of comes back to what I introed with. React will preserve a component state as long as it's being rendered at its position in the React tree, in your UI tree. But if we look at this, we can see, well, we're rendering this in the same position in the DOM tree. We're rendering it as a sibling to this label component both times. We're not rendering any other kind of component or anything like that. We're rendering our grudge list component in this same position. So regardless of whether we render this grudge list here or this grudge list here, we're not going to see a change in state, as you see here. Now, what if we get even crazier with this? What if we do something like, if is fancy, if that is true, then what we're going to do is we're going to take this entire piece of React tree here, so to speak. We are going to render it here, but instead of this ternary operator, we're just going to render is fancy as true. Effectively, we're just going to set that to a Boolean of true. And then I also need to do a return statement here and render this JSX within the return statement. So now we're really making things look quite a bit different. And then in this case, we will just render our grudge list as is fancy with false. The key thing to remember here, though, is React will preserve a component state as long as it's being rendered in the same place in its UI tree. So in both these cases, we are still rendering the grudge list at the same place in the UI tree. All of this is the same. All of this is the same. We render our grudge list here. All of this is the same. All of this is the same. And we render our grudge list here as a sibling to this label component here. So in that case, if I'm going to refresh for good measure again, we'll just add 1 and then add 2. And if I toggle this, you see that It maintains the state of those lists. And at first glance, you might think that React is rendering a totally different grudge list right here because we're doing like an early return of this HTML. And then the same thing here. But since we're rendering this component at the same position in the UI tree, it is not going to wipe out state or reset the state of this grudge list. So component state doesn't necessarily like live within the component. It's more so like assigned to that component if it's at the same place in the React tree. Now, what would be an easy way to kind of change this? Well, say we did want to make sure the state was reset if we toggle back and forth between them. Well, we could just change its structure in the React tree a little bit here. And of course, there's other ways to do this. But now, if isFancy is false, let's render that component within a span here. So we're changing its structure in the React tree to where this one, we're just rendering it as a sibling to this label. But right here, we're actually rendering it as a child to a span that is a sibling to this label. So let's come back. I'm going to refresh for good measure again. Let's add 1, add grudge, 2, add grudge. And now when we toggle, you see that it clears the React state. Let's add 1. We see it's the fancy styles, but now I toggle and it removes the state. And it does that simply because it's rendering those at 2 different locations in the React tree. So the common misconception here is that state just kind of lives within a component. And I think it's better to kind of think things about React is going to maintain or preserve a component state as long as it's being rendered in the same position in your overall UI tree. As this could be a little bit tricky to reason about if you weren't thinking about it in that way. So I hope this was clear. I hope this kind of, clicks something for you. I definitely recommend reading that page more. I'm going to create some other videos that are kind of a similar topic to this because I do think this can get a little bit tricky, but it's definitely helpful to understand, especially in kind of larger applications. So a common mistake that can be seen in React apps relates to having a single source of truth for your state. So in this example here, I'm going to show you kind of an obvious example of where this might be an issue, but just know that this can work in much more kind of subtle ways and kind of creep into your application here and there and ends up causing different bugs and just is generally a bad practice. So what you're going to see here in this example is we have the ability to toggle our theme in our home component, but you see that doesn't affect the theme in our 2 card components here. Although I actually kind of think the UI for this doesn't look terrible, but let's just say that we want to toggle the theme in one place and then that affects all of our components rather than all 3 of these components here are managing the theme state separately. So there's not a single source of truth for the theme state, which in most cases is going to be what you want here. So to go ahead and fix this, all we need to do is make sure that we just have one source of truth for this theme state. And then the way that we're going to do this in this case is we're going to just lift our state. Now, for theme in particular, you're probably going to want to share that state globally with either using React context or maybe some other global state manager, just because you're probably going to be using your theme state throughout your application, or you're going to be using global CSS in Tailwind or whatever CSS that you're kind of using within your application. So our example, we're just going to lift state. So in our home component, we manage this isDark state right here. In our user profile, we do the same thing here. And then our dashboard, we do the same thing here. So all we need to do is pass our isDark state down into the dashboard and down into the user profile card. I'll create an interface since I'm in TypeScript here, and I will call this dashboard widget props. It'll have an isDark that is a Boolean, and then it'll also have the ability to toggle the theme which is just going to be a function that doesn't return anything. And then here within the props, we'll accept isDark and toggle theme. And then I'll get rid of this state within the component here. And then I just need to do the same thing within this user profile. So I'm going to copy dashboard widget props. And then within user profile, I'm just going to rename this to user profile props. And then it's going to accept isDark, toggle theme, user profile props. And then I'll get rid of this state here. And then now within our home component, we just need to pass those props to these components. So isDark is equal to isDark, and then toggle theme is equal to toggle theme. I will copy these props and pass them into our widget here as well. So now if I come back and I refresh the page, now when I toggle the theme, you see that it changes the theme for all of my components. So I can toggle any of these components and it changes the theme for this entire page here, which is probably what you actually want to do here. So now we just have this single source of truth for our state. It is right here within our home component, our isDark state. And this is going to be a lot more manageable and lead to likely a lot less bugs rather than trying to manage the same state in several different components. Now, like I said, this is a pretty obvious example of doing this, but in larger applications, you'll have to make decisions on, okay, what do you want to be your single source of the truth of state? Like, do you want it to be coming from your database? Do you want it to be coming from global React state? Where do you want it to be? But just for the concept, just try to remember you don't want to create duplicate pieces of state throughout your application, which are all kind of managing really the same state. You want to just have a single source of truth for that state, or else, like, trust me, you will run into issues, because I've definitely done stuff like that before. And I think a lot of it comes down to, like, sometimes you realize that you're kind of duplicating state and managing the same state in two areas, but in the moment, it's like, can kind of be annoying to have to do like a refactor or lift the state or move it to global state management or adjust your backend APIs. So your backend is your single source of truth. Like, in the moment, it can kind of be annoying to do that refactor, but trust me, in the long run, make sure to kind of do it right the first time up front and just have that single source of truth for your state. So I hope this kind of gets the concept across, even though this was a fairly obvious example, and I hope it helps you out. So when managing React state, you might run into an issue that isn't maybe particularly clear what's going on when you first notice it, especially, if you're a little newer to some of the nuances, let's say, to managing React state. So let's say that you have, this is, of course, like a contrived example for our demonstration purposes here. But in our case, we have this scoreboard and we have player A's score to where they can increment their score, but then the user can go ahead and go to the next player. So we switch to player B, but we see that the score doesn't change here, which is probably not what we want from a state perspective. We probably want to reset the state here when we click next player or toggle back and forth between player A and player B. So let's look at the code here. And what we have going on is we have our scoreboard, we have our isPlayerA state right here that we default to true. And then we have a button that will kind of toggle our player back and forth. And then we have our logic right here to where we check within this div, isPlayerA, then render our counter component to where our person prop is set to player A, else render player B. So pretty straightforward here. Like this doesn't look too dissimilar to how you would, maybe structure your own code here. So what's kind of going on here? Like, it looks like we're rendering two separate components here, but when we toggle back and forth between rendering this and rendering this, our count within our counter component, the count just kind of remains the same. And if you saw my last video, you kind of know what's going on here. So state isn't necessarily specific to like this instance of the counter component or this instance of the counter component. State is more specific to a certain component within a certain position in the React tree. Regardless of whether we render this counter here, player A, or render this counter here, player B, we're still rendering them in the same position in the DOM, in the React tree, so to speak, right within this div component. If that's true, one way that we can fix this is we could, and I'm going to show you what I think is maybe a little bit of a better way, or kind of more so my preferred way. These two ways are not the only two ways that you can solve this issue, but one way just to fix the kind of issue of rendering them in the same position is we could render player B within a span here. So player A is rendered as a direct descendant of this div within the tree, but player B, it's within the div, but it's also within the span. So we've kind of nested it a little bit further in the tree. So now if we switch back and forth, let me just refresh for good measure. I'll increment A here. Next player, you see that the score gets zeroed out. So just by rendering them in different positions of the React tree, we see that it actually resets the state here when we shift between our two players, which in this case might be what you want. Now, what I think is potentially a little bit of a maybe better way to do this without needing to add more nodes within your tree is you can actually, similar to how you render lists in React, you can actually render a key for each of these components here. So I'm going to render a key for person A, and let's just use the key of A. And then for person B, I'm going to render a key that is equal to B. And this should have the same effect. And I'm going to refresh for good measure. But let's increment, next player, increment, next player, so on and so forth. And you see that it resets the state here, because this is effectively telling React that, hey, since we added a key for these two components here, then they should kind of be treated as their own kind of separate components with separate state. So toggling back and forth between these is still going to reset their state, even if they're in the same position in the React tree. And this would probably be my preferred way to kind of solve this issue if you run into it. So yeah, I think that's all I got for you here. I hope that was helpful. It might not be particularly evident if you run into this kind of initially and you don't really know what's going on, but hopefully those solutions make sense there and that this video makes sense. But if not, let me know down in the comments below. In this demo application here, where you can add different tasks, and I know to-do lists or task lists like this are pretty much a cliche at this point when it comes to web development tutorials, but it does kind of get the point across well. So we have this task list, and you can add new tasks, you can delete them, edit them, save them, mark them as checked, so on and so forth. Now, we currently manage this with just using React state. So if we go to the actual component here, what you're going to see is that we have this use state to where we manage our list of tasks. And then we have our like edit task ID, edit task title, new task, so on and so forth. And then throughout this, we have a function to add a task, delete a task, toggle the completion of a task, start editing a task, save editing, and then kind of all of our JSX here to render things out and to call the different event handlers. So that's great and all, but today we're going to kind of convert this to, instead of using just the use state hook in React, we're going to use the useReducer hook and use reducers to manage this state rather than just using use state. Now, towards the end of this video, we're going to cover some like pros and cons of reducers because, they're definitely not the go-to solution for managing state all the time. And, we'll kind of see what it looks like here, as sometimes it actually results in more code, but it can also be more manageable. So there's kind of a little bit of a give and take with reducers, but I'm going to show you how the useReducer hook works and how we could kind of fit it in to this task manager component. So first of all, I probably don't need this side menu open, and we can kind of clear up those files up top. But what we're going to do first here is we are going to skeleton out our useReducer call. So instead of having our useState call here, what we're going to say is, and this is going to, of course, throw errors here at first because we're going to have duplicate pieces state. But we're going to say const tasks, comma, dispatch is equal to useReducer. So this is a hook from React, very similar to useState. It's just another hook that helps you manage state. But what it's going to accept as arguments here is first, it's going to be a reducer function. So in our case, we're going to call it task reducer. And what a reducer function does is it effectively takes multiple things and then reduces it down to one thing. So in our case, it's going to take the current state as well as some sort of action that the user takes, and we're going to display that or represent that action as just an object. So it's going to take the current state and an object, and it's going to reduce that down into what the new state should be. And I'll, of course, create this function and show you more of how it works. But then as a second argument to the reducer function, it is going to take the initial state. So what we can do here is above our task manager component. And if you see this use client here, just ignore it. This is technically a Next.js project, but this is all just pure React code. What we're going to do here above our component is I'm going to say const initial state is equal to, and it's basically going to be what our initial state was right here for useState. And I'm going to pass it like so. And I'm just going to get rid of this useState call here. Now the useReducer hook, it's going to return our current state, and it's also going to return a dispatch function. And all this is a way for us to tell our reducer function effectively what action the user took. So when we call the dispatch function, we might say something like the user added a task. Okay. And then the reducer function is going to accept the current state and that action, and then just figure out how to update the state from there. So let's actually start building out this reducer function. So below my initial state here, I'm going to say const task reducer is equal to, well, what arguments is it going to accept? It's going to accept the current state, and I'm just going to say it's state. And it's also going to accept some sort of user action. So action. And then we're going to make this an arrow function. And now once in this function, what we basically need to do is, okay, we need to see if the action was that they added a task, then we need to update the state based on that action. If the action was they deleted a task, we need to update the state based on that action. So a very common way to do this is using a switch statement, because we're going to have different cases of different actions the user took. Now you can also write this using if statements, and that sometimes that can be the better approach. But for me, I tend to like using the switch statement because, as you'll see, you can kind of more easily see the different cases for that switch statement. So we're going to say switch, and then this is going to be on the action and we're going to pass a type property on the action. So action.type, what type of action is it? And this is kind of the convention when using reducer functions. And we'll open up curly brackets, and then I'll do case. And then what should our first case be? What should be an action that we handle here? Well, we should handle whether the user added a task. And one kind of small note is that I am kind of thinking in more so past tense here. So like added a task rather than add task. I've seen it either way, but for me, it just kind of makes more sense like handling an action that the user took. So added a task, deleted a task. So kind of making things past tense to me makes a little bit more sense. And I would say probably is what you're going to see a little bit more often. So for our case, we want to do added a task. And in our dispatch function, we are going to dispatch an object to where the type is added task. So to prevent us from repeating ourselves here, what we're going to do is we're going to create a constant, and I don't know, maybe I'll just say const task reducer, and that's going to be an object where added task is going to be added task. And then I'm going to also do deleted task, toggled task, and edited task. So we have our constants set up here. So now the first case is going to be, we'll do task reducer dot added task. So what do we want to do if they added a task? Well, we're going to return an array where we're going to spread in the previous state. Then we're going to add a new piece of state where the ID, we'll just be a little hacky with it and just do date.now. But you're probably going to want to use like some sort of, helper function to generate a ID. The title is going to be, well, on our action object, we also want to pass basically the title of the new task. And the convention here is to pass it on the payload. So for this, the title is going to be our action.payload. So when we dispatch this action, we're going to want to make sure that for an added task, we want to, on the action.payload, pass the new name of the task. And then completed is going to be false for an added task. And really, that should be it for adding a task. But now we just need to go through the other cases here. So another case is going to be task reducer dot deleted task. And then in this case, we need to return our state dot filter. We're going to accept a task. And we're going to say the task dot ID is not equal to the action dot payload. So when we dispatch an action for a deleted task, the payload should include the ID of the task that we want to delete. And then here we just filter that out. And real quick, whatever you return from the reducer, that is going to be your new state. So we're returning for our added task, our new state plus this task here. For the case of a deleted task, our new state is going to be filtering out the action.payload task, the one we want to delete from our current tasks. So whatever you return from your task reducer is going to end up being your current state. Now we need to do our toggle task, where we're going to return our state dot map, accept our task, and then say task dot ID is equal to action dot payload. If that's true, then spread that task, but say completed is going to be equal to task dot completed, but we need to make sure to toggle it. So we'll say not task dot completed, else just return the task. So map over our tasks, find the one that matches our action dot payload, toggle the completed, else just return the task in our map function. And then the final case here is going to be our task reducer dot edited task, where we're going to return state.map task, find the task.id is equal to the action.payload. If that's true, spread the task, but then set the title to be the action dot payload dot title actually is what we're going to want to do. And this should be action.payload.id, else just have it be the task. So in this case, our payload for an edited task is actually going to be an object that is going to have our action.type on it, but it's also going to have an action.payload, which is also an object that has an ID of the task that we want to edit or that the user edited. And then also the payload is going to have a title, which should be the new title for the edited task. And I will fix these case statements here as well. So let's make sure that they're all kind of lined up with each other and a little easier to read. I would definitely recommend using Prettier, but I do not have that set up right now. But by default in our case statement, we will actually throw a new error and just say unknown action type. And you might also like console log or log out the action or the state right now as well. But we'll just kind of throw this generic error. So that kind of sets up our task reducer, which we're already passing into our task manager here. And then really from here, all we need to do is update our functions to dispatch actions instead of like manually updating the state. So for add task here, we'll keep our check. If the new task is empty, just don't do anything. And we'll also keep our set new task title, kind of resetting the state here. But for kind of this in between here, all we need to do is call our dispatch function with an object to where the type is task reducer dot added task. And then the payload, that should be our new task title. So that kind of, to some degree, simplifies our add task function, and kind of a lot of the logic for managing our state is now just in this one single reducer. Since I used a switch statement, you can easily see the different cases here. If you're like debugging, okay, deleted task isn't working, it's very easy to come and find deleted task here. So that should be add task for delete task instead of this logic kind of directly here. We're again just going to dispatch, call that function with an object to where the type is going to be our task reducer dot deleted task. And I definitely could have named that constants object a little bit better. But then the payload is just going to be the ID that we pass into deleted task. For our toggle task completion, instead of setting the state directly, we are also just going to dispatch an action object that has type task reducer dot toggle task. The payload is going to be the ID once again. For start editing, that's going to remain the same because we're still using set state. So you definitely can use useReducer with use state calls. That's perfectly fine to do. But then the save edit is going to be a little bit different, where instead of setting tasks directly, we're going to dispatch our action to where the type is going to be task reducer dot edited task. And then this one, our payload's a little bit more complex. So we'll have a payload that is going to be an object to where the ID is going to be our edited task ID or our edit task ID. And then the title is going to be our edit task title. And then everything within our code should remain the same because we're still calling all these functions with the same stuff. We might have actually wrote a little more code there with adding the reducer and adding these constants, but some would argue that this is a little bit more easy to manage because we're just dispatching actions here from these functions rather than immediately updating the state. So a lot of our state logic is just in this one single function that might be a little bit easier to maintain and debug if things aren't working quite correctly. And this is Editor Ryan here, but just as a quick note. So I'm not sure if this was clear going through the video and editing it, but when you call the task reducer, your reducer function with dispatch here, so like we dispatch this action, you see that we're not calling it with the current state. And that is because React will automatically pass in the current state to your reducer. So when you dispatch an object or an action, that is effectively immediately passed into the second argument to your reducer function, because React will already pass the current state to your reducer. So if that kind of seemed a little bit magic in the video, just know that React automatically passes the current state to it, and then your dispatch function effectively calls your reducer. But since React is already going to pass the current state into it, your action is just going to take that second argument there. So if that was confusing, hopefully that clears it up. So let's go see if this works here. Let's refresh to make sure we're all good. I'm going to add another task, another one here. Let's see if I can toggle them. It looks like I can. Let's edit this one. Let's save. That looks good. Let's delete. So it looks like everything is still working correctly. All we changed was how we manage state under the hood, which is exactly what we want. Let's head to the React docs and just finish on a few things that are important to note. So in their docs here, I'm going to just run through some of their comparison between useState and useReducer, just to kind of give you another overview and kind of their perspective on it. So for code size, generally with useState, like I kind of showed you, sometimes you have to write less code up front, but with useReducer, you have to write both a reducer function and dispatch actions. However, useReducer can help cut down on the code if many event handlers modify state in a similar way. So yeah, it does depend. It is kind of a case-by-case basis, but I would argue that it's not bad to write more code sometimes if it makes things a little cleaner and more manageable, which I think useReducer sometimes does do, but I also think sometimes useReducer does just kind of make things a little bit more complex than it needs to be. Readability, useState is easy to read when the state updates are simple, but when they get more complex, they can bloat your components code and be difficult to scan. In this case, useReducer lets you separate the how of the update logic from the what happened of event handlers. So rather than in our kind of event handler functions right here, rather than focusing on updating the task state directly, we just had to dispatch an action saying, okay, what happened? They added a task, they deleted a task, they toggled a task, and then we let our reducer manage how to actually update that state. So it's kind of separating those concerns there is what they're getting at. And then with debugging, when you have useState, it can be difficult to tell where state was set, but with useReducer, basically everything happens within a reducer. So when we were using useState earlier, we were setting the state here, we were setting the state here, we were setting the state here. Sometimes you'll see it also be done in the event handlers themselves, and we're setting state in all these different places. With useReducer, we're really just setting state in our reducer function. And then for testing, a reducer is a pure function that doesn't depend on your component. This means you can export and test it separately in isolation. While generally it's best to test components in a more realistic environment, for complex state update logic, it can be useful to assert that your reducer returns a particular state for a particular initial state and action. So could have some testing benefits. I'm kind of on the fence about this one. I think that you can still find ways to test your components regardless of whether it's using a reducer or useState. Personal preference. Some like it, some don't. That is definitely for sure. For me personally, I'm kind of meh. I tend to default to using useState, but sometimes if it is like a more complex piece of state that is being updated in a bunch of different event handlers, sometimes it is helpful to kind of separate things out into a reducer. But for the most part, useState is my default until things start getting a little bit unmanageable. Then I'll switch over to useReducer. And then for a couple of things for writing reducers well, just make sure your reducer function is pure. And then also each action describes a single user interaction, even if that leads to multiple changes in the data. For example, if a user presses reset on a form with 5 fields managed by a reducer, it makes more sense to dispatch one reset form action rather than 5 separate set field actions. And then I'll, of course, link these docs in the description below if you want to read more about this. But let's do one last overview of the code here of what's going on, just to make sure that we're all on the same page. So the useReducer hook in React, it's going to accept a reducer function as the first argument. This reducer function is simply going to be a JavaScript function that takes 2 arguments, the current state, as well as an action object that represents some sort of user action that the user takes. From there, within your reducer function, you're going to see what action type it is, what action the user took, and then you're going to return some new state based on the current state and whatever action it was. And in that action, you might also send a payload if you need more information on how to update that state. And that payload might contain the title of a task, the ID of a task, or different things to help you update the state based on whatever action it is. And then whatever you return from your reducer function, that is going to be your new updated piece of state. And then as the second argument to useReducer, it is just your initial state. useReducer is going to return an array of 2 items. The first is going to be your current state, just like the useState hook. But the second is going to be a dispatch function that allows you to dispatch actions for your reducer function. So then throughout your code, instead of just calling the set state function directly, you actually just dispatch using your dispatch function an object that contains basically the information needed for you to update the state in your reducer function. So in add task, we dispatch an object that has a type saying the user added a task, and then the payload of the new task. Same thing with delete task, dispatch an object to where the type is deleted task. The payload is the ID of the task we want to delete. Same thing for toggling a task, as well as editing a task. But this time our payload is actually an object with a little bit more information, the title and the ID. So really not too complex. I think sometimes people are a little scared of reducers, but you're really just probably a step more complex than using the useState hook. So hopefully this video kind of helped you see some of the pros and cons of reducers, where they might be useful, and how reducers work in React. So in React, something that you're commonly going to do is pass props from one component to the other. So if we look at our kind of page component here, we can see we have this component and we pass what looks like an HTML attribute, but as you're probably aware of, this is a prop. And props are great. They basically allow you to add arguments to your components, which are just kind of JavaScript functions. So it allows you to kind of customize your components a bit easier. Now, you can run into a problem with passing props. And straight from the React docs here, they mentioned that passing props is a great way to explicitly pipe data through your UI tree to the components that use it. However, it can become verbose and inconvenient when you need to pass some props deeply through your component tree. And the nearest common ancestor could be far away from the components that actually need the data. So you have to kind of lift this state really high up into your component tree and then pass your props all the way down. So in their little diagram here, sometimes say you have a component and then you need to pass a prop to this child and this child component. And I'm going to show you examples in actual code in a second. This is perfectly reasonable. This is still very manageable. You're just passing props one layer to one child and one child. But you are going to run into situations in your application where maybe you have that same sort of parent to child setup, but then you realize that, okay, well, actually, these children over here in my application also need that same state. So you end up lifting state, and then you end up having to pass it down to 1, 2, 3, kind of 4 layers deep in your application tree and you have your state kind of spread out throughout these children. You're passing it through components that don't really need to know about that state. They're just kind of passing it through. And that starts to get much more unmanageable. And that's the whole issue with prop drilling is it becomes very inconvenient and verbose, as they're mentioning, to pass props through multiple layers. I think it also makes it really hard to kind of maintain that state when you're having to track it through several layers of your application and it's going all through your component tree. And sometimes you're even passing it into components that don't even need it. They're just kind of like pass through components, which generally can be a little tricky. So if we look at my demo application here, I have several different components to where we kind of mimic this layout right here. So if we look at the code, I have my page component and we render a hierarchy diagram, which is really just this data flow here. So you can kind of ignore that right now, but we render a grandparent component that accepts a user data prop, which is just this hard-coded user data. And if I click into my grandparent, you can see that this component, it renders two more components, a parent and a sibling, and it passes through more of that user data. But to the sibling, it passes the task completed prop. And if we look at my diagram, we have my dashboard, which is my grandparent component. And then it has this user roles child and this user statistics child. And then further, if we go into this parent component, it maps over and renders a bunch of different child components, which those child components are going to be these role components here. So admin, editor, and viewer. And if we further click into that, we have this data display component that is going to render the name and role of a certain user. So you can see we're passing this user data through several different layers of our component tree to where it goes from grandparent to either parent or sibling here. Sibling, it just stops here. It doesn't pass it any further, but grandparent passes it down to parent, which passes it into child, which passes it into data display. So we're kind of drilling this all the way through our application in this sort of hierarchy here. It's starting at grandparent, passes it to sibling, also passes it to parent, to child, to data display. And in our case, we still use the state in parent and in child. But if you were just needing that data in this data display component and passing it through parent and child, it kind of makes you feel like, I wish there was a better way to do this, especially if these components weren't using that state. And luckily, there is solutions to prop drilling to where you can use context in React, which is going to be probably my next video in React, or you can use some sort of like global state manager, something like Recoil or Redux, or there's several other kind of new kids on the block as well that can help you do that. And I've heard great things about. But the kind of purpose of this video is to kind of show you the issue with prop drilling, what it is, and show you an example in code. It is kind of tricky to show like a realistic example that makes it super clear why it's an issue. But in larger applications, drilling props through several different layers, passing them to siblings, it becomes very unruly very quickly, and you need to use some other solution in those cases. So hopefully this video helped you understand the problem with prop drilling, what it is, and in future videos, we'll kind of dive into more examples of how to solve the issue of prop drilling. There's going to come a time in your professional React career to where you're probably going to want to share some state between components. In my previous video, we looked at having some data and then having to send that data through several different layers of components. So this is also called prop drilling. So here we have our user data. We passed it into this nested component, and then we pass it further into this user details component, and then we actually use this data. But on the same level, we have our user data. We pass it into this user card component, and we use it here. So in this example, you probably wouldn't need to have shared state, but it kind of gets to the idea of we have a kind of deeply nested component, at least a few layers deep in our React tree, that needs to use the user state. And this user card component also needs to use it. So we have to lift that user state into this home component and then pass it down into both. Now, in this example, that wouldn't be a big deal. Like if this was your actual application, I would say, hey, just pass these as props. It's not a big deal. But what you're going to find is that sometimes, especially for data like user data, where you might need to use almost everywhere in your application, or at least in a lot of different places in your application, if you have your React tree and say you have a component way over here on your tree, and then this component in the middle of your tree needs it, and then this component over here in your tree needs it, and this component over here needs it, well, you're going to have a really difficult time probably managing that state in just one place. And it's going to be a little bit easier to share that state across your application. So today I'm going to show you one solution to that, and that is using context in React. And just so you know, this starter project will be linked in the description below. So if you do want to follow along as we go, you can absolutely do that. Just make sure to clone the repo, npm install. It is going to be a Next.js project, but I will handle any Next.js specific stuff as we go here as well. So the project is linked down below. Now, if anybody listening to this knows why React actually called it context, let me know. I mean, maybe it's a way to give your components more context throughout your application, but I feel like that's a stretch, and I'm not sure I love the name context, but all it is a way to share state throughout your application. So to solve this issue here, I'm going to open up our Finder here, and we basically need a way to, in our user card here, to consume the user state directly, and also in our user details component, just to consume this state directly. So we're going to create context to do this. So I'm going to create a new folder called contexts, plural. And this is where we're going to store, if we had multiple contexts, we would store it here. We'll just have one. I'm going to create a new file called user context.tsx. And later on in this video, we'll go to the React docs to kind of talk about when you should and shouldn't use context. But right now we'll focus on how we can actually solve this problem here. I'm technically in a Next.js application, so I'm going to put use client here up at the top, but you won't need to do this if you're just in a React application. Everything else is going to be just pure React, so it's still going to apply. I just needed to do that for this Next.js project. But here we're going to import create context, React node, use context, and use state from React. And then at the top, we're going to create an interface for our user, or create our types for our user, because we are in TypeScript here. So I'm going to create interface user, and it's going to have a name, which is a string, an email, that's a string, and a bio, that's a string. And then we'll create another interface, and this is going to be for our user context, the type for our user context. So interface, user context type. It's going to have a user, which is going to be our user interface, and then a set user, which is going to be a function that accepts a user, and it is not going to return anything. So just void. So basically that sets up our types there. That's all we did there. If you're not using TypeScript, you can just ignore that part. But now, in order to use context, we first need to create a context, and we do that with the create context function that we import from React. So we need to say const user context is equal to create context, and then this is going to be used as a generic function here in TypeScript. So we're going to say user context type or undefined, and then we're going to call create context. We're going to initialize it with undefined. So when we first call create context, you can call it with an initial value. In our case, we're just going to make it undefined, but we will update this here in just a second, or at least the value. but this will remain the same. So we call create context. That's going to create our user context. Now I'm going to create a provider. You wouldn't necessarily need to do this, but I think it's a little bit easier just to do it in a specific file for this specific context. Because in order to be able to use the values in this context, we need to use a provider. So the way that this is going to look is I'm going to export a const called user provider, and then it is going to accept children because we are going to use this as a wrapper component around other components. And we're going to add a type annotation as React node here. And then within the body of our user provider, I'm going to say const user, set user. So just using normal state here. It's going to be use state, and it's going to be of type user. We're going to call it and initialize it with actually some values here. So we're going to have a name, an email, as well as a bio. And I am going to put default values in these. I'm going to do John Doe at example.com, and some random bio here. So we have those all set up. And then now what I want to do is I want to return, I want to wrap my user context provider around the children. So I'm going to say user context dot provider, and then I'm going to pass in a value where we are going to have the user as well as the set user. And then we're going to pass our children in. So what we're basically doing is saying we have this user provider component that we can basically now use this user provider component. We can wrap it around any components that might need to use our user and set user context or user and set user values. We just wrap it around any components that need it. And then these components will be passed along as children. And then those components can consume the values of our user context provider. So they can consume the user as well as the set user state. So we just wrap this user provider around any components that might need to use the values that we set here for our user context dot provider. Now we're going to do one final thing here. We're going to say export const use user is equal to a function. And then we're going to say const context is equal to, and we're going to use the use context hook from React. And when you call the use context hook from React, you need to pass in the context that you want to use. And in our case, it's just going to be our user context. We'll do a check here. If not context, then we will throw new error. And I'll just say no user context, else we will return our context. So basically what this is doing here is when we actually want to use this user context, the way that we're always going to do it is by calling the use context hook and passing the user context in it. So we're just creating this helper function here called useUser that basically, if we just call useUser, we're already just going to be passing the context into use context. And if it exists, we return it. So when we want to use our user context, we don't need to do this step right here. We just call this useUser function, and that's going to return our context. So I know it's quite a bit of steps there. You can, mostly ignore these type annotations here. I think that makes things a little messier sometimes to see, but really all we need to do is call the create context function from React. That's going to create our context. And then we need to wrap that context dot provider around any component that is going to want to consume the values of that context. So in our case, we created this user provider function that is going to be a wrapper function that wraps around any component that needs to use the context. We set this value prop to the values that we want to share with those components that are going to be wrapped by this user provider, in our case, the user and set user. And then we create a helper function where we call the use context hook from React. We need to pass it in our context here. And then we're able to just return this context from useUser, which is going to have our user and set user values on it if our provider is wrapped around our components that are calling this useReducer function. But now that we've created this user context, now we just need to go use it in our components. So first off, in Next.js here, we're going to go to our layout here, and we're actually going to wrap our user provider around our root layout here. In React, you just want to make sure to wrap your user provider around any component that might need to use the user context. In our case, this root layout is going to wrap our entire application. So we're making sure that any component within our entire application is going to be able to use the user context. So we're wrapping user provider around our root layout here. So all of our components are going to contain our user context or have access to our user context. But now let's start consuming it within our cards here. So in our user card, all we need to do here is say const user is equal to calling useUser. And that's going to return our user context. And we need to make sure to import that, but that's going to return our user context, and then we're destructuring user. Now we don't need any of these props anymore, and I can get rid of all of these. And then here in Next.js, this just needs to be a client component now. So I will just put that at the top. And then if I go to my nested component here, I don't need to pass through my user anymore to user details. So I can get rid of this. I can get rid of this. We can get rid of all of this. And then I'm going to put use client here up at the top of this page as well. And then finally in user details, we can also get rid of all of this, put use client at the top. I can get rid of user details here. And then all we need to do is say const user is equal to use user from our user context. And then back at our home page, we no longer need to pass the user to either one of these. So we can remove those. I can remove this, and I can remove this. So really, we've simplified our components quite a bit here because we're just consuming our context directly within our user card here, as well as our user details. We're just calling this useUser that we created here within our context. And if I come back to our application and I refresh the page here, you see that nothing changes because everything still works as expected. So basically, instead of just having to pass, starting from our homepage, having our user data and passing it down into our user card and all the way down into our user details, we just use our user context to consume that state directly. So context allows you to consume state directly in components rather than needing to try to pass data around through props. And just to recap really quick for context, step one, you need to create your context using the create context function from React. Step two, you need to provide that context with some data that you want to share throughout your application. So in our case, we have our user data here, and we also pass our set user. And then we need to wrap our user context provider around any components that might need the value of that user context provider. We need to make sure to set it here in the value. And then step three is we just need to call the use context function, passing in the context we want to use. And that's going to return the values that we set in our user context provider or your context provider. And then you can consume that in any function you want to using this use context hook, passing in the context you want to use. And in our case, we just created this helper function here and this helper function here to make things a bit easier. Now, as promised, let's head to the React docs and let's just really quickly cover kind of what they mention here. So they say before you use context, start by passing props. If your components are not trivial, it's not unusual to pass a dozen props down through a dozen components. It might feel like a slog, but it actually can be fairly readable, and you can always kind of follow that data flow. So starting by passing props is not a bad thing. And sometimes your props might look a little bit ugly, but it's really not a bad thing. So you shouldn't always default to using context. And then also you can extract components and pass JSX as children to them. For example, maybe you pass data props like posts to visual components that don't use them directly, like layout post is equal to post. Instead, make layout take children as a prop and render layout, and then render the posts within it, and then layout. This reduces the number of layers between the component specifying the data and the one that needs it. And then if neither of these approaches work for you, consider context. So they mention use cases for context, using theming throughout your application, getting the current account. So this is going to be like the logged in user, what we just did. Routing, although a lot of routing solutions use context internally, but it is a use case for it nonetheless. And then managing state as your app grows. And then you might use context together with a reducer, which we'll cover in our next video. But if many distant components need to use that piece of state that you're using, then context might be useful. But just know that it's maybe not always the go-to solution. So here, a nice recap that I kind of covered as well, but context lets a component provide some information to the entire component tree below it. To pass context, you create and export it with my context is equal to create context, like we just kind of went over. Then you just need to use the use context hook from React and then wrap children into your context provider, providing a value to your context. So just kind of what we went over as well. So hopefully that kind of helps understand context in React. We will do another example here where we set up a reducer with context. Context can be pretty tricky, but once you kind of do the whole setup process a few times, it becomes much, much easier. In my previous React video, we covered using context, how to set it up, how to create a context, how to use it within your application, how to create like helpful helpers or helpful helper hooks when using context. But today I want to show you just an example of another common pattern that you'll see with context, and that is using context with a reducer. So we have this very simple application. You click login, it just hard codes this name that they're logged in. We go to a different page here. We can see this user is logged in. We go back, they log out. We see they're logged out, so on and so forth. So in this app here, we're managing this context with a reducer. So let's go to the code, and very similar to how we've done in the past, I'm not going to go through all the details here. If you want to know how to create context and use it, check out my last video on using context in React.js. But effectively, we set up the different types right here for our user state and our user action. I also have a specific video on reducers that you can see as well. And I'm not going to hit all the details here. I'm just going to kind of go over this pattern that you'll see. And then we set up our initial state for our context. We call the create context function from React with our initial state. And then also, as a second argument to create context, we pass a dispatch prop, which right now is just a function that returns null. And then here we create a reducer, just like you create any other reducer, where we have our state and our action arguments. And then it has our switch case here on our action.type. And then it returns different state based on the different actions that we have. And then we create a user provider component, which accepts children, because this user provider will of course wrap around any components that want to use our context. We call the useReducer hook from React. We pass in our useReducer, our initial state, and of course that returns our state and dispatch items within an array here, just like any other useReducer call. And then in the user context.provider, as the values, we pass both the state and the dispatch here. So we're just using kind of basic React functionalities of context and this useReducer hook, but then we're just passing the state and dispatch as the value of our user context provider here. And then below here, we have this use user context hook that basically just calls the use context hook from React and passes in our user context. So when we want to use our user context, all we need to do is call use user context within a certain component. Then within our layout, we wrap our user provider around our children, which is effectively going to wrap around our entire application because this is our root layout here. And then within our different components, our home component, we call use user context, we destructure state and dispatch. And then for logging in, all we need to do is call dispatch with a type of set user and an appropriate payload. Of course, in a real application, you would not just hard code the name and email here. It would be what the user actually types in. But for our example here, this is going to be just fine. And then for logging out, we just call the dispatch function again with a object or an action with type reset user. And then within our profile page, all we want to do is read the state of the use user context. So we just say const destructure state, call use user context, and then we use that right here and right here. So very similar to how we used context in our previous video, but this time the main difference is when we want to set our state in our context, we just call our dispatch function here because we set our context up using a reducer here. So I just wanted to show you this common pattern that you'll see. I personally tend to not go to a reducer until I really need to, just because there are, kind of extra steps and extra code that's added here. But sometimes you will find, like, if you have a lot of different cases here where you are going to be setting state based on different user actions, that tends to be a good time to use a reducer. Or if it's a more complex state, so maybe it is a user piece of state, but instead of just having name and email, you have name, email, ethnicities, demographics, address, like a lot of different stuff. Okay, at that point, it might be a good idea to use a reducer rather than trying to manage all that with use state. But this is a pretty common pattern that I wanted to show you, and you can just pass the state and dispatch as values here into your context provider. But just know that this isn't necessarily like better than just using use state. It tends to be kind of more of a, okay, using state or using the use state hook here within context is getting a little bit too complex. Now I'm going to go use the reducer because there's, several different cases here or user actions that they can take, or it's more complex state that you're managing. So hopefully this video gives you a good idea of kind of this pattern. It's just using context and reducers and combining those into kind of this pattern. Understanding refs in React.js. So this video, we're going to kind of do a quick overview of what refs are, using refs versus just using state, when you should use refs in your React applications, a couple of best practices, and then we'll kind of get into some of the technical details of how they work, as well as an example here. So what are refs? Well, I like to think about them as more of a last resort to hold on to values that aren't used for rendering. So you won't need them often, but when you do, they can be a kind of a useful escape hatch to maintain mutable values across renders. On the refs side of things, you're going to call the useRef hook with an initial value, and then that is going to return an object that has a current property with your initial value. So a ref, you call the useRef hook just like you would with the useState hook, and you call it with an initial value, but instead of just returning that value as well as a setter function like useState does, it's going to return an object that has a current property, and that current property is going to contain your value of that ref. Whereas useState, as we've covered in previous videos, accepts an initial value, but then it returns an array where you have your current value and a setter function. So value, set value. But a ref just returns an object with a current property that points to the ref's value. Now, one of the biggest differences between a ref and state is that a ref does not trigger re-renders when you mutate your ref. So if I use, my ref.current is equal to some new value, it doesn't trigger a re-render of your page. Whereas state, when you call the set state function, it does trigger a re-render of your page, which is a key difference there. And it can get you in trouble if you don't really understand that about refs and you try to use them. This is also why it's important to not use refs for rendering or to read values during rendering. And we actually kind of say that right here. Avoid reading or writing during rendering. And that is because if you try to read a value during rendering, well, if you change the value of that ref, it's not going to be re-rendered, which means that if you try to read that value during rendering, that value is not going to be updated to the page like it would with state. Because state you can read at any time here. But refs, if you try to read a value during rendering and you try to present that to the page, it's probably not going to get updated like you think. Now, refs, they are mutable, so you can modify and update the current property, this property here, of your ref. Whereas with state, these should be treated as immutable, where you use the setter function to modify the state value without mutating the piece of state. What are some situations where you would actually use refs? Well, if you're storing timeout IDs, that would be a good use case for using a ref because it's a value that you're probably not going to use within your page, your rendering page, but it is a value you want to maintain across re-renders. So that would be a good option for refs. Storing and manipulating DOM elements. I'll cover this in my next video, but this one is a very common use case of refs that you'll see. Storing other objects that are not used for rendering. So again, if you're not going to be using that object to show the user something, well, this is where you might use refs. And then choose refs if the value doesn't impact rendering logic, but needs to persist across renders. So very similar to what we've kind of covered already. Now, a couple of best practices: avoid overusing refs for core logic or data flow. This just kind of comes back to refs are more so like a last resort, and they shouldn't be used as like a default behavior that you try to do. And they should not be used for like your main logic, nor should they be used for data flow. It's just maintaining values across renders, but values that you're not going to use for rendering, and it's not really used for kind of core logic or the data throughout your application. Avoid reading or writing ref.current during rendering. We discussed this already. If necessary, use state for predictive behavior. A little bit more on how refs work. You import the useRef hook from React, and then you can pass it in initial value, just like you would with state. It's going to return an object. So we're saying const myref is equal to useRef. So it's going to return an object to myref, and then myref is going to have a .current property that is going to contain your initial value. So if our initial value is 0, and then we use myref.current plus equals 1, it's going to set that .current property to 1. But let's look at this a little bit more with an actual example in code. So if we go to VS Code here, this is a running application that I created. If we come to VS Code, you're going to see we have this refs page, and I set up a counter using state and a counter using refs to just kind of show you how you don't want to rely on refs for rendering logic. We have our state counter, which is just counter and set counter is equal to use state. And then here we have our counter ref is equal to use ref, and we set it to 0. And when we increment our counter ref, we have to go counterref.current. We access the current property on our return value of useRef here. Counterref.current plus equals 1. And then for our increment counter state, we say set counter is counter plus 1, but we should actually, to do things the right way here, we should pass in a function here, and I should say prev count, and then we should set it to prev count plus 1. As when you're setting state based off of the previous state value, this is just a better practice here to pass in a function, so you're always guaranteed that previous value here. So our set counter, we call that here, and then we also have our ref counter. And if I scroll to the bottom, you're going to see that in our example here, we have our counter ref. We just access the counterref.current to show the count for our ref counter. And then for our state counter, we just show the counter state value. clicking on the state counter, we see it works exactly how we would expect. But if we click on the ref counter, then I am clicking on this right now, you see that it's not incrementing the count. And the reason for this is because when we click this button and we call this increment counterref function and we set the counterref.current plus equals 1, this does not cause a re-render. So a React page doesn't re-render when this state is mutated, which means that this counterref.current is also not going to change, which is also why I kind of harped on it in this video. You don't want to use refs for rendering purposes here. So rendering out this to the page, you don't really want to use ref data to do that. Because if I come back and now if I click increment state counter, it is going to re-render and we should see this count over here update. So I click on it and you see my ref counter is now updated to 6 because I clicked on this 6 times before, which it did increase my ref value, but it didn't re-render until I actually caused this state change right here. So let's do it again. And then I'm going to trigger a re-render by using my state update. And we see it gets updated to 11. So hopefully that makes it clear why you don't want to use a ref for rendering logic like what we're doing here. We're trying to use that value within our actual JSX rendering. That's kind of a no-no here. And you just want to use regular state so you can have reactive state updates like we do with our state counter here. So just to kind of recap here, refs are somewhat an escape hatch or a last resort to hold on to values that aren't used for rendering. You won't need them often, but when you do, they can be quite helpful to maintain mutable values across renders. For refs, they work a little bit differently than state, to where you still call the useRef hook from React with an initial value, but it returns an object with a current property that represents the current value of your ref. It doesn't trigger re-renders when you change it. It is mutable, so you can modify the current property, just like what we do here in our example where we modify counterref.current. We mutate that directly here. That's okay to do with refs, but you should avoid reading or writing during rendering. So as I showed in the example down here, this is not going to work out very well. Using this during the rendering, it's just not going to get updated as you might expect. You should probably use refs if you're like storing timeout IDs, you're storing or manipulating DOM elements, storing other objects that are not used for rendering, or you need a value that doesn't impact rendering logic but needs to persist across multiple renders. Now you should avoid overusing refs, especially for core logic and data flow. And then, of course, like I talked about, avoid reading or writing the ref.current during the rendering process. So hopefully that gives you a good idea of refs. In my next video, I'll do an example of using refs with elements, as that tends to be a very common pattern for refs. But hopefully this gives you a really good idea of how they work, when you should actually use them, and how they differ from using state. So how can you use refs in React.js to gain access to DOM nodes or HTML elements? Well, that's what we're going to cover in this video. And then towards the end of this video, we're going to cover a kind of word of caution when it comes to using refs in React. But the example that we're going to use here today is we have this section element. I've gained access to this element using refs, and then we're going to call that element dot scroll into view when we click on this button here. So as you can see, I click this button and it scrolls this element into view. Now this is just one example of using refs to gain access to an element. There's several different things that you might use this for, but this just kind of goes to show how you might use refs with your DOM elements. So let's actually look at the code for this. It is pretty straightforward here. In my previous video, I go over kind of an overview of how to use refs and an example of doing so, and additional kind of words of caution with using refs. But here, what we do is we just call the useRef hook. We add our type annotation here because I am using TypeScript here. And then we give it an initial value of null. That's going to return into section ref here an object with a current property. Now, the kind of key here to using this on HTML elements is that for your element, you can add an attribute that is called ref. And then you can set your variable containing your ref to that element. So here on the section that we want to scroll into view, I just say ref is equal to section ref, which matches my section ref constant here. That is the return value of calling the useRef hook. So useRef returns an object with a current property, and then we set for our section element, ref is equal to section ref. But if we wanted to kind of track this P element, this DOM node, we could totally do that as well. And we would just say ref is equal to, instead of section ref, we might say para ref for paragraph ref or something like that. So you can set a ref attribute on your different elements, and that is basically going to mean that your current property is now going to represent this section DOM node here. So we can see I'm console logging my section ref right here at the top of the page. So if we come back and I open my console, we can see I'm console logging it here. It's an object with a current property, and you can see it is an HTML element. It is a section.h96 background gray 700. And you can see when I hover over it, my inspector highlights it here on the page because this ref is representing this HTML element, which means we have access to all this HTML elements, properties and values and methods that we can use. So you can see it has the inner text. You have reached the target section. You have reached the target section. So this just gives us access to this direct HTML element. So then quite simply, when I want to click on this button that says scroll to section, we pass in handle scroll. And then all I do here is I do a quick check to make sure that the section ref.current exists and it is an element. But then we just do section ref.current. So this represents the HTML element here. And then HTML elements will have a scroll into view method. And then we call that method, and then we just pass a behavior of smooth to kind of customize how it scrolls there. And that is exactly how we get this effect right here. So pretty straightforward when it comes to using refs with elements within your application. You just use the useRef hook like you normally would. And then for whatever element that you want to use or that you want to track, all you're going to do is use a ref attribute on that element and then set that equal to your ref variable returned from the useRef hook. And then that will give you access to that element. Now, of course, you could use this for different things, but let's kind of go over that word of caution that I mentioned earlier. And that is avoid changing DOM nodes managed by React. Modify adding children to or removing children from elements that are managed by React can lead to inconsistent visual results or crashes. And they showed an example here as well. I'll link this if you want to read kind of more about this, but it does say that it doesn't mean you can't do it at all. It just requires caution. You can safely modify parts of the DOM that React has no reason to update. For example, if some div is always empty in JSX, React won't have a reason to touch its children list. Therefore, it is safe to manually add or remove elements here. So basically what it's saying here is that, like in our example, that's fine to do because we aren't modifying the DOM manually with refs. All we are doing is using the method on the ref to scroll into view. So we're not like adding DOM nodes to the page. But what you need to be careful about is modifying the DOM manually using refs, especially if React might modify similar parts of the DOM. It can result in, like it says here, inconsistent visual results or crashes. So before manually updating the DOM with refs, I would definitely read through this section of the docs and just make sure that you're being careful about it and kind of doing it correctly and not potentially introducing bugs with using refs in manual DOM manipulations. So to end here, let's actually just kind of go through this recap that they have in their docs. So refs are a generic concept, but you'll most likely use them to hold DOM elements, just like we did in our example. You instruct React to put a DOM node into myref.current by passing a ref attribute to a certain element, just like what I showed you with my section element. Usually you will use refs for non-destructive actions like focusing, scrolling, or measuring DOM elements, like what we did. We used scrolling as an example. And then finally here, it also covers kind of what we covered earlier, avoid changing DOM nodes directly with refs that are already managed by React. And it says that if you do modify them, modify parts that React has no reason to update. So that is using refs with elements in React.js. Let me know if you have any questions below, but hopefully that makes things clear. This probably shouldn't be your go-to solution for everything, but in a large application, I think you will find yourself needing to use refs at some point for certain functionality. So in your React components, I think there are kind of 3 different types of code that are important to understand for professional developers. And these 3 different types are rendering code, event handlers, and effects. What do I kind of mean by these 3? So rendering code, this is going to be code that transforms state and props into JSX. So for example, we have this rendering code section of our page here. If we look at the actual code of this, all I mean by rendering code is that it takes either some state or maybe you have passed in some props and then it just renders out some JSX with that. So within both of these sections here, you see that there's really no event handler. So like I'm not handling any on click, on hover, nothing like that. There's no side effects occurring. It's just rendering out this JSX based on some state right here. Maybe I pass in some props and then I kind of have some logic to calculate what I want my rendered section to be. But that is just rendering code. And I would say that's going to make up the majority of your React components. It's just rendering out some JSX based on some props or state or some other logic that you have in your component. But outside of that, we also have event handler. And in this section right here, you can see that on this button, on click, we actually do some action. So event handler code is just code where you have functions that are triggered by user actions to perform side effects. So in this example, we have a button that you can increment a count. Then it has this on click event handler that just sets the count to and this is actually, it should be the correct way to do this would be prev count. And then what we want to return is going to be the prev count +1, just to make sure that we don't run into any issues there. But this event handler just handles this user action. If the user comes and they click on this button here, you see that it just increments the current count. And then we have the third type of code in your app, and that is going to be just effects. And we'll get into the useEffect hook here in later videos, but this is basically going to be side effects triggered by rendering itself. So side effects that aren't triggered by the user, pretty much. And this is used to sync with external systems, or a very popular reason to use effects is to sync with external systems. Now, what do I kind of mean by external systems? Well, here we have this section that's effects example. And if we come up to the top of this, we see we do use a useEffect, which if you don't know what this means right now, that's perfectly fine. My next couple of videos will be covering this hook because there are some complexities around this useEffect hook from React. You can see I import useEffect from React, but one way you might do this and one external system you might connect to with the useEffect hook is something like a WebSocket. So for my actual job, my professional job, we use WebSockets to push events to the front end. So for example, we have some processes that are going to load data, and these are background processes. So we kick those off with a user event on the front end. So we kick those off with event handlers. These are, links to this data. But after the user kind of triggers that initial loading of data, it's not like the user is going to trigger when the data finishes loading. So this side effect is going to be triggered by some external system. It's basically going to be triggered when our background process finishes loading that data. So what we do in our app is we send an event via WebSocket. We push that event to the front end saying, hey, this data has completed its loading. And then from there, we let the user know, hey, your data is finished loading. But that's completely from an external system. It's not like the user is triggering the event of data finish loading. So since that's the case, using a useEffect hook or using just effect code is going to be what we need there because it's kind of linking to some external system. Now, one caveat with your effects code is that they are typically used to kind of step out of normal React code and synchronize with external systems. So my example is WebSockets, but you might have other third-party APIs or widgets or other external networks that you need to kind of synchronize your app with. This is where effects are probably going to be a very common thing to use. However, even to this day, I see a lot of developers doing this. If your effect only adjusts some state based on other state, you might not actually need an effect. So for example, let's say instead of connecting to this WebSocket here, let's say, and with the useEffect hook, in this array that you see as the second argument here, you can pass values that if those values change, it's going to run this first function in your effect again. So let's say I just wanted to change some value based on my count. So like if my count changes, I want to change some other piece of state. I see people using effects for that all the time. But really, the useEffect hook can be a little bit tricky to manage. It can be a little bit complex. And a better thing to do is probably just like when the user increments the count, do your other logic of whatever else you need to do. Rather than doing that logic when the count changes via a useEffect, just when you set the count in your event handler code, also do the logic to update whatever else that needs to be updated. Because you don't really need an effect in that case. It's more so event handler code. And that kind of brings me around to the entire reason I'm creating this video is because we're going to go over the useEffect hook and how it works, but just know that there's kind of very specific cases where you need it. And there's also kind of poor patterns of using effects because they can be tricky. In a large application, I try to use the useEffect hook basically as little as possible. And I try to get away without using as much as possible. And if you understand the difference between rendering code, event handler code, and then when you might use effects, that's going to help you a ton in making your applications more scalable and really writing professional React code. So just know that before going to an effect, consider whether you can use just your event handler code to do what you're going to do in your effect. And like I said, you're not always going to be able to, because like if we're connecting to a WebSocket that is going to push background process events, there's really not much else we can do apart from using some sort of useEffect at some point to make that connection and to listen for those different events. So in summary here, 3 kind of key parts of your React code to understand is your rendering code. That is your most straightforward code. It's just going to take your state and props if you have them, and it's just going to return JSX. There's no event handlers or effects or anything like that. It just takes state and props. This is just pure code. There's no side effects to this code, and it just returns your JSX. Then you have your event handler code, which is code that handles user events. So the user clicking on a button and that triggers a function to perform other kind of side effects in your code, or the user hovers over a button or they click a link, different things like that. And then you have effects, which are side effects triggered by rendering itself, not by a user action. And these are often used to sync with external systems like WebSockets or other third-party APIs, different things like that. And just know that before using effects, consider if you really need them and if it might be better to just handle that effect within an event handler instead. And if you can get away without using them, I definitely think that's generally a good idea. So hopefully this video helps you out and gives you a better understanding of kind of the code within React components. But in future videos, we are going to cover the useEffect hook because, sometimes you definitely do need it. So today I'm going to give you the TLDR on how the useEffect hook works in React. So if we go to my application here, for this useEffect hook, in my previous video, we covered kind of when you would use this hook, where it's appropriate, when you shouldn't use it. And the summary of that video is that really you shouldn't be using this useEffect hook here very often. And as you can see, this is just a function that we import from the React library. It's very similar to how you import other hooks from React, like useState, useReducer, useRef, useContext. It is just a function that we import from React that allows us to kind of hook into some React features. Now, as I was saying, you really don't want to use this very often, and it's kind of reserved for situations to where you're kind of stepping out of normal React code. So in my previous video, we kind of covered where there's kind of 3 different types of code in React. You have your rendering code. That's going to be like this block of code right here. All it is rendering JSX. There's not really much else to it. There's no event handlers or setting state or anything like that. But then the second type of code is like event handler code. So like right here, we have this button and then we have an onClicked where we set some state. Then we have effect code. So, this is kind of an effect, but it's in a user event triggered that effect because you click the button and then you set some other state elsewhere in your app. It is kind of a side effect, but it's also triggered by a user event. But with effects, it's going to be stuff that you use to where you need to use like a side effect, but it's not triggered by a user event. It is triggered by some other external thing. It could be, you use a useEffect hook to connect to WebSockets, or you connect to third-party APIs, or maybe you have a chat in your application and you're waiting for, well, I guess this is just WebSockets again. You're waiting for that message to come through, or you're waiting on an event, something like that. It's not based on user events, and it's not just your normal rendering code. It's some other effect. That's where you're going to use these. All right, so try not to use these too much, but how they work is that basically you import useEffect from React, just like what I did up here, but it's going to accept 2 arguments. Now, right now, I'm only passing it 1 argument. I'm passing it a function as its first argument here. And that is what your first argument should be, is a function. And by default, when I have a useEffect just like this, it is going to run on every single render of my application. So you can see right now, it's just console logging the current count. If we go back to my app and open the console, you see if I increment my count, it console logs it, which you might think, okay, this is exactly what you might want. However, when you don't pass a second argument to useEffect, like I said, it's going to run on every re-render. So if I set some unrelated piece of state, like I do here, this random number setter, it sets this random number. When I click this button down here, it sets this different piece of state, which triggers a re-render. This function within my useEffect hook, it's going to run again, or it calls this function. Okay, so the first argument is a function to the useEffect hook that you can pass. And by default, React is going to call that function that you pass to the useEffect hook on every single render. So you can see when I click random number setter, it's not even related to my code within my useEffect. I console log the count. I don't care about the random number, but you can see this like number 6 here is going to keep going up. 7, 8, 9, 10, so on and so forth. That's probably not what we want. So how can you kind of control that? Well, the second argument to the useEffect hook is, so I'm going to do comma. This comma is after my function here that I passed into the useEffect hook. I'm going to do comma, and then you could pass what's called a dependency array. So it's basically saying like, okay, for your function that you pass in as your first argument, what dependencies does that function have? Or what pieces of state does that function depend on? Well, in our case, we only care about the count. We use our count right here. So what's the dependency here? Well, it's going to be the count. So you can put that in your dependency array. And now what React is going to do is it is going to run this useEffect hook, or the function, as the first argument in the useEffect hook. It's going to run that function. And you could also pass a named function here as well. I'm just inlining an anonymous function, which is probably how you're going to see this written the most. But it's going to run this function when this component mounts, so the initial render, or anytime the count changes. So if count goes to 1, goes from 1 to 2, 2 to 3, it's going to console log our count again, and it's going to run this first function again. However, since we don't put our random number piece of state in our dependency array, which we shouldn't, because our function doesn't depend on that or doesn't care about that at all. When we set the random number and it re-renders, it's not going to rerun this function, which is probably what you want to do. So normally you do want to pass a dependency array. And what you're going to see is when I increment it, you can see that it console logs the current count. But then when I hit this random number, it's not console logging the count because it's only going to trigger the recalling of my passed in function to useEffect when one of the values in the dependency array changes. Now you could pass multiple values here, and that's totally fine to do as well. But just make sure that, you shouldn't choose the dependencies. They should be things that your function actually depends on. So what I mean by that is I wouldn't want to set this up to where I'm rerunning this function when random number changes, because my function that I passed to useEffect here, it doesn't care about random number. It doesn't use it in any way. There's kind of nothing it does here that cares about it. So make sure that your dependency array or the values in your dependency array actually match what your function that you pass into useEffect depends on. Now you can use multiple useEffects in a single component. Something like this is totally fine, and all of them can have different dependency arrays, and that's perfectly okay to do. But like I said earlier, really you probably shouldn't have that. Maybe there's cases to where it makes sense, but for the most part, I like components that do not have useEffects in them. It makes it much easier to reason about. One other thing that you can do here with the useEffect hook is you can return a function from your passed in function that will run when this component unmounts. So for our useEffect demo here, if I go to a different page and we unmount our page component right here, that function is going to run. So in our passed in function, if we have a return statement and we return a function and then we, do something in this function that we return, React is going to call this return function here when this component unmounts. So if we left this useEffect demo page, React would call this return function from our passed in function, which is our first argument to our useEffect hook. A little complicated, but just know if you need to do something when your component unmounts, you go to a different page, return a function from your function that you pass in to useEffect. Now, when might you actually do this? Well, I know in my professional application, we do something like at the top of the useEffect, we might call a connect function to connect to a certain WebSocket. And then when we unmount, we'll call a disconnect function and do something like that. So connect to the WebSocket on mount. When you leave the page, we don't need to keep that connection going. We need to kind of clean that up. So we're going to return a function that is going to disconnect from that WebSocket connection. Now, let me show you one other example here. So, in your passed in function, you might have various logics. So like if count is greater than 10, then maybe here you could set your count back to 0 to reset it. And this will work, but there's a but to this. So let's first see that it works. All right, I'm going to increment this. I hit 10 and now it goes back to 0. So it's basically in this like infinite loop here. Now, what's the problem with this? Well, what are we doing here with our useEffect hook? We're actually responding to a user action, which is not what you want to do in a useEffect hook. Because we wouldn't need to use this hook whatsoever here. Let me get this random number out of our dependency array. We wouldn't need to use this useEffect at all. We could just do this when we set our count, when we increment it. We could check, okay, if this prev count is greater than 10, set it to 0. So let's go ahead and do this. I'm going to adjust this a little bit. By default, return prev count plus 1, but we can do if prev count is equal to 10, then we are going to return 0. And then we wouldn't even need this useEffect hook whatsoever, which is my favorite. So if you do this, we can see that we get the same effect here. We get to 10 and it goes back to 0. And this is much better practice than trying to use a useEffect hook for this to track some state and then set that state when that state is meeting a certain condition. Because like I said at the intro, This is user actions triggering the changes of this code. We don't need to use useEffect or effects for that type of action. UseEffect, like I said, is going to be something like connecting to a WebSocket. Like, I think the perfect example of useEffect is, okay, when our component mounts, and if you pass an empty dependency array, that is going to mean that you are only going to run this passed-in function to useEffect when your component initially mounts. When this component initially mounts, we're going to call a connect function and connect to a WebSocket. Maybe we pass in a certain channel name there. And then what we can return is we just want to disconnect from our WebSocket. So when it mounts, it connects it. When it unmounts, we return a function from the passed in useEffect, and it's going to disconnect. Now you might have other stuff like, on mount, you need to sync your app with an external API, like a logging service or something like that. That's another great example where you might use these. But just know, like, if you're ever like responding to user actions in a useEffect, you can probably restructure your code and do some better stuff. The TLDR here on the useEffect hook is it's a function that you import from React. 2 arguments are possible. One is mandatory, and the first one is going to be a function that is by default going to run on every single render. You can also return a function from that passed-in function if you want to run some code when your component unmounts. But if not, you don't need to return any function from your passed-in function to useEffect. And then the second argument is going to be a dependency array. It's basically going to be like, all right, for your passed-in function, what does it depend on? Are there any like state variables that it uses, or what does it kind of need to stay in sync with? You're going to pass those to your dependency array. Your passed-in function, it's going to run on mount, as well as anytime one of these passed-in values of your dependency array, anytime these values change. And for the most part, you're going to want to pass a dependency array to your useEffect hooks. Today, I'm going to show you 2 mistakes that are very easy to make in React that revolve around using the useEffect hook. And luckily, they're very avoidable mistakes. Now, if you're not familiar with how useEffect works, I have videos on how this hook works and when you might want to use it. So feel free to check those out because I'm going to assume some familiarity with this hook. The first mistake that we're going to go over is when you use the useEffect hook during a user event or an event handler. So in this code here, we have a button down below. When they click this button, we call this handle by function. And then what we do is we set a product in our state, and then we use a useEffect hook here to track when a product changes. And then it makes an API request when that product changes to effectively maybe make a post request to your backend to say user just bought a certain product. The kind of issue here is that when using effects or the useEffect hook, you don't need to use it when you're just like responding to some user action. That is kind of event handler code. You don't need to use effects for that. Effects are more so going to be to synchronize third-party systems. Maybe you connect to WebSockets, different things like that. You don't need to use useEffect when it's just responding to some user actions. So although this might work in some situations, I think you're just making things way more complicated than they need to be by setting a product. Okay, now the product has changed, so we put that in the dependency array. If the product changes, we are going to make an API call here to buy the product. Like there could definitely be bugs with this where what if they buy the same product twice, but the product in your array doesn't actually change and it doesn't get triggered again, or there could be a host of issues with this. And then also you kind of have to understand, like just tracking this code, it can be kind of tricky to understand where, okay, we call handle by, but all we do is set a product. Okay. And then when we set the product, what else is depending on the product? Okay, this useEffect hook depends on this product. So if the product changes and it isn't null or it is a truthy value, then we fetch this post. This can be far simplified to where in our more correct way to do this, we just handle all that code in our onClick. We trigger this handle by function, but then we just call this API endpoint directly in our handle by function. So we don't have to worry about state. We don't have to worry about a useEffect hook. We don't have to even know how any of that stuff works. It's just like, okay, the user clicks this button, then we make our API request. And of course, maybe you do have some state here, or when they click handle by, you pass in an argument of the product ID that they want to buy, and then you pass that along here. But in a case to where a user is just doing some action, like buying a product or clicking a button or hovering over something, some user action, that can often just be handled in some sort of event handler function like we're doing here, rather than trying to handle really anything in a useEffect. As really, useEffect is to kind of step out of normal React code when you like absolutely need to. And if you don't need to use it, I think it's best practice to not use it. So that's the first example. If it's user event code, just handle it right in that user event, right when the user clicks on that on click or on that on whatever action it is. Handle the code that you need to do right away directly rather than kind of indirectly through a useEffect. Now, number two is definitely one that I've seen before in production code, but say you have a list of data, or you have some data, and then you want to process that data in some way. So maybe you want to filter that list or sort it, or maybe you need to map over that list to remove some characters or make strings title case, whatever it might be. Well, one way that you might think about handling this after learning about the useEffect hook is that, okay, if you have this list of data, then if you want a filtered list, you can use another piece of state and then just use a useEffect hook to track your list. So if our list changes, then we are going to set our filtered list to a new filtered list based on this list. So if that sounds like a lot, we just have this list of data, and then we have a filtered list piece of state. Our useEffect is going to track when the list changes, our original list changes, and then when it does change, we are going to set our filtered list piece of state to our original list, but then filtering that in some way or processing that in some way. Now, again, this can work in a variety of situations, but it's just simply not needed. Like anytime you're using a useEffect to just change some state based on another piece of state, you probably don't need that useEffect. And again, if we don't need to use them, like as you can see, like just trying to explain that out loud to you of what's going on here is much more complex compared to in our after example. We have our list of data, which of course could be some state, or maybe it's some props that are passed to this component. But then we don't need to create another piece of state for this. We just can create another variable, just a JavaScript variable, const filtered list. And then we just do our filtering directly right here at the top level of our application. So we don't need to use a useEffect. We don't need to use a different piece of state. We just say, hey, okay, we have this list here, and let's just filter it directly and into another variable. And this is going to work just fine because, say we also had like a set list function and we were occasionally setting this list to something else. Well, when you set state, it's going to re-render the component. So it's going to reinitialize this variable here, and it's going to refilter the list and stay up to date. That's going to be perfectly okay to do because when this changes, it's going to re-render and we're going to create this new variable, refilter the list when it re-renders. So we are just deriving this piece of state here, this piece of data from some other state. And anytime you're doing that, you don't really need to use a useEffect. You can just do it directly like what we're doing here, rather than kind of indirectly doing it through your useEffect. So these are two common examples that I've definitely seen in professional code of, stuff that can work. Like I'm not saying like you're a bad developer or anything like that. If you write your code like this, I've probably made mistakes like this. But I just think this is a mistake because it's not necessary. You don't need to actually use effects here. This is unnecessary code here. It's unnecessary code here. You can greatly simplify both of these cases by handling user actions directly in the event handler and just handling that code directly, as well as just deriving a variable from your piece of state or from props, that's perfectly acceptable to do and much more simplified compared to, using useEffect, using another piece of state, and just making things a little bit harder than they need to be. This definitely isn't the only couple of mistakes that you can make, and I'm going to go over some more stuff related to useEffect because it is a little bit tricky. And just to kind of show you that I'm not crazy here, React covers this directly in their docs to remove unnecessary effects. For example, you don't need effects to transform data when rendering, just like our list example here. We're transforming this list data here while rendering in like the top level of our component. We don't need an effect for that. We can just do that directly right here instead of writing this effect code. And then also you don't need effects to handle user events. Just kind of like what the example I showed you, to where in our before button, we don't need an effect to handle this user event. We can handle that directly in the event handler function, because effects are really just needed to synchronize with external systems, not necessarily for kind of this stuff here. So there's a mistake that's pretty easy to make in React applications that involves using redundant state as well as useEffect hooks. And this mistake can kind of lead to less readable code, poor performance, and can just kind of open yourself up to bugs and errors. So in this mistake, if we look at the code here, what you're going to see is I have 3 pieces of state: first name, last name, and full name. And what we do is we have these 2 different inputs here, to where when the user types in the first input, we set the first name to the event.target.value. And when they type in the second input, we set the last name to the event.target.value. And then we render out a full name below. Now, the way that we generate the full name is basically the issue here, to where we use a useEffect hook. And then anytime the first name or last name changes, we set the full name to be a template string of the first name and the last name. So if we go back to the app, you can see if I change this here, you can see that it works just fine. It updates the full name based on kind of what we type in here, but this is just not needed, because a far easier approach here is going to be to remove this useEffect altogether, remove it from our import. And then instead of having this piece of state here, all we need to do is we could just say const full name is equal to a template string, where I can say first name and last name. And then if we come back, we're going to see that everything still works just as we would expect, and everything looks fine here. And to me, this code is so much more clean, just having this constant full name and deriving the full name from our state here, rather than creating a whole nother piece of state, compared to using our useEffect hook and kind of indirectly setting our full name. And this also has a minor performance benefit, because when the first name and last name are set, it's going to re-render this component and it's always going to keep this full name up to date. But if I Command Z and we go back to what we had before, what you're going to see here is that, okay, first name and last name, when they change, it's going to trigger a re-render, but our full name isn't going to be updated yet. So then we trigger this useEffect hook because first name and last name change. And then we set this new piece of state based on our first name and last name. So these trigger a re-render when they change, but then we trigger an extra re-render when this useEffect hook runs, and then we set the full name. So anytime these change here, we trigger another re-render to set the full name, which, in this case, it's not going to really be a noticeable performance difference. But in our improved version, all we have going on here is that when our first name and last name change, we just derive our full name from our pieces of state here. But when we set this constant here, it's not like it's triggering a re-render. We're just deriving this during the render process itself. So we're not triggering extra re-renders here as we were in our useEffect. This can lead to, in some cases, significantly improved performance. I think this is way cleaner, much more readable, and I generally like to not use useEffect hooks when you don't have to. So the take home here is that whenever possible, really try to pay attention to if you're using state variables when you don't really need to, or if you're using useEffects when you don't need to. And can you just derive a constant or just a normal JavaScript variable to kind of track a certain value rather than creating a whole nother piece of state for it? I'm going to show you a common problem that you can run into in React, and then I'm going to show you the wrong way to fix it, as well as, of course, the correct way to fix it. So the issue here is that often in a React app, you might want to reset the state based on some other prop or state value. So for example, say we have this comment section and user 1 types in this comment section, profile 1. Well, when they switch to profile 2, we probably want to clear out this comment section. And same thing when they switch to profile 3 and so on and so forth. And this is fairly common to where you might have an application to where your user can select different profiles and you want to kind of clear the state when they select a different profile, or maybe the user ID changes. So if we look at the code here, we have our profile page, and then we render a profile component and we pass it a user ID prop. And then in our profile component, this is where we manage the comment and set comment state. So one way that we could fix this, and this is going to be the incorrect way to fix this, is we could add a useEffect here, and then we could set comment back to an empty string once the user ID changes. So we could track the user ID. And if we do this, what you're going to see is if I type in this comment section and I change the profile, it does indeed change this. However, this is absolutely not needed and probably what I would consider the wrong way to do this. Now, it works, so it's not like it's a major issue, but it's more code that's needed and it can also lead to bugs down the road. You're also kind of triggering a double render here to where you're first going to render this profile page and it's going to have the previous comment set. But then you're going to see, okay, this useEffect is going to run. It's going to see the user ID has changed. And then it's going to set the comment back to an empty string. And then when you set state in React, it's going to re-render this component. So you're going to kind of get like a double render when you do this. And that can sometimes cause some issues as well. So a better way to do this here is actually super simple, but I think a lot of React developers don't really know about it. So let me get rid of this useEffect. And then all we need to do is we go back to our page component. And on our profile component, we can effectively tell React that once a certain value changes, we want to basically render a new profile component with reinitializing its state. And the way that you can do that is you can pass a key prop, and this key prop should be, okay, under what circumstance do we want to render a completely new profile component to reinitialize state? Well, if the user ID changes. So if we pass a key of user ID, when this user ID changes, we're effectively going to reinitialize this profile component, render a new profile component, and reinitialize the state. So we pass that key as a prop to our profile. So when that user ID changes, then this profile is going to basically be a new instance of the profile and its state is going to get reset here. And there's nothing else we need to do here within the profile component itself. So to prove I'm not lying, I'm going to refresh the page here just for good measure, type in some stuff. We're going to change the user ID here by setting a new profile. And you can see it resets the state. And this is a much easier and cleaner way to do this. And it's probably a little bit better for performance. It doesn't kind of trigger that double render that I kind of mentioned earlier with using the useEffect. And generally, whenever I can avoid using a useEffect, I think that's a good practice. So in your React applications, anytime you find yourself using a useEffect just to kind of reset state based on like a prop that you're passing, take a step back, see if it makes sense to take an approach to where you pass a key prop to just reset that state instead. And that's going to be a much cleaner way to do this. And this is something that I see all the time in applications to where they use a useEffect just to reset state. You don't need to do that. This is going to be a much easier way and cleaner way and more performant way to do this. One thing that you might want to do in React.js is adjust state when props change. Now, there's a problematic way to do this and a much better way to do this. And we're going to cover that here today. So if we come to VS Code, you can see that this is the page that I have rendered here. We see problematic using useEffect, best deriving state from props. We see that problematic using useEffect, best deriving state for props. So we have this application here and we render two different lists, our problematic list and our best list. So let's look at the problematic list here first. We pass an array of items to this problematic list here. And then we also have a piece of state here called selection and set selection. And then we basically use a useEffect hook to set the set selection to null when the items change. So what this looks like in our app is that if we, select a different item here and then we change the items, it basically deselects the item. We can do this again, and we won't even actually change the items here, but it'll just re-render the page. It'll kind of deselect the item. So this useEffect here, whenever these items change, it is going to set the selection to null. Now, what's wrong with doing things this way? Well, for one, it's going to cause unnecessary re-renders. This problematic list, it is first going to render to the page, and then this useEffect is going to run after this component mounts. It's going to recognize, okay, the items are now different from the previous items, so we need to set the selection to null, and when you set state in React, it is then going to re-render this list again. So we're going to kind of re-render this problematic list twice when these items change. And then also, sometimes you'll notice in your app that you'll get a component that it kind of has a flicker to it, meaning it renders kind of like some stale state first, and then that state gets updated. Well, this is one situation to where that would happen here as well, to where we're going to initially render this list display with the current selection, but then we're going to recognize that, oh, these items are different, so we're going to re-render the page and set the selection to null. So if you had like a component that took a little bit longer to render, we're not going to notice in this case because it's so fast, but if it took a little longer to render, you might notice the selection flicker a little bit. To where initially the selection is still going to be whatever we selected, but then it's going to recognize the items are different and it's going to re-render this component where selection is set to null. So you can kind of get that stale state effect. So this would not be the best way of kind of handling this. So a better way of doing this would actually be to derive state from props. So in this best list, we still pass our items array, and then we still have a piece of state here, a selection ID and set selected ID. However, we derive our selection from our selected ID as well as a prop. We check during the render process what our selection is. So rather than setting our selection using a useEffect here, so using an effect to do it and not doing it during the render process, we do it here during the render process to figure out what our selection is and then pass it to our list display. So when we set a selection, we just set a selection ID and then we derive that selection based on that selected ID and the items. The selection or the selected ID, both of them, are going to remain the same on re-renders unless that item doesn't exist in the new items array, which is probably the behavior that you want here. Like if you pass a new items array, but only one of the items are different, well, you might want the selected item to remain the same. And in this case, it would. So if we look at this behavior, I'm going to refresh here. Say I select apple or banana in both of them, and then I click change items. Okay, banana doesn't exist in this list, so that's what we want. But now let's select date in both and change items. And notice when I click change items here, it's going to set the items to date and elderberry by default. So the items aren't actually going to change. It's just going to re-render the components. So I do this, and you can see in the problematic way of doing it, it still resets the selection because technically speaking here, we reset our items to a new array of items. Even though they're like the same items, it's still a new referenced array. So here in our useEffect, it's going to pick up that that's a new list of items and it's going to set our selection to null. But here it's going to say, hey, our selected ID still exists in the items array. So we still want that to be our selection. And in this way, we are not going to have to trigger our unnecessary re-renders or our stale state because we are deriving our selection here during the render process rather than doing it within a useEffect here. So the take-home message here of this video is that anytime you find yourself setting state, so setting selection here, setting state in a useEffect based off of props, like what we're doing here, we're using this useEffect to track the items array and setting state. Anytime you find yourself doing this, just know that there might be a better way because this can cause unnecessary re-renders and sometimes that flicker effect of stale state. And in reality, you can probably structure things a little bit differently, like what we do down here, in which we have our selection and we derive that from our props as well as our piece of state here. When using React, you might be tempted to do something like what you see right here, where basically, say when a user subscribes, you want to show them some sort of like toast message or an alert saying they have subscribed. So you might create a useEffect hook in which when the isSubscribed state changes, you check if isSubscribed is truthy, you set this to you have successfully subscribed. And this is fairly common code to see, or at least see code like this. Basically, you track some sort of like user event with the useEffect and then do some other action with it. And here you can also see we use local storage to set an item when the isSubscribed changes here as well. So if we go to the running application, if I click subscribe, you see, okay, you have successfully subscribed, which can make this even more tempting to use because it sort of works when you start using it. But if I click OK, and then you see our subscribed content, so we could go to exclusive content here and see the exclusive content because you're subscribed now. But if we come back to the page, they are still subscribed. So this useEffect is going to run if isSubscribed is going to be true because they're still subscribed at this point and we stored in local storage, which might be what you want to do, or you might store this probably in a database actually, but we're just using local storage for this. But isSubscribed is still true. So it's probably going to alert again here, which is probably not what you want. So if I just go back, you see that it alerts right away. You have successfully subscribed. And it even shows it again here because it renders a couple of times. This is definitely not what you want. You probably only want it to show this subscribed message when they actually click subscribe. And that is kind of the root of the mistake here. You never want to use a useEffect to just track a user event. And a key point here from the React docs is that when you're not sure whether some code should run in an effect or an event handler, so whether it should be in a useEffect or like an on-click, on-hover, on-change, something like that, ask yourself why this code needs to run. UseEffects are only for code that should run because the component was displayed to the user, not because the user performed some sort of action. So do we want to save this to local storage and alert the user because this component renders? Or do we only want to do this when this user actually subscribes? Well, I kind of answered it for you. We only want to do it on the user action when the user actually subscribes. Because as you can see, we get several issues with trying to do it this way. Even if I just refresh, we get the message again, not the actual user experience that we want. So a much better way to do this is going to be if I just move this local storage into my handle subscribe, which my handle subscribe is going to be right here. When they click subscribe, we're going to call this event handler. And then we will also do it right here. But instead of just passing in it is subscribed, we'll pass in true when they do subscribe. and false when they unsubscribe. And then here we can move this alert to here as well. Just right in their handle subscribe. We can get rid of this useEffect altogether. And then I'll refresh for good measure here. But now if I subscribe, you see, okay, you have successfully subscribed. That's okay. And if I go to exclusive content and I come back, you see we don't run into the issue of showing it multiple times now. This looks good. If I refresh, we don't show it again. We can still unsubscribe. That's totally fine. I refresh. Everything looks good. We still get the alert. And this is just a much better user experience here. And it is much simpler code. We get rid of that useEffect altogether, and we just put our logic in our event handlers instead of basically tracking an event with the useEffect. So just remember, if you're going to want to run some code because of a user action, just make sure that that code is in a event handler function rather than in a useEffect. And if you find yourself using a useEffect for code that could be written in an event handler, that's probably a mistake, and it can lead to bugs and just generally more complex code. One thing that you might do, or at least see in a lot of React applications, is at the top level of your application. So maybe in your app.js folder, or even in an index.js folder, somewhere towards the kind of top level of your application, you might need to run some initialization code. So you might have a useEffect to where on mount, you initialize something. This could be some third-party library. You have to init some code for it, or it could be for authentication purposes, or whatever it might be. This is a fairly common pattern to see. However, React.js actually recommends against doing just kind of what you see here, running this useEffect on mount and not putting any other kind of checks in place. As if we go to my running application here, you can see that if I refresh my page, we see my console log actually runs twice here. So init something right here, init something. Now you might be thinking to yourself, isn't the useEffect only supposed to run once on mount? And while that is true in production, when you are running in development mode, in strict mode in React.js, it's actually going to run this twice. So as you can see, when I refresh, that's why we see this console logged twice to the page here. So there it is again. And straight from the React docs here, they mentioned that you might be tempted to place initialization code like this in an effect at the top level of a component. But since this is code that should only ever run once, Next.js recommends that what you should do instead is put some sort of flag within that code to make sure that it only runs once. So here they kind of create a variable outside of their app component, and then they will kind of check that flag here to make sure their code only runs once. So we can do that as well. I can create a let variable because we're going to change it. And I'll say initialized is equal to false. But then here I'll say if not initialized, then we are going to console.log. And this, of course, wouldn't be an actual console.log. It would be actual initialization code, but just for an example here. And then we will make sure to say initialized is equal to true. So now if we go back to the application, I'm going to clear the console and I refresh, we see we only get it one time per refresh. Now we don't get the double kind of render here. So adding this flag kind of protects against this code ever running multiple times. And this is kind of the recommended pattern from React.js here. They mentioned for functions that aren't designed to be called twice, you should make sure to kind of follow this pattern. Even if it's not remounted twice in production, following the same constraints in all components makes it easier to move and reuse code. If some logic must run once per app load rather than once per component mount, add a top level variable to track whether it is already executed. So in summary here, if you have some kind of top level code or even code within a useEffect that it really should only run once, not necessarily only when a component mounts, it should only run once ever, then adding some sort of flag like what we did here is the best practice coming from React.js there. Now, some stuff, it might be okay to run every time a component mounts, and you might not actually need this flag, but just kind of keep that detail in mind when you're authoring your code. And also keep in mind that in development mode, in strict mode, React will kind of mount the component twice, and that's why we see the behavior without the flag here. Hopefully this helps. Hopefully it provides some information you didn't already know. I'm sure a lot of you probably already knew this, and it's something that I've definitely done before. I didn't know that React necessarily recommended it straight in their docs to do it this way. So it was kind of nice to see that confirmed here. So an important concept to understand in React is which way data should flow. And to show you this, we're going to use this little demonstration here. And then also I'm going to link the React docs here to where basically it shows an example in which you have some child component using a useEffect to effectively send some data from the child component back up to the parent component. And then React mentions in React, data should flow from the parent components to child components. When you see something wrong on the screen, you can trace where the information comes from by going up the component chain until you find which component passes the wrong props or has the wrong state. When child components update the state of their parent components and effects, the data flow becomes very difficult to trace. Since both the parent and child need the same data, the parent component should fetch that data and pass it down to the child instead. And then they show the parent component getting the data from the API and passing it down to the child. So that's kind of the overall concept here, is that in React, if you find yourself in a child component trying to pass data up to a parent component, that's probably a mistake. And it would probably be much better to fetch that data in a parent component and pass it down to the child. So in the running application here, you can see we basically just have this product search feature to where I can search for different products here. And it basically does like a little bit of a autocomplete sort of search bar here. And then when looking at the code for this, you see we have our products page. And on our products page, we render a search bar as well as a products list. So this is our overall products page, and we have our search bar and this product list. Now, within our product list, this is currently where we are fetching our data, and then we are calling the set products with our data. So in our products page, we have products and set products. We pass set products into our products list component, and then our products list component effectively sets that parent data. So our products list, which is a child component, sets the products after we're kind of mimicking it, fetching it here, but you might actually hit an API to get this data. It sets the products within this useEffect, effectively setting the products in the parent component, and then it renders out the products list. And then the search bar is basically fine. It just functions like a search bar. But kind of the core issue is that the products list fetches the products and then sets them. And those are the products that are being set in the products page. And a much better way to solve this is if I go to my /products page, we have our products page here, but we actually just get the data here within the products page. So in this example of useEffect, if you're using Next.js, you could fetch this directly and you wouldn't need to make this a useEffect here. But in basic React, you're probably going to do this in the useEffect, and then we set the products on mount in that useEffect. And then all we have to do is pass the products down to our products list as well as our search bar. And then our products list is much more simple here to where it just receives the products and renders out the list. So now data is just flowing from this parent component into the child component rather than passing a function into the child component that is then going to set data in its parent component. Now, you can see that both of these work. Like this is our child to parent example to where you can see like the search bar works just fine. And if I go to /products, this also works just fine as well. Both of them have the same overall end result. But as React mentioned, when you start passing data from parent to child, it becomes much more tricky to kind of track that data and can just result in issues. So I know this is a pretty basic concept, but if you're newer to React, or even, I have developers on my team that focus on like Python, but sometimes they do some React stuff, and I'll see them sometimes doing stuff like this because they kind of understand how like useEffect works and stuff like that, but maybe miss some overall concepts of React. So hopefully this is maybe just a refresher for you, or if you're newer to React, hopefully this kind of helps you understand that if you are passing data from child to parent, it's probably a mistake. And the solution to that's pretty easy. Just fetch that data in the parent component and then pass it down to the components that need it. And generally, good rule of thumb is if you have multiple components that need data, then fetching that data from the closest ancestor to those components is probably a good idea. So, for example, if we had a component that was higher up than our products page, well, we wouldn't need to fetch our data in the products page parent and then pass that down to the products page and then pass it down to the products list and search bar. Products page is the closest ancestor to search bar and products list, and we could just fetch it in products page here. So in React, just make sure that data is floating from parent to child, and you should be good to go. A very common feature to have in web applications is some sort of search feature. So it could be, in our case, searching for a list of books and then showing those books to the user. It could be searching for a certain post and then returning the post that the user searched for. There's a ton of different reasons for having some sort of search functionality. But when having a search functionality, you can run into a couple of issues. And I'm going to cover solutions to those issues here today. So if we initially look at the search feature, I'm going to type in Harry Potter here to search for books, and it's going to query a API here. So if I type in Harry Potter, you can see that it returns a list of Harry Potter books here. And you might be thinking, okay, this looks okay. This looks like it's working. But if I open up the network tab here, I'm going to clear this out, and then I'm going to refresh the page for kind of good measure, and I'm going to clear my network tab. If I type in Harry here, but I type it particularly quickly, or at least even at a normal pace, so Harry, what you can see is that I make a search query for the H, the HA, the HAR, HARR, HARRY. I make 5 different requests here. Now, one issue here is that we're not really like throttling the requests. So we're making a request for every single time the user types in a character, in which one way to kind of solve this would be to only make a network request if the user has stopped typing for, I don't know, maybe 300 milliseconds or something like that, in which we would only probably make like one request here, which is probably something you would do. But that's not even the kind of core issue that I want to cover here. The core issue is that if you look at the timing of these requests, you can see that for the HA request, just based on like, network differences, and if you type in HA, that might return more books than typing in HAR. So that might return more results and might take longer for those requests to complete. And you see here, 885 milliseconds. Whereas HAR only takes 286 milliseconds. So there's a decent chance here that you're actually going to return the results of HAR before you return the results of HA. And you're kind of getting a race condition here. So I'm going to type in Harry again here, but watch how the results of my books, they look like very inconsistent. And I like get a bunch of different results being set for every character. So I'm going to clear this. And then if I type in Harry again, you can see my results are being set at a bunch of different times there. And it just looks honestly kind of janky, and it doesn't look like a very good user experience. Now, as I already alluded to, you could kind of throttle this where you only make a request after a certain amount of characters are being typed, or alternatively, make a request only after the user has stopped typing for a certain amount of milliseconds. And you still might want to do that alongside the solution I'm going to show. But what I want to show you here is a way that you can prevent this is if we look at our search results component, in which it has a query and it fetches to this API here, this free API, with that query to return the results, and then it sets the results right here. Well, what we could do instead is I could set a variable here called letIgnore is equal to false. And then when this component unmounts, I'm going to set ignore to true. And then if ignore is true, it is not going to set the results. And this comes from an example straight from the React docs that I will link to you, in which they kind of recommend you fixing this race condition in this manner. You set a flag, and then if that component is unmounted, meaning the query has changed, it is going to set this flag, and then you're going to make sure to check that flag before you set the results. In theory, if I type in Harry, well, for my H, for my HA, for my HAR, those are all going to get unmounted, and it's going to set ignore to true, and it's not going to ever try to set the results for those. So it's only going to try to set the results if the request is completely finished by the time this component unmounts. And that's going to kind of fix the issue of setting stale responses. So it's updating the results only if they're not ignored. And here, when it unmounts, we're marking the previous request as stale if the new one starts. So let's go look at the behavior here. I'm going to refresh the page here, clear my console, and then I'm going to type in Harry. And this time around, you can see that it only shows the results one single time here. Now it still makes the 5 different network requests here, which you could solve with some sort of throttling like I talked about earlier, only making a request if a letter hasn't been typed for like 200 or 300 milliseconds. But here you can see we fixed the issue of kind of the race condition, in which I'm only setting the results for when I search for Harry here. I am not setting the results for HA, HAR, HARR. And here in these results, you can actually see that I see the Harry Potter results. Towards before, when I wasn't setting that flag, I would actually see different results here for Harry, because actually one of my previous requests was finishing and still setting the results, which is definitely not the behavior you want. So it's important to be careful with your search features. Make sure that you're kind of handling this case where there could be race conditions. And then on top of that, I think even adding some sort of throttling is good, but I think you can use these both together, because say we throttled this to where we only make a request after a certain amount of milliseconds have passed. Well, if you look at the variation in some of these returns, like this last request took like 700 milliseconds. So say the user stopped typing after HAR and they just, had to pause and think about spelling Harry. Hey, who knows? They would make the request for HAR, but then if they stop typing after HARR and this request finished sooner, there's still a chance, at least, for some sort of race condition to occur. So I think using something like this to make sure you're not running into the issue is a good idea. So as a quick recap here, when implementing a search feature in React.js, you can get a race condition to where some requests are going to finish and set results prior to other requests. So here, if the query changes, we're going to kick off this request, but no matter what, we're still setting the results here, no matter when the request finishes. So in our case here, when I type in Harry, we're going to see a bunch of different set results occur, and it's going to look pretty janky. So I type in Harry, and you can see all these requests are kind of finishing and setting the results. And then we're kind of getting a weird result here when we just type in Harry. However, if we set a flag to ignore results when this component unmounts, so we use letIgnore is equal to false, we default it to false. And then if this component unmounts, we set ignore to true. And then we check here, if our component has unmounted, do not set the results. And then by doing this, it fixes that race condition. And now if I type in Harry, you can see that it only shows one single result here for Harry. And this result actually looks good. So it kind of fixes that issue here. And then just keep in mind, you could also have a pretty good solution here as well. Or in addition to this, you could add some sort of throttling to only make a request after the user has stopped typing for a certain amount of milliseconds. And that could kind of help prevent making too many network requests and maybe hammering your own server or something like that. How can you use custom hooks in React? And what are some kind of key points regarding custom hooks to consider? Well, first, let's look at just kind of an example of how you might use them and kind of what you might use them for. And then we'll kind of get into the key points here towards the end. So I have this example where I fetch data from the JSON placeholder API to render out a list of posts here. And then also if I click on to-dos, it's going to render out this list of to-dos. If I click on users, it renders out this list of users. So I have pretty similar logic in all three of these cases to where I'm fetching from the JSON placeholder API, but really the only thing that changes is the endpoint that I'm getting this data from. So when you have some logic that is similar and kind of repeats itself, you might want to turn that into a function, just like you would when using a function any other time in programming. You create a function that encapsulates some logic, so you no longer have to repeat yourself and you can just use that function throughout your program. That's the same thing you're doing with custom hooks in React. You are creating a function that encapsulates some React logic so you can reuse it throughout your application. Now, if we look at this example, our homepage renders out this placeholder list here. If we go to the placeholder list, you can see that here it calls use placeholder data, which is our custom hook. It passes in a data type, and this data type is set based on, in our homepage, what button we select. So if we select users or to-dos or posts here in this array, that's going to set the selected data type. It's going to pass that to the placeholder list, and then I'm going to call my use placeholder data custom hook with that data type to retrieve the data. And then if we go to our actual custom hook here, what you're going to see is that basically it's just a React function that uses or encapsulates some other React features. So it uses other React hooks in this function. If it didn't use like useEffect and useState within use placeholder data, well, you wouldn't need to create a custom hook for it. You could just create a regular JavaScript utility function and then share that utility function throughout your application. But since we are using other React features here, like useState and useEffect, well, in that case, since we are encapsulating actual React features, we want to create this in a custom hook. So basically, we have a async function here that fetches data from the JSON placeholder API depending on the passed in endpoint. It's either going to be posts, to-dos, or users to match our posts, to-dos, or users. We're going to check if the response is okay, do a little bit of error handling here, handle some loading state. But then if all goes well, we're going to set the result. And then from this custom hook, all we need to do here is we need to return information or data that we want to actually consume from this hook. So what would we actually want to know from this use placeholder data hook? Well, we'd of course want the data itself. That's kind of a given. But we'd also probably want to know the loading as well as the error state. So when I call this hook in my placeholder list component, I automatically destructure the data, the loading, as well as the error state. I check for those here, and then I render out the result. And the reason that this could be useful is, in this case, I'm only rendering one placeholder list component. So I'm not calling this use placeholder data custom hook several times throughout my application. But you could imagine that I could have separate places in my application that would want to use this hook and pass in either posts, to-dos, or users, or even any other endpoints to this URL. And then I could reuse this logic. We could even make this a little bit more general if we wanted, but you also want to be careful about not making these too general, as we'll get to that in just a second. Now, there are some key points to remember when it comes to custom hooks. So I'm going to go to my key points page. And the first key point is that custom hooks, as I kind of alluded to, let you share reusable logic. So instead of repeating logic in multiple components, you can extract it into a custom hook. For example, if multiple components need to fetch user data, you can create a hook called useUserData, so they all share the same logic. Now, even on top of this, I would say custom hooks, it's not only about sharing logic, but it's about sharing React specific logic. So sharing logic that needs to use other React features like useState, useRef, useEffect, stuff like that. Because like I said, if we didn't have any React features in here, so like other React hooks, we would just create a regular JavaScript function, and that would be totally fine to do. So you only need to create a custom hook when you are going to be using other React features inside that hook. Now, you need to make sure that you always call custom hooks in the top level. So custom hooks, they mimic React hooks to where A, they must be called in the top level, and then B, they also need to start with the use prefix. So here you see it's called use placeholder data. It is not called get placeholder data or something else like that. Custom hooks need to start with the lowercase use prefix, just like React hooks do. So it needs to follow the same convention of like use state, use effect, use ref, use placeholder data, use user data. It needs to start with that use prefix. And then from that use prefix, it's going to be JavaScript camel case. So similar to how use state is a lowercase use, capital S for state, kind of this camel case. It's going to be the same thing with like use placeholder data. And then it also needs to be called at the top level of your function. So similar to when you're using use state or use effect, we can't call this stuff after like any if statements or anything like that within the body of our component. So when we call use placeholder data within placeholder list, it happens right at the top level of our component here. It cannot occur below like these if statements right here. That would cause issues. It needs to be at the top level, just like any other React hook. So it mentions here, just like built-in hooks, custom hooks need to be called at the top level of another component or of another hook. You can call hooks within hooks, but they cannot be inside loops, conditions, or nested functions. For example, don't put use fetch data inside an if statement. It always must be called in the main body of the component or other hook. Additionally, custom hooks only share logic, not state. So each component that calls a hook gets its own isolated state. Hooks don't share state across components unless you use global state management. For example, if two components use a custom use counter hook, they each have their own independent counters. They wouldn't share that counter state. So really, custom hooks are meant for encapsulating logic. They're not meant to be like a global state management tool to where you're trying to like share the same state throughout your application. Like each component that uses your custom hook is going to get their own instance of individual state, encapsulated kind of state. You shouldn't be trying to use custom hooks to like implement global state management. You're going to use something like context, or you're going to be using some other global state management tool. I particularly don't love context, so I'd probably use some other global state management tool, but custom hooks are for sharing logic. Also, don't create overly generic hooks like use mount. Hooks should have clear purpose instead of like a generic runs on mount hook. Make one that solves a specific problem. For example, instead of use mount, create a use fetch on mount hook that fetches data only when the component first loads. So your custom hooks, they shouldn't be overly generic. They should kind of solve specific issues throughout your application. And then also with custom hooks, decide when to break logic into separate hooks. So similar to this one, it's kind of up to you how to organize hooks. If one hook is doing too much, break it down into smaller single-purpose hooks. For example, if a hook handles both authentication and data fetching, split it into a use auth and a use API custom hook. So split it into two. So you don't want them to be too general, and you don't want them to like solve too many separate problems within the same hook. It's kind of helpful to make them into their own kind of pure, reusable custom hooks. So to recap here, you can create custom hooks in React, but you need to treat them like any other React hook, meaning it has to start with the use prefix. It must be called at the top level of a component or another hook. So for example, when we call our use placeholder data within our placeholder list, we cannot call it after these if statements here. It would have to come before it. So it needs to be called at the top level of a component or another hook. And then in your custom hook, you're going to be using other React features or other React hooks If you don't use any other React features, you don't really need a custom hook for that. You can just create a regular JavaScript function. But if you do want to share some React specific logic, like use state, use effect, stuff like that, then you can create a custom hook to do so. Now, when doing that, you want to make sure that you create a specific hook. You don't make it too generalized. And you want to make sure that it's kind of solving one issue. So here we're solving the issue of just fetching data from our JSON placeholder API. But we don't make it too terribly generic here to where it's trying to solve a bunch of kind of unrelated issues all in the same custom hook. And then generally, I would say, don't get carried away with custom hooks. Like after learning this, it can be tempting to create a custom hook for like all of your React logic, but just make sure, just like with, putting stuff into JavaScript functions, make sure that you're actually reusing it in probably multiple places throughout your application, and make sure that you have like a really good use case for it, because it can be kind of tricky to track all of your custom hooks within your application over time, especially on a team of a lot of developers and a large application. You can run into issues like that. So I would say, they can be helpful for sure. And they do have their use cases, but they are kind of like an escape hatch, so to speak, to where it's like, okay, I'm really reusing this kind of same React logic over and over throughout my application. That's when you want to use this custom hook. Today, I'm going to show you how to solve a common problem that you're going to run into in React, and it's related to preventing unnecessary re-renders. And we're going to do that using the React.memo function. So if we go to our code example here, we have this memo demo component, and I'm technically in a Next.js app here, but I'm just using React.js here. But down below, you can see that we have this counter state, and then we have a button where on click, we set the count to the previous count plus 1. And then we also render this button component here. And this button component is basically just a button that will alert hello when you click on it. So if we come back and we click on this button, we see an alert of hello. But the problem that we're going to run into here is if you see this console.log for button rendered, we're just going to console log every time this button component, or, components are just functions. So every time this button is actually called, we're going to console log that. And what you're going to see is that when we re-render this parent component, that is automatically going to re-render this button component. Because in React.js, a component is going to re-render, or React is going to call that component whenever the parent component re-renders. So this memo demo component is the parent because it's rendering or returning the button component. So anytime memo demo re-renders, or anytime this button component has props or state that changes. But we don't have any state in this button component. And we also, the only prop that we pass it is this say hello as the children prop, and that's going to stay static. So really, there's no reason this button component needs to re-render when we re-render the parent component. But if I re-render the parent component by clicking on increment and setting this count, what you see is this button gets rendered, and you see a double console.log because I'm just in development mode here, so it's going to render it twice. But you can see that it's still recalling this button component, even though it really doesn't need to. And if this button component had some more kind of complex logic in it, or maybe this button component made a network request from it, or anything that could potentially slow down performance, this might be an issue. And you might need to find a way to basically tell React, hey, I don't want you to re-render this button component just because a parent component re-renders. I only want you to re-render the button component when its own props or state change. And that's exactly what we can do here with the React.memo function. React.memo is going to wrap the button component, and it will basically skip re-rendering it unless its props actually change. So it will basically check, are the props shallowly equal, as opposed to re-invoking it on every parent render. So it will do like a shallow comparison of the props. If the props are the same and no state changes within this button, then it's not just going to re-render it because the parent re-renders. So the way we do this is we import memo from React here, and I can just say const button is equal to, call the memo function, and then pass our entire component into it. So as easy as that, we basically just pass our function button into our memo function. That's going to return a memoized component that is only now going to re-render if the props or state within the button component itself change. It's not going to re-render if our parent component set state and re-renders. So if we come back, I clear my console, I refresh the page for good measure here, and now I click increment. We see it increments the count here, but it's not re-rendering the button. So this is indeed having the effect we're looking for. The button still works as planned and everything is working well here. So in React, if you want to prevent unnecessary re-renders of a child component and you want to prevent that child component from re-rendering when its parent component re-renders, then you can wrap that component in the memo function that you import from React. Now, I would say that you don't need to do this for every child component within your applications. Really wait until you have like a performance issue. And, in our case, you wouldn't really need to do this. But like I said before, if this button component was maybe doing some network requests or it had some more expensive calculations in it, and it was just kind of not the quickest rendering component, then at that point it'd be like, yes, this is a great component to memoize and make sure that you're not just re-rendering it when its parent component re-renders. Today, I'm going to show you how to use the useCallback hook in React to prevent a common performance issue that you may run into in your React applications. So what we're going to do here is let's look at the code here. And basically you're going to see I have this useCallback demo function. It has a piece of state here, count and set count. It has a function called handle click, which basically just sets the count to the current count plus 1. And then we pass that handle click to a button component down below. Now our button component above, it accepts the on click. And when you click on it, it's basically going to increment the count. Now I also have this button wrapped with React.memo. That's so it prevents unnecessary re-renders when the parent component re-renders. If you don't know how that works, make sure to check out my very last video I did on React.js. But effectively, it's going to make sure that our button component is only going to re-render when its props or state change, which kind of takes me right into the issue. We still have an issue here to where for our handle click here, we're just initializing this function every time the useCallback demo function re-renders, which means that every time useCallback demo re-renders, we are going to create a new instance of this handle click function and then pass it as a prop to our button. So every time it re-renders, we are then going to also re-render our button because the prop is changing here. We are technically passing a new reference to a function every single time our useCallback function re-renders, which means that if we come back here and I click increment, you see I console log button rendered. And you see it double console log because I'm in development mode here. But we have this button rendered console.log. So every time I click on the button, even though this function is technically staying the same, since we are reinitializing a new function here every time useCallback demo re-renders, we're actually passing a new reference to a function here for the on click, and that's going to re-render our button component every time we click on this, which in most cases is actually fine, and it's not a performance issue. But you could imagine a world where maybe our button component is an actual pretty complex component, and maybe it makes network requests, or maybe it has some more expensive computations. Maybe it just doesn't render all that fast. Well, in those cases, if you're passing a function as a prop, you have to be really careful about, are you passing a new function every time the parent component re-renders? And is that going to cause issues in your application? So the way that we can fix this, and the way that we can prevent passing a new reference to this handle click function on every re-render, is by using the useCallback hook. So we're going to get rid of just this inline function that we are going to reinitialize every time we re-render the useCallback demo component. And then we are going to use the useCallback hook. So now I'm saying const handle click is equal to calling the useCallback hook that we import from React here. So import useCallback from React. And then for this useCallback hook, we pass a function, and this function will set the count to the previous count plus 1. And then basically we need to tell the useCallback hook as a second argument to it, when do we want it to reinitialize this handle click function? Well, for us, we want the function to always just set the count to the previous count plus 1. So we don't particularly care about anything other than just making sure that we don't reinitialize the handle click function. So we just pass an empty array. If our handle click function had dependencies and we wanted to actually reinitialize the function when some other variable changes, then we would put it in this dependency array right here. But this way, we're only going to initialize this handle click function once, pass it to this button. So now our button, it's wrapped in the React.memo, so it's not just going to re-render when the parent re-renders. And then also the prop of onClick, it's going to maintain the same function reference. So it's not going to recognize that the props are changing. So by just clicking the increment button, we shouldn't be re-rendering this button component here. So if I clear my console and I refresh for good measure here, and I click increment on the button, you see that we no longer get any console.logs. And that's because, like I said, we're no longer passing a new instance of the onClick function every single time into the button. We're passing it the return value of our useCallback hook, which is basically saying, I want you to make sure this function stays stable. I don't want you to recreate this function every time the useCallback demo component re-renders. And then that prevents this onClick prop from changing, and it prevents us from re-rendering this button component. So in summary here, anytime you're passing a function as a prop, you might have to think about, okay, do I care if this component that has that function as a prop, do I care if that component re-renders when the parent component re-renders? If you don't, then great, just pass it as we did initially. But if you want to make sure that you really prevent unnecessary re-renders in that component, and maybe it's a more computationally expensive component, then it's a good idea to make sure for that function that you're passing in as a prop to just pass in the return value of the useCallback hook. And then the first argument of that useCallback hook is going to be a function in which you do the logic that you originally wanted to do. And then the second argument is going to be a dependency array, basically telling React when you want to reinitialize the returned function. And then this way, that prop is going to remain stable, and it's really only going to re-render the component that you are passing it to when you actually want it to, not just when the parent component re-renders. And likely, you might have to use this in combination with React.memo, because without React.memo, this button component is still just going to re-render by default when its parent component re-renders. So hopefully this was clear. Hopefully it helps out. Let me know if you have any questions below, and I'll see you in that next one.